you can say, I'm going to, if I measure the weight change, if I measure the weight at this latitude and I measure the weight at this latitude, there should be this X percent of weight change based on this formula and the fact that the globe is a circle with this, and it has this much mass, blah, blah, blah. That's all related.
Yeah, I can come up with, dude, I can come up with all kinds of unicorn stuff and all kinds of mass attracting mass stuff with the mass underneath. That's not the point. The point is,
Prince Harry.
somebody's hot micing or something.
Harry urged William.
Daryl, you're hot micing.
He's gone.
You can come up with all different kinds of things. He left. You could come up with all different kinds of things. If your experiment is just going to be to go go see the effect, measure the effect over and over again, and then come up with something that you did not test for, that you maybe have another good idea on things, or maybe that's it, maybe it's not, whatever, or it matches the math, that's irrelevant. I can make math match math all day if you want unicorn math or math attracting math.
That's the problem, Jeremy, because you would have a point. You would have a point, but that's not really true, right? Because you can say that it's these other variables, and you can measure the magnitude and relationships of those variables, and then they should predict your experimental result when you measure the mass or the weight at the two different locations. Unfortunately, those other variables that you're fallaciously appealing to, called the possibility fallacy, they do not predict the correct percentage of weight change. Yeah, so that's a problem.
What he's basically saying
it could be a combination of multiple things. The point is, no, hold on, extremists. Jace came in to save you. You guys aren't going to tag team me up in here. This isn't fight the flat Earth and McToon. Okay, thank you.
McToon.
So McToon. Yeah. So yeah, you could have a multitude of other things that could predict it. You could come up with some very clever math. The point is, if your experiment is to just go measure the effect over and over again, and then come up with something that you didn't test for as your cause to the effect, you think that's how it's done, Jace?
But what you're saying it's fundamentally not true, or else other people would have already came up with that clever math with all these other variables that affect it, be them flat earthers or not.
It's a fallacy. I don't know the name of it, what you just said.
Yeah, it's called the appeal to possibility fallacy.
The thing you just said, yeah, it was a fallacy.
No,
anyways,
the thing you're using.
No, the thing you just said was a fallacy. Anyways, the point is,
no,
is that how we're gonna do science? Is that how you want to do science, Jace? You want to just go measure the effect over and over again?
We certainly do not say that it could be any. Jeremy, we certainly do not just say, "Oh, it could be anything." I can just make up random math that doesn't work, but it could be this. That's not how it works.
Okay,
man.
Jace. Okay, but is that how we're moving forward with science in the future? Is we're going to have an effect, then we're going to measure the effect a whole bunch of times in different places. Then we're going to say, okay, that's the experiment was measuring the effect over and over again in different places, and then just come up with the cause of the effect, something that we did not check for, that we didn't do nothing with. That's how we're doing it.
Well,
You're doing it
out
of order. You have the wrong order.
This is how Bob, the science
don't
guy,
think
told me to do
that's
it.
what Extremistus was saying. I think he's saying
this is how Bob
predicted values are these predicted variables, which is the mass, and it's going to change the weight. Before you do the experiment, you're going to calculate the percentage weight change based on those variables. Then you do the experiment and you check how close your predicted values were to the measured values. I think that's what Extremistus is saying, and I feel like I'm stepping on his toes now, so I'll let him explain.
Yes, that's what I mean. When I say you're doing it out of order, basically what
I'm not doing it out of order. I'm doing it the way Bob. Can we not do the McToon fight the flat Earth shit show tag team thing we're trying to do here? So what Bob's the science guy. He's actually got science as his name, Jace. I don't know what you do, but this guy is obviously a higher ranking science than you because he has the Ed in his name. Anyways, he told me that what we're going to do is to get the effect, weight change with latitude change, and we're going to measure the effect at multiple different latitudes, then that was the experiment, was us measuring it and Earth rotates out of that. That's what you guys are cool with, coming up with a cause to an effect that we did not test for at all.
I mean, I think that there is some, whether that's what he said, he might, when you were asking me if I was fine with it, there's some steps that are sort of skipped in there, whether they're implied or purposely skipped. But here's the thing. Okay, so if I'm doing this, me, a non-scientist, as opposed to Jeremy, an actual scientist, if I'm doing this, and basically you come up with a formula, the math, whatever, and you say, at all of these latitudes, your weight should be this. And there should be some sort of plot. I mean, you should be able to plot that graph. I mean, it should be kind of a linear plot or whatever, some sort of plot. There should be a graph to it. Now, you have the math, you have your sort of theory behind it. The math says this because the Earth is a globe and it's spinning this speed with this mass. This is the plot of your weight change right here. Here's the graph. Okay? This is what the graph looks like. And now, if you actually go and do these measurements and measure the weight at each latitude, and the weight at the latitude matches the graph, then that is how you say that, that's evidence that your theory is correct. Whether it's proof, that's sort of a philosophical argument, but that's evidence that your idea is correct if you have a graph and the experiment matches the graph. Basically, that's sort of the short answer.
And the last part would be you would also plot out graphs for other variables that can be conflicting things too. Well, I'm just going to add this last little piece, right?
Okay,
because you should also have a graph of the other variables that could be involved, like pressure, energy, or wind, or fairies, whatever kind of variables you want to say. You should have the graphs of how they would affect it, plus the combination of those variables all combined in different ways, and then you should check that against the experiment and see which one matches. And of course, it's going to be the mass that matches the actual experiment.
Okay, like I said, yeah, great. Like I said, I'm not doing a fight the flat Earth back-to-back shit show where you guys will never let the flat earther talk. If you guys want to have a one-on-one, let me know.
We were letting you talk. I thought we did okay.
Yeah, I was just adding the second part where you
I wanted to
eliminate
respond to
conflating variables.
Said, I didn't need nothing added to. I didn't need anything added. I wanted.
Well, then you're responding to only half the story.
I already had enough. He waffles on and you waffles on. What am I supposed to respond to? Something you said or he said? Like, what's up? Like I said, if you guys want to do a one-on-one, let me know.
Well, if I was debating someone, I would want the full story to respond to, not just half of it.
The problem is I'm not debating someone, I'm debating some two people. Yeah, I know, but I'm not debating someone, I'm debating some two people.
It doesn't matter. I would respond to 8 people if they were giving me the full picture.
As long as you have the time to respond and the opportunity, I mean, I don't see what difference does it make. If we get 30 seconds and you get 30 seconds and everybody takes their time.
I don't even remember what I was going to respond to for you now. The first thing that I had.
I don't know.
Because he was talking about the graph. You have an equation for how the mass will affect it. Gives you a graph. The experiment matches the graph. Respond to that part.
Dude, I'm not doing the fight the flat earth McToon back-to-back double team shit show. Like I said, if you guys want to have a one-on-one, let me know. Otherwise, I'm not doing that.
It's a conversation, and everybody has their part of it. As long as you get your opportunity, then what difference does it make?
It makes a difference, dude, because I know this tactic that you guys do with this. I'm not playing into this game anymore. I'm done with it. This shit ain't even, it's borderline worth even talking to you guys at this point. So I'm definitely not doing this.
It's a conversation. There's no tactic. I I skipped a step, he added a step, whatever. There's no whatever.
Well, at the end of the day, you haven't isolated a cause. You're just making an extrapolation from the observation of an effect and fitting it into a model that you've decided to believe for whatever reason, but you haven't actually isolated the cause of it. So therefore, you really don't have the cause. You just have a correlation.
Well said, Gio. Well said.
I mean, that's, okay. So it's correlated to the mass and the rotation and the actual mathematical function. There's a correlation there. Now, until and unless somebody can give us a better correlation, why wouldn't we go with what we have? I mean, this graph matches our prediction at each latitude. So why is it that it's not true unless there's something better we can come up with? I mean, we can't just say, we don't know, so we're not going to do anything about it until we know something else. I mean, nobody's come up with Nobody has come up with something else. This is what we're going to use.
Depends on how high of a quality of truth discernment you have and how you decide to navigate that. If that's how you want to do things, I'm just going with the thing that might not be true. I guess that roll with it if that's your thing. That's not how I want to do things. But
I'm going with what we have the evidence for until we have something that provides better evidence or is more likely and is a better description in terms of not only does it describe this, but it describes other stuff that we might have questions about. That's what I'm going with.
And that's kind of what I was hinting at with the second part. You're also eliminating these other possible isolated causes. So you know that they're definitely not these things because they would give different predictions. But you do have the thing that does seem to be bang on. And that's a pretty good evidence for your hypothesis being accepted for the provisional time being. Because people saying that your hypothesis is not correct and that's not the truth, they don't have the truth either, or else they would propose the truth and it would match experiment much better than your original hypothesis does. So they can claim that they're truth-seeking and they know the truth better than you, but in reality, they're leaps and bounds behind the person proposing the hypothesis that actually matches the experiment.
Witset's always going off about it being electrostatics or something kind of like that. And okay, the problem is and I think he's kind of hinted at this before, but how would you prove that, or how would you devise an experiment that would either confirm that by giving you statistical analysis or whatever, or would say, hey, if it is electrostatics, we should get this result, therefore, and we don't get this result in the test, therefore it's not electrostatic. You either prove it or disprove it. Or I guess you can't really prove it, but you can give the evidence for it, or it can disprove the theory. And, if it's electrostatic, there are some ways to test that idea, and they would either provide the evidence or they would disprove it in terms of weight change with your latitude. And I don't think there's any way you can correlate weight change with latitude based on any kind of electrostatic idea. Because I don't know that if weight changes with your latitude, electrostatics must somehow change with your latitude. And how does that work?
Well, bulk matter is electrically neutral, so the whole thing doesn't make any sense. The electrostatics are holding the bulk matter together, but they're not on a magnitude magnitude large enough to have influence outside of that matter, or else if they were, the object would be charged.
And that's kind of how you, you confirm, or I shouldn't say you confirm it, but you provide the evidence that your idea is right. Like I said, if your idea, you make some predictions based on whatever idea you propose, typically based on the math, by the way, and then you kind of graph out those predictions based on all the changes to whatever variable you're doing, and then you test it. And if your graph matches the graph of the actual experiment, again, that's evidence that you may not be correct, but you're at least on the right track.
How does may not be correct and at least you're on the right track? How do those work together?
Well, I'm just saying
it's not correct. It's not correct, and you're totally on the wrong path. You're not even close.
I mean, what I'm saying is that depending on how, within your experimental error and how much does it match the graph that you've predicted, I mean, if you're off by 5% at each step, maybe you've got an idea, but maybe there's some variables you didn't account for. Or that, for instance, maybe gravity is a little stronger, a little weaker, whatever. Maybe the mass is slightly different. Maybe you didn't, in the case of Earth, maybe you didn't estimate the mass right, whatever. I mean, there's some slight variables, but I mean, if you're off by 5% at this point and you're off by 30% at this point and 10% here, you're probably got to refine your idea or throw it out altogether. And again, it could also come down to some part of experimental error, or, I mean, and the whole thing about science doesn't prove anything is there's always some possible unknown variable that we don't even know about.
Right. Well, it's just surprising to me that some people that, like you said, just go with the thing, whatever it may be, without actually having like 100% proof of or like validation of the cause of whatever it may be. To me, like I was thinking like almost an analogy, like let's say there's a mountain and just, like it's just an analogy or like a symbolically, let's say the top of the mountain is the truth. That's the one single pointed truth of the matter. And if you're like halfway up the mountain and there's like a theory that some men made up and then they say that is what it is, and another theory of someone else says something else, until you get to the actual truth, if you're really discerning to find truth, why would you quote unquote just go with something that isn't the truth? Like, it's surprising me that you wouldn't be more skeptical and be like, well, you know what? These men over here are telling me it's this. It does seem to correlate in certain ways with their model and with what they're saying, but I don't have the truth yet. I don't know for sure yet. So I'm going to be skeptical of them until I get to that. But instead, it's like this demonic possession thing where people just decide to in my opinion, it is, just to go with the deception, even though it really isn't even validated. Then they'll come online and try to debate and defend and do all these different things to try to do that, where it's just kind of a surprising psychology that one would do that.
Well, in the case of, say, general relativity, it's pretty accurate for most of what we observe in the universe. And I mean, if you even use here on Earth, I mean, you can use more simpler methods, Newtonian stuff, but Einstein and general relativity are pretty accurate. But there are cases in the universe where we can observe that this does not work. Now, it doesn't work, let's say, in the case of black holes. We're not going to throw the whole thing out because it doesn't work in black holes and it works everywhere else. That's kind of silly. The idea is that you have to refine it, or some sort of extension to it, or improve it, so that not only does it explain most everything, but it also explains black holes. I mean, if you can come up with a whole new entire idea, start to finish, completely scrap general relativity and start over, and it would have to do just as good as general relativity does on the whole, and also explain black holes. Then we can go with that. But until we have something that's as good as general relativity, then we're going to go with that until we come up with something better. And that's kind of what I was saying about they just go with it. Well, like I said, general relativity is pretty good for most of the universe. So we go with it, even though we do know it's not the full and complete explanation.
Right. Then why are you, that's my point. If you're really discerning to find truth, why are you just going with something that men made up and told you? That was my original kind of comment.
And my point was, if we're not going to go with this, let's just kind of take that opinion. If we're not going to go with it, we got to come up with something else that does what we already can predict and do and measure. And not only does it has to do just as good as what we do now. If it can do just as good as what we can do now, then we can go with that instead. And then we've got two sort of competing theories. And there are a number of theories out there that kind of compete with general relativity. The problem is a lot of them either are not testable or the predictions they make are, that's generally the cases. They're just not really testable with current technology. And so it's hard to say whether these other competing ideas are right or wrong. And most of them are not competing in the sense that they start over. Most of them are extensions of the current theory. I mean, you can say it's wrong, that's fine, but to just say it's wrong and just leave it there, where does that leave us? Gravity is wrong, okay? Now what? What do we do now? How do we make any predictions on the universe if we say gravity is wrong?
Well, when you're saying, I mean, there's a whole bunch of things you're bringing up. I mean, if you're talking about the universe, what are you talking about? This outer space place that somebody made up as well? Because then you're assuming that that's true. So it's believing in these other people's model that even exists in the first place. So it's sort of like debating the parts of a fairy tale. So I don't know, man. That's getting into a whole nother realm of unverifiable, unvalidatable claims, and then there are theories that fit into that unverifiable medium that they're claiming even exists at all. So that gets into a whole nother. But I mean, the thing is, like, you're like just going with it, even though it isn't actually been validated or isn't true in all cases. But then you're criticizing, in the case you were criticizing Whitsitt for having something that you don't think he validated. So why are you going with the men that told you one thing versus the man Whitsitt who told you another thing? I'm not saying you should go with either. I'm just saying, why are you like degrading Whitsitt on one level and then of his theory or idea, and on another one you're backing these other guys? Like, what did they do to get your trust? Like, what did those guys do?
Well, I use these ideas like general relativity, special relativity, quantum field theory, and the such every day. So I know their validity, their accuracy, and their limitations as well. Whereas Whitsitt's ideas don't work for anything. Whitsitt's ideas wouldn't help me at all in any of the experiments that I do, either in my lab or in the field. They have no applicability, no practicality.
So if you don't see any validity in thinking outside of the mainstream model, then what is your goal of being here, being in these discussions?
We do think outside of the mainstream model. It's just we shouldn't be so far, have our brains opened up so far that they just fall out. When something's clearly wrong, we should accept that, and we should move closer to the truth and discard those incorrect ideas.
So then that's why you're here, is to figure out parts that are not true about the mainstream and figure out what's going on?
Sure. In some cases, I like hearing people's ideas. Who doesn't?
It's not.
I think a lot of quantum and relativity stuff was jacked from the original ether concepts and ether understandings that happened, I think, before there was a massive reset in the 1800s. So I think that a lot of that is true, but it doesn't, because they've jacked it from the actual ether math originally. So some of the stuff you're working with may be accurate. It just isn't quite in the model that they're selling.
It's not just about. I mean, if you're thinking outside the box, that's great. But what are the practical applications? How do you test those? How do you put that stuff into use? And he was just saying he uses that every day. He uses that in his job, the current theory. So if you're going to have some other idea, you've got to show how your other idea is useful for current applications, current technology, and how can you build on it? What are the proof? Prove it and then extend it. Show, you got to prove it with science and then engineer stuff that makes use of that science. It's not, we have practical things that make use of quantum field theory, electric dynamics, the speed of light. There are things that we use and build and every day. Literally the internet, fiber optics, microprocessors. All of these things make use of these ideas. You can't just say they're not true. You can, but you've got to come up with alternatives and then show practical applications of those alternatives.
And another part too is that, like, during, when we're in school learning about these things and the history of how these models and theories have come about, you learn about, the chemists learn all about the models of atoms that don't work. You do experiments that show where those models were correct and where they failed, and it shows you the reason as to why we had to go from, like, the plum pudding to the orbit model to the quantum mechanical model, et cetera, et cetera. And so you learn where these older ideas, why they were accepted at the time, their use at the time, and then you learn and you experiment with their shortcomings and why we have to use the modern ideas, the hypotheses that have been, developed and expanded upon.
So then how do you use relativity in your work?
Well, with something like a synchrotron or a cyclotron, we accelerate electrons to relativistic speeds using magnets, and we have to know where the radiation coming off of those electrons goes. And there's different predictions from when you're using a non-relativistic model compared to a relativistic model, so that we can focus the X-ray beam into a beam that we can then send out biological materials like proteins and nucleic acids to determine their molecular structure. All of that requires an understanding of relativity. There's also examples like mercury being a liquid at room temperature, gold having the color it has. The standard quantum mechanical models that don't take into account special relativity don't give you the correct kind of wavelengths for the color coming off of gold. It predicts that mercury should be a solid at room temperature, but we know in reality mercury is a liquid at room temperature. We know that gold has this gold yellow color when we look at it. And relativity, when you incorporate the equations of relativity, you come up with the exact wavelength that you measure from gold's emission spectrum, and you come up with the mechanism for why mercury is a liquid at room temperature.
Okay, so in your general framework of life or possibilities, could all of that be happening on a stationary planar Earth? Is there anything about anything you just said right there that requires a spinning globe in outer space?
Those two specific things Hang on, my dog's barking at another dog. I'm sorry. For those two specific things, no, you don't have to be on a globe. You don't have to be on a flat Earth. The shape of the Earth doesn't really have anything to do with it. But when you take those as not being in a vacuum and all the other effects of relativity, like when we make muons in a particle accelerator, they only have half-life like 1.7 to 2.2 microseconds. But somehow, when we measure that they're created way up, 100 kilometers in the atmosphere, and then that they can be detected down here at the surface, even when we create them up there using instruments at those heights, and then detect the muons that we've created, the only thing that can predict that happening is relativity.
If the magnetosphere was closer to us, could we make things float? As in like repel or something like that? Some type of magnetic thing to keep it up there?
Yeah, they can be being repelled by the strongest magnet in the universe. Still, they shouldn't be reaching the surface. That doesn't help the case. They can travel, I think it's something like 100 times the speed of light. So we could be wrong by 100 times for what the speed of light is, or just that velocity number. And they can be traveling at that speed. They still shouldn't be reaching the surface, regardless of how you want to make them travel that speed, whatever variable. They should not be reaching the surface, but they do, and that's a problem. So when we take into account these effects that are from particle physics and cyclotrons and synchrotrons, and then chemistry effects like the mercury and gold thing is talking about, there's plenty of other kind of chemistry effects that special relativity contributes to a lot. Then we take into account these muon things. Then we also move to things like the precession of Mercury. Even if you just want to call it a light in the sky, it's just rather peculiar that special relativity somehow with just it's basically one or two equations really, predict all these effects. And it's not plausible to me to argue that all these things are just like a coincidence and it's really something else that's going on.
So
it's just not how reality works.
I kind of thought sometimes that the Hadron Collider was kind of built in another way to kind of replicate our realm. If we were in a Orlando Ferguson mapper, which is at the bottom, the Hadron Collider in ways would replicate our universe, wouldn't it?
Well, the types of particle accelerators I was talking about before, they're not like the Large Hadron Collider. These are particle accelerators. They accelerate electrons and positrons around, and they're primarily used for like biological and nano scale material engineering and figuring out the structure of those molecules and atoms and whatnot. Whereas the Large Hadron Collider is more to explore it's to create the energy scale, sending protons and things like heavy iron nuclei around to create collisions that are on the energy scale of what's thought to be of the early universe, so that we can kind of understand how the forces reunite under certain symmetries, like the electroweak unification, and how the physics changes in that sense. So it's a different task between like a synchrotron or a cyclotron in the Large Hadron Collider.
But am I right in saying that they use vacuums in all these experiments?
Yeah, they certainly, any kind of particle accelerator has to use a vacuum, otherwise he'd be colliding with, regular gas molecules at these relativistic speeds, you'd have a big mess.
But I guess let's just say, for example, if I wanted to replicate, or if there was a replication of what we knew about space, and let's say we all agreed and knew that space was made out of hydrogen, for example, would we then try and replicate all these things about the beginning of the universe in a hydrogen environment, or similar?
That's a good question.
Well, I'm kind of confused as to what you, because like space is made of hydrogen. Like it's not like it's just a steady background.
Well, it's a basic sugar, isn't it? Or a carbohydrate, some might say. A carbo and a hydra and an 8, whatever 8 is, maybe the infinity symbol. But the carbohydrate is pretty much makes up quite a lot of space, if I'm not correct. Or if I'm not mistaken, whatever the thing is. So a lot of carbohydrates in space. So trying to replicate something in a vacuum when space is not a vacuum, it might be an absence of oxygen, but it's not an absence of anything else.
So one
depends
thing
on what part. Go ahead, extremist.
Well, to me, the Large Hadron Collider is more about the energy levels produced. It has less to do with the atoms and the molecules and all that. It has much more to do with the energy levels involved in not only accelerating whatever they're using, but the collisions and the energy levels that produce, and then the whatever's given off, you measure that energy that's in the collision, before the collision. You measure the energy after the collision, then you add up all the little parts. And there's some discrepancies there, and that's kind of what you're looking for.
Yeah, but I'm thinking
it's about using these collisions to create these high energy scenarios and checking how particles behave under those kind of physics, things like the W and Z boson and the Higgs boson, and regular just leptons like electrons and quarks and whatnot. They're not leptons, but how they behave as well. But to get back to the space isn't made out of carbohydrates, nor is it made out of hydrogen either. It depends on what carbohydrates are biological molecules, and they have been found on meteorites and in the spectra of certain stars and planets and stuff. But depending on the region of space you're talking about, there can be, one hydrogen atom per every 15 kilometers. Right, so there's these big, huge, empty regions where there's no atoms, no hydrogen, no nothing. And that's what the things that the LHC are trying to replicate. But even those regions at a much higher temperature, when the universe had a much higher overall temperature than it does today.
Yes. I was just about to say that if you change the temperature, the effects at that pressure, for example, can take that atom and make that atom a lot bigger, but still weigh the same. So it just takes up more surface area, perhaps.
What I mean by temperature is the energy scale, because temperature is a macroscopic or an emergent thermodynamic property of a huge collection, a statistical ensemble of molecules. So when we're talking about space with hydrogen, one hydrogen atom per every 15 kilometers, what we're talking about is the energy of space. And so when you put enough energy into these hydrogen atoms, they start to break down. They turn into their consistent electrons and quarks, or just the nuclei. Then you add more energy, and the nuclei break apart into just the 3 quarks separated from each other. And so the LHC is testing the physics when those things happen, how the quarks act, how electrons act, how the atoms came together in the first place, things like that.
Yeah, but the whole thing I was trying to get at is that we're doing experiments in a vacuum, but yet nothing we experience or possibly could experience involves a vacuum. Therefore, trying to create the origins of the universe and stuff like that, assuming there was a vacuum, is just part of the problem that I've got. It's not, it might present a picture of something, but there's nothing that we know of that replicates naturally.
And well, there's like I said, we can put, a bunch of energy into either groups of hydrogen atoms or a single hydrogen atom and split it into its constituents. We can see that it will break apart into its electrons and its quarks. And so at some point, it'll come back together. When we stop inputting that energy, it'll come back together. And that's the same thing that had to have happened, in the early parts of the universe. And that's what the things like the LHC are looking to explore. Because the CMB tells us that there was a point where protons and neutrons captured electrons. That's what the CMB was released from that event.
I think Ron might be failing to realize that the point of the vacuum in the LHC is to isolate the observation and the event. So, like you're saying, like they have, there's these incredible energies that happen when they collide, but in order for them to to know what they're looking at or to isolate that one event, is important that it's otherwise a vacuum in there.
Yeah, it's twofold, because obviously if it wasn't a vacuum, then you would have the protons or the iron nuclei just slamming into all the gas molecules in the collider. But it's also because space is primarily a vacuum. Like, it's not 100%, but like I said, one hydrogen atom per 15 kilometers or so, and that's at current day. Back in the day, there was no hydrogen atoms. It was just the constituent parts. So it was a total vacuum. There were no gas molecules or atoms around. So that's what it's trying to replicate. But on top of what Kosha said, you wouldn't be able to do it if you have a bunch of gas molecules in there that the protons are slamming into.
I mean, here's a novice example, because I'm not a scientist or anything. So you've got the experiments where you've got a tray of water, a bowl of water, you've got a pint glass, and you've got a floating candle. You light the candle, you put the glass facing down over the candle, which is floating on the water, and it exhumes all the air, and it sucks up the water, right? In that situation there, is there a vacuum? There's not, is there? It's just exhumed the.
It's not it's not a perfect vacuum. It's like a lower region of air pressure, basically.
I could make the flame 10 times bigger. It will suck up more water. I don't know how much more. But then, is that closer to a vacuum?
Again, you're never going to reach like a full vacuum, because it's a chemical reaction that's occurring. So the oxygen molecules, the gas molecules in there, are just being converted into a different kind of gas molecule, usually carbon dioxide, which has a lower partial pressure, which allows the atmosphere to push the water up further into the cup. But you're not really creating a vacuum, you're just lowering the partial pressure inside the cup, so that the difference in pressure between the atmosphere and the inside of the cup is it's bigger, so the atmosphere can push the water up further. But there's still gas molecules floating around in there. It's not a vacuum.
Yeah, but the atmosphere isn't necessarily fighting against those remaining molecules. Therefore, there's no, the pressure is actually quite weak in there, because it compensated by sucking the water up. Now, if it didn't suck the water up, then the glass would break, wouldn't it? Because it would get so hot so quickly, because it hasn't got a dampener, because it's used up the dampener of. I don't know what I'm talking about, but it's just novice talking here. But the point was that if you've got the sun and all these fiery things going up in space, they obviously are burning off other things which need other things and other things that we can replicate on Earth. Everything, like if pretty much everything in space is everything on Earth, then pretty much it's all one and the same, isn't it? But to assume that there is a vacuum, it could be a liquid, it could be a dense form of shitloads of hydrogen or anything. I don't know. It's got to go. The exit's got to go.
Well, that's where the problem comes in between yours and my thinking, I guess, because in normal science, and I verified this doing spectral measurements myself, we know that the spectral signature of empty space is not a liquid, it's not a superfluid, it's not a super solid, it's nothing crazy like that. It's gas molecules extremely dispersed from each other with empty space, nothing but the quantum vacuum basically in between them.
Hey, Jace, can we talk about superfluids for a minute? Just because I know that you have a better understanding of, quantum mechanics than really most of us.
Yeah, I can try.
I mean, I don't know how familiar you are.
My exact expertise, but yeah, I have some familiarity.
Well, we made a superconducting. We made a superconductor in school, like the simple ones, like the sapphire wafer, and it's covered in some other shit, and you just put the liquid nitrogen on it and freeze it, and you get like that magnetic property. We made one of those in school, but sometimes we talk in here about superfluids, and sometimes they bring up how superfluid medium could be the explanation for why the moon stays up, and all these things are silly for several reasons, like the temperature and there's things like that. But I know there is an actual scientific hypothesis about the vacuum. I forget what it's called, but it's something to do with it's like a superfluid vacuum or something like that. I don't know if you've ever heard of this hypothesis. It's like vacuum fluid or something.
Sorry.
I may have. You gotta give me a little bit more details, because I've heard a lot of kind of like quantum superfluid, but not made of regular atoms, like superfluid made of the quantum vacuum. Basically, I've heard a lot of those kind of hypotheses. So
let me see if I can find the name of it.
But the problem with the whole superfluid space, space being made a superfluid thing, is superfluids give off a characteristic spectrum, and that's not what we see from space. On top of the problems with the temperature and the pressure, none of that makes any sense.
Actually,
it's not what we see.
That's actually what I wanted to ask you specifically, because you brought that up. Is what does that entail? Because I've never heard of that. What would that spectrum look like, or behave like? I guess would it look anything
gas
like?
Molecule. So if you're doing an IR spectrum or a Raman spectrum, gas molecules, you have a collection of gas molecules and they're bumping into each other, and that changes what the spectrum looks like compared when you have just like an isolate of very minimal gas molecules in the IR spectrum, or even liquids and solids. So if it was in the superfluid state, you wouldn't expect the characteristic spectrum of a gas. You shouldn't see like the hydrogen, the normal hydrogen IR or Raman or microwave or UV, whatever kind of spectrum you're doing. You shouldn't see that. You should see what's called the bosonic spectrum of the superfluid. They have a characteristic spectrum, because the atoms in the superfluid are so close to each other, bumping into each other and exchanging energy in their rotation and vibrational and translational modes. And that would be apparent in the spectrum. It would change if you have a superfluid of helium, it would change the wavelengths that you would get in a normal helium gas spectrum compared to the superfluid spectrum.
Okay, and can you just because I've heard the like description before, and I think I understand it, but when they say that like a superfluid, when something's in a superfluid state or even superconducting state, they say it's like they share quantum state. Is that true, or is that correct in saying that? What does that mean?
So what it is, it's kind of complicated, but for the most part, that's true. Like what's happening is when you have helium atoms, in a normal situation, they're fermions. They're made of fermions. And the Pauli exclusion principle says that fermions can't occupy the what's called the same energy level or the same state. And so that's why you have, like in a atom, you have one electron in an orbital. You have one electron that's spin up and one that's spin down, because they have to be in different states. They can't be identical, because then you'd have no way. If they were both spin up in the orbital, you'd have no way to distinguish between the two electrons. So they have to be one spin up, one spin down. And there's some more complicated stuff called the spin statistics theorem, which is what really that all derives from. So when it comes to superfluids, what happens is they transition. They have a transition temperature where they transition from a fermion that can't be in the same energy level. No two helium atoms can be in the same energy level. They transition to being a boson, where bosons can be in the same energy level. Whole groups of bosons can occupy the same energy level. And so that's what the superfluid is. It's all these helium atoms go from occupying like a statistical ensemble of energy levels. They all, at the transition temperature, they all drop down to the lowest energy level of the system. They all are in that level.
Right. Yeah. So, okay. So I've heard of, like, there's been claims of room temperature superconductivity, and there's definitely like higher temperature superconductors than others. But for a superfluid, I know that helium has to be like much colder than, colder than a vacuum, even like colder than the vacuum of the space outside our planet. But is there any, just because you said it has to be at the lowest energy state. So is it possible for a superfluid to be at higher temperatures than very close to absolute zero?
Well, it's all defined by what the lowest energy level of that system is. So when it comes to superfluids, typically if you have light atoms like helium and hydrogen and stuff, they can be, their lowest energy level, their ground state energy level is extremely cold, we'll say, in this sense. It's extremely low energy. But superconductors and things like that, these come from metals, which have band gaps. They have band gap energy levels, and those are way, way hotter per se. They're way, way higher in energy. So the lowest energy level for that system is at a much larger temperature than a superfluid's lowest energy level.
So I guess it's kind of fair to say that like there's like a correlative, like there's like a relationship between the different boiling points and melting points, and even what do they call it? The something temperatures, critical temperatures or whatever for superconductivity or superfluidity is like, so basically it's like a metal, right? It's going to be very, very high temperature for it to become a liquid or gas. But for it to become solid, it's again, a higher temperature. Whereas like helium, it's basically almost, you have to have extreme pressures to make it like a solid. If I don't even know what the pressures would be, but the even to get it to become a liquid, it's extremely low temperatures. And so I guess the superfluidity is also extremely low temperatures. I guess
yeah.
Yeah.
It's all related to the mass of the, the objects in question, like helium and hydrogen. They're, like extremely low mass. Like hydrogen is like 1.008 grams per mole. So like 6.022 times 10 to the 23rd atoms of hydrogen only weighs about a gram. And helium, it's the same thing. 1 mole of helium, only 4 grams. So they're extremely light. Whereas metals, things like lead and gold and silver, these are, on the order of 100 grams or so for a mole of them. So the energy scales involved in those things are much different.
Okay. Yeah, it's just interesting because, like I said, that comes up sometimes in here, and the only thing the only thing that I ever could add to it is, to say that the moon's in some sort of superfluid medium because there's helium up there. The temperatures up there are already hotter than you need for superfluid helium. So, but I guess there's other problems too.
Yeah, especially for something like the region of space in between us and the moon, it's even much higher in temperature than there's the intergalactic medium kind of regions. So those are like it's like 2.7 Kelvin or something like that. Whereas the region between us and the moon is at a much higher temperature because there's a bunch of gas molecules that are up there moving around providing energy. And also to get these kind of superfluids and whatnot, you need kind of like pure samples, whereas the region in between us and the moon, there's all sorts of different gases. There's hydrogen, there's helium, there's CO2, there's water vapor, there's nitrogen, there's oxygen. So you don't have like a pure sample to kind of make it a superfluid. So it just doesn't really work out.
Right. I think superfluid helium requires like 2.1 or whatever above Kelvin.
Yeah, it's some crazy low temperature, depending on because there's also like different kinds of superfluid helium as well. There's like superfluid helium 3 and superfluid helium 4, and those even have different like phases of being a superfluid between them and stuff that occur at different temperatures and pressures, and they're all like extremely
Well, they say the coldest temperature ever in the universe was witnessed here on Earth, created in the lab, which is interesting. But
just kidding. But the like an astronaut spacesuit is meant to withstand like negative 250 Fahrenheit. Like dry ice is negative 105 or so, and you can get quantum locking with that. So I don't know.
Yeah, because that's superconductivity. That's superconductivity, which
I'm just talking about
different.
It's a separate thing than quantum superfluid, whatnot you're talking about. But I just mean the demonstratable version that we may be able to see, just with dry ice, can occur with something where a magnetic field is present. That's all. Thanks.
Yes, Jace.
Feel free to dismiss me. Thanks.
Just real quick, Jace. What exactly? Because I understand that one's a fluid and one's not. But what exactly are the similarities and the differences between a superfluid and a superconductor?
Well, it has to do with viscosity versus electrical conductivity. In a superfluid, the atoms can, move with each other, move past each other with almost no frictional collisions. They can move basically as one solid mass. There's no viscosity to it. In a superconductor, the electrons inside the band gap, inside the bands, the energy level bands of the metal, they can move with no electrical resistance.
Right. Okay. But it's the structure, the atomic or the molecular structure of the material will still keep its shape. So it's basically like they both exhibit the same like zero viscosity or sort of zero resistance, but one's based on the electron moving through the crystal, like through the atom basically, or through the molecular structure, and the other one's just based on the entire atoms or molecules moving past each other. Zero viscosity.
Yeah, one's in a solid, so like the atoms that are composing the superconductor are hang on one second, sorry.
Well, I think I get it. That makes sense.
Yeah, so levitation, quantum locking doesn't require superfluid, all right?
Well, no, a superconductor, to get a superconducting magnet, you have to put the superconductor in a magnetic field, and so to give it that magnetic like that magnetic property, basically, like you have to actually freeze it when it's in that magnetic field, and then it'll maintain that same orientation or whatever.
Okay.
But a super fluid is one that can move freely in the medium. But a superconducting magnet, you'll still need to put it in a magnetic field, for it to.
I'm going to come up with some more concrete examples. It seems like it might be just like a little too gooey to get into. But I'll get some specific examples to bring back to you.
It's a distinguishment between the states that the atoms are in. So in a superconductor, they're in a solid state. So they're in a lattice structure where the intermolecular forces are constant and holding the atoms at a set distance from each other, and they don't change. They're stuck in this lattice structure. Whereas in a liquid, in a superfluid, the helium atoms are only forming fleeting intermolecular forces between each other. They form and break so that the helium atoms can move. They can move in any direction in the media, as Kosha said. So that makes them a liquid as compared to a solid. And
for the superconductor, when you say it's metals, we're talking about like the free electrons are the ones that are free to move, but obviously the interconnecting, the ones that create the structure, those are fixed. Okay.
Yeah, the non-valence or the core electrons are still they can't move. It's only the band gap, the valence electrons that are allowed to move.
Yeah, that makes a lot more sense now. Yeah, thanks. Because like I said, I understood the basics of what both of them are, but now that makes perfect sense that they're kind of in a way they're behaving similarly, like as far as basically the zero resistance and the zero viscosity are like the parallels to one another, but just in one it's the fluid nature of the atoms themselves, and the other one it's the electrons that get that zero resistance. I guess that's why it also has zero electrical resistance for that reason.
Yeah, sorry, I missed a little bit of what you said. Can you repeat it?
I'm just saying, like that's the reason why it said that they have zero electrical resistance, right? Like a superconductor, is because those electrons are basically moving freely, basically like they had zero viscosity.
Yeah, so it's very similar, but it's just in a superfluid, it's the atoms themselves that are moving freely, whereas in a superconductor, it's the valence electrons that would usually, just be kind of what's called the sea of electrons in a regular metal, that are, in between the band gaps. Those are the electrons that are kind of flowing without any viscosity per se, or no electrical resistance.
I know you said you're not like, I don't know how familiar you are with all this. I hate to ask you too many questions, but what you said about them like turning from fermions to bosons, I've never heard that before. So, is that like an actual, like they actually turn to bosons, or they just behave more like bosons, or?
Well, what it has to do with is the total spin. So in a helium atom, you have four total baryons. You have 2 neutrons and 2 protons. And so when you total the spin, they each have spin 1/2. So when you total the spin, it gives you an even number or an integer. Whereas with electrons and fermions, even hydrogen atoms, they're also spin 1/2. But there's only one in just the not deuterium or tritium and just a regular hydrogen nuclei. There's just one proton, so it's just a spin 1/2 particle, same as an electron. And so those are what's considered in this kind of sense that we're talking right now. It would be considered like the fermion kind of state or the Fermi behavior. But helium atoms, like I said, they can have an even total sum of their spin, and at a specific temperature they'll transition from this fermionic behavior to this kind of bosonic superfluid behavior.
Okay, well, I guess I have to look more into that, because from what I understand about bosons and like the quantum fields, for example, is like they're sort of they sort of create a way for different quantum fields to communicate with each other. I've heard that explained in that way before. If that makes sense, like a photon will allow electron fields and other fields to communicate with each other. I don't know if that makes sense.
Yeah. No, I know what you're saying. So, right, it's multi-leveled, right? So when you're talking about just elementary particles, just not composite particles, just elementary particles, the distinguishment between fermions and bosons, and this holds even at the composite level, but for this level, it's the spin. If it's a spin 1/2 or 3/2 or 5/2 or any kind of half integer spin, it's a fermion. And if it's a even integer, it doesn't have to be even integer. If it's an integer spin like 0, 1, 2, 3, etc., those are bosons. So like a photon is a spin 1, whereas an electron is spin 1/2. So an electron's a fermion, a photon is a boson. And in the particle sense that way, elementary particle sense, all the bosons are the force mediators. They're the interaction, the interaction exchangers between the fermions. But when you're talking about these composite particles like helium atoms and hydrogen atoms and stuff like that, now we're talking about summing the spin of the elementary particles that make up those composite particles. And if that sum is a integer 1, 0, 1, 2, 3, 4, 5, etc., then it can have this kind of bosonic behavior, where the defining behavior we're talking about here is like photons and gluons and those kind of things can occupy the same energy level or the same state. And so that can happen in atoms too if they have this kind of bosonic behavior.
So theoretically, or like if you were able to have these like temperatures that could put larger atoms or larger more massive atoms into the superfluid state, like if you had the conditions for them, there's only certain atoms or certain what do you call them, isotopes would be able to become a superfluid because of this, right? And some would never be able to.
Yep. Yeah, exactly. The total spin of their elementary particles that are making up them has to be an integer. If it's not, then they can't have this bosonic behavior where they can drop down to the same state, the lowest energy state, and act as a superfluid or a superconductor.
Okay.
Guys, can I just give you a little tip?
Yeah.
The word is etc., not etc. It's spelled et. It's like etc. But other than that, everything sounded legit.
Yeah.
All right, well, I gotta take off for a little while.
Oh yeah, man, Mr. JC, I appreciate you, man. Sorry, I always ask you a bunch of questions.
No, it's cool, man. I like talking.
Yeah. Appreciate it.
See you later, man.
Honestly,
It
I
was
like
fucking boring. Yo,
Dude, that's the guy that says he like makes vaccines, right? Or the V word. Sorry.
Yeah, actually, he told me something interesting yesterday. He said that he's one of the teams that worked on actually identifying the
Yeah, dude,
spike protein.
that guy is something else. I would somebody that's trying to explain to you like boson particles but doesn't know the word etc. or how to spell it. Very, very fucking dubious.
Do you really think? I mean, honestly, I don't think anybody else heard that but you though, because I mean, I didn't.
I know I got a sharp ear.
I didn't remember that.
He said it twice. He said etc. Like
you know,
EX.
I think that's just a way to speak. But anyways, I think somebody was going to say something. That's an interesting criticism.
oh show.
I got news for you, dude.
No, I don't want no news. No news is good news. Okay, you know what I want.
He wants 4
Enough
points,
said.
4 GPs, bro.
Where's my 4 fucking GPs at? You ever seen that movie? Where's my 4 GPs at?
Yeah, I would tell you, but you
Dude,
don't
where's
need
my
news.
GPs?
I'm just kidding. I want the news. That was a joke. What's up? I love your news. What's the news?
Well, it's first of all, I have to tell you, this isn't just fucking simple work, dude.
Okay, first of all, where are you getting these GPs from?
Where am I getting GPs from? First of all,
I know you're not going out and measuring them, so are you getting them from like Stellarium or what's up? The Almanac?
The Almanac. The Almanac has the Almanac has the fucking GPs, dude. That's what it's for.
How are you getting the angles?
You told me you wanted the fucking. You said specifically that you wanted the
angles
GPs.
and the distances. GPs, angles, distances.
Yeah, the angle to a GP is 90 degrees.
The GPs. I want the angle to all the other stars from the GP, from one of the GPs. How are you going to get
one of the
those
GPs
angles?
or all the GPs? Because I have it for all of them.
Bro, there's a guy at there's 4 GPs. There's a guy at one GP. He's going to get angle readings to all the other GPs, right? How are you getting those angles? I'm just curious.
Heavens Above.
Heavens Above. Is that a website?
No, I pray to God, and He gives them to me. Yes, it's a website, dude. And first of all, if you didn't know about this website, what the fuck, dude? We've been talking about this website for years.
Never heard of it.
What a doofus, dude. Dude, every time we fucking plan the ISS bullshit, I mean, and it doesn't matter, dude. Yeah, Heavens Above. It's a very useful fucking website. And
if you tried to go get the angles from Stellarium, that would give you the same angles.
Yes.
And this is all happening within the same second, like the same time, right?
That's the part that I need to inform you of. Because one of the first things that I did was I took a time that was today, and I was like, well, that's not useful. So I did a time that was a week from now.
Why is it time today? No, I need something that already happened, bro. Nothing in the future. What?
Well, that's great news, bro. Great news. Okay.
Dude, I don't want some shit that might happen. Maybe it'll happen. Maybe it won't. Who knows, bro? I need some shit that's happened, dude.
I have all
your
that.
head.
I already have that then.
Right.
I have something that's already happened. I had something that happened today, something that happens next week, and something that happens in June. What I'm gonna have to do is go to last June, because
can't we just do something that happened like yesterday or something? The 4 GPs yesterday.
Because of your restrictions.
I have very few restrictions.
You want all of these on land, is that correct?
No, I'd like them all to be at 0 elevation. I don't know if elevation even matters. I don't think so, but it'd be nice if they were just all at 0 elevation.
Elevation doesn't matter. But you want them all on land.
So, no, I want them all on 0 elevation.
Well, they're all on the shore, so it doesn't matter.
Okay, cool. Like what? So like 0 elevation right at the beach.
So it doesn't matter if they're at sea.
I'd like for them to be at 0 elevation on coastlines.
Dude, that's impossible. That is
right on the coastline. You go into the water. You're in New York City. You go into the ocean. Boom, you're at 0 elevation, right?
Dude, let me just tell you something. It was hard enough work to find 4 GPs that were all going to be, you know, you could see all of them at the same time. Okay, that was actually very hard. Okay, on top of that, I have to make sure that they're all. I was making sure they were all on land in the North America at the same time, right? And that was difficult. And then I had to make sure they were all not. The sun wasn't up while they were all visible. That also restricts it to a certain time of the year. Okay. Now you're saying you want all of them to be on a beach. Okay. If you said that they were all.
Hold on. Okay. Before we go any farther with this, I got to talk to some guys. Some of my guys.
What guys?
Don't worry about what guys. I got to talk to some guys. You wish you knew all these guys I knew because you're gay.
Yeah, that's right, dude. I'm gay. I wish I knew all the guys you knew. Because I'm so gay, I need more guys. You're the one who you have a guy for everything, right? I don't need a guy for anything. I don't need any guy.
Who are you gonna hold hands with when you watch the ISS go by at night?
My girlfriend, dude. That was one time. Anyways, man, listen.
No, you listen. Don't do anything. Just don't do anything. I got to get with some people, and then I'll get back to you.
Listen,
but nice work thus far.
Elevation doesn't matter. If this is what you're going to go to your guy to, I'm telling you the elevation doesn't matter.
Okay, fine. Proceed forward then with elevation not mattering. Fine.
Okay. Well then, so is it better on land or is it important that it's not at sea? Like
I would rather do it at sea.
If you would rather do it at sea, that makes the restriction a lot less more. That makes it a lot simpler to do, dude. I don't know why you didn't say it in the first place.
What if they're all at sea?
Yes, they can be anywhere in the world.
Yeah, just make them all at sea.
Making it over North America.
Go ahead, Jeremy. Say something that pisses Koso off.
Say something to what?
Pisses Koso off.
Yeah, dude. I mean, I spent so much time only because it was so restrictive, dude.
I didn't have no restrictions. The only restriction was that you could see all the GPs.
Yeah, but you said that in North America, you said, well, it'd be nice if we could go do this. If I go outside and do it, it'd be nice if somebody. So I had to put it in places where people could actually go to. You said don't put it in Antarctica or some shit like that. So I was.
Fuck it, bro. Fuck it. Anywhere in the ocean, can we use the sun for a GP? Let me talk to a guy or two, and I'll get back to you. Just
okay.
We may be able to use the sun and the moon and shit, which would make it easier.
Out of curiosity, who are you going to talk to?
One of my guys.
Are you going to name a name?
No names.
No names.
Names are not important. Not important.
I'm just wondering if this source that you're going to go to is trustworthy.
I'm just going to go to the guys that I'm going to, because when I go to them with what Kosho has, then we'll have it.
Put a tail on you, dude.
Well, I only asked that because the other day you mentioned about going to 10th Man or Nathan Oakley, and I'm like, why would you ever do that?
Well, no, that makes sense though, because he's ultimately going to present this, so he wants to make sure that what he's presenting is, going to be acceptable by them.
Okay, I mean, I don't mind about them getting their opinion on what's acceptable. I just don't want him to come back and say you're wrong because we think this is this.
Oh yeah, right.
If you made an argument about unicorns, and then I went to Kosho and had him do some unicorn shit. And then I brought that stuff to you, and you're like, this ain't how fucking unicorns work. And I was like, oh, shit, I should have checked with you first to make sure that Kosho knew how the unicorns work, right?
Right.
Yeah, sure. Whatever. Yeah.
I don't know what. I said this the other day, and I mean it still. And I think this should cause you to reflect, possibly. But flat earthers are fucking obsessed with unicorns, dude. I don't know how many times you guys fucking bring up unicorns, but it's 3 times.
This is the second time for me today.
Yeah, exactly. You guys bring up unicorns like it's fucking. You guys are going to some fucking parade or some shit.
Well, I think they're real. They exist. So how about that?
There you go.
Rhinoceros is just a fat unicorn.
Yeah. Okay.
You got narwhals. That's the evolution. Actually, unicorns evolved from those. What are they called? Narwhals.
Yeah, they evolved into narwhals.
No, they evolved from narwhals. Evolved into unicorns.
Well, it makes more sense that they evolved into narwhal. Aren't narwhals mammals?
And so are unicorns.
Exactly. That's what I'm saying.
So are whales. So are narwhals.
Yeah. Well, back in the day when whales were still land animals, narwhals were unicorns.
Bro, this is how evolution works.
So evolution, so the whales, they came out of the water as like the single-celled organisms. They went onto land. They became land animals, and then they went back in the water and became water animals again.
Okay,
That's
bro, the
true.
unicorns can be whatever you want. It doesn't matter. We'll figure it out later. It's not important.
That it is. But I mean, actually, that's actually not a bad. That's actually a pretty crazy theory about narwhals were previously unicorns.
We have horses. I mean, the horses are just unicorns that evolved that lost their horn.
Well, the whales and dolphins.
Probably a vestigial organ. The horn was a vestigial organ. I mean, dude, we can make up all kinds of bullshit about unicorns that you want.
Jeremy's got the science on this.
No, whales. The type of mammals that they were what do you call that? Cows. I forget what you call them, but those same kind of animals. I forget what type those are called.
Gio, tell them about the unicorns.
Yeah, Coach. So you're saying people you categorize as flat earthers should not use them because they're actually they're degrading the unicorns by saying they don't exist, even though they really do exist?
No, I'm not saying that. I'm saying I'm just bringing up the fact that you guys bring up unicorns fucking way too much. That's what I'm saying.
They're the most magical creatures on Earth.
Yeah. Next thing, if the flat Earth went away, like somebody asked us the other day, if you guys all found out it wasn't flat or something, I don't think you guys would go away. I think you guys would all just become bronies.
What's that mean? Is it the people that love My Little Pony?
Yeah.
Dude, come on, bro.
You guys would just be a big brony community.
You're weird. You're weird, Kosho.
No,
that's probably what you're into.
No, dude, I don't understand that. Those guys are obsessed with it. I feel bad because there might be bronies among us, but it's weird. But anyway,
the truth is not going anywhere.
Yeah, well, I got to tell you, Jeremy.
Oh, sorry. Go ahead.
Well, no, it's just back to the star bullshit, dude. If you unrestrict this, I'm gonna be pissed off because of how much work I put into it. But if you unrestrict it, it's gonna make it.
It's unrestricted. The only restriction is I need all the guys and all the GPs to be able to make celestial navigation measurements on all the other stuff.
And it doesn't matter if they're in the middle of the ocean at the time.
I'd rather have them be on the ocean. Maybe.
In the middle of the ocean. All right, dude.
Just do a whole bunch of them. Do a whole bunch.
You fucking suck.
What do you want?
Hey, great. Bacon's here now. Great, dude. Fun's over.
All right.
Get showed up. No, dude, it's just I finally get. I'm doing this thing. Bacon's not here to fucking show me up. Now Bacon's gonna show me up, dude.
Bacon's back from vacation. He's gonna come in with a whole bunch of extra work on Monday here. He's gonna have a bunch of new tasks.
You're the perfect guy for this, Bacon, which sucks. But Jeremy wanted 4 GPs, right? Such that if you're at the GP, you can observe the other 3 stars. All 4 of those people, actually.
I think it would be best if this was over the flat ocean water that we know is flat.
Yeah, I think I already have that.
Great.
Because I think
perfect. Per Bacon, you are on top of shit, dude. I was going to have Kosho shit double check, triple check. Now that you're here, though, I mean, we're good.
Let me see if I get... see if I had the data.
Well, I have 4 stars that are over land. He says they can be anywhere in the world. So
Kosho said this shit was tough. He had to go back to ancient Egyptian times to get a measurement, one of the celestial observations and shit. It was crazy. Thank God, Bacon, you're here.
All hell, Bacon.
So this is so you can see all the GPs, measure all the angles, measure all the distances, and then show the Earth isn't curving?
That's what we're gonna do, right?
Yep. If Jeremy told you what he's really doing, you guys would probably hang him. So
we're gonna see. We're gonna get the distances from this. We're gonna get the distances and do the geometry and then figure it out. No doubt.
He's basically trying to prove to the other flat earthers that this is not work on a flat Earth.
We're about to fucking find out what happens right now when we get these angles and shit.
The points that I have here, the 4 points I have, I mean, they're all on land, but the line that connects them are over water.
Like on beaches.
Yes.
Oh, perfect. Bacon. So glad you're here. So glad. Kosho had us walking around in a mound of shit just a minute ago.
Yeah, I'll post it. All the 4 points.
Awesome. Kosho, be ashamed of yourself.
Who fucking called? Did somebody call you or something like that, Bacon?
No,
I did. I called Bacon. I got out my beating bow and I started to play a little Jenga.
Bacon, will you DM it to me, please?
You heard me.
Yeah.
Thank you.
Fucking damn it.
Bacon, do you do full contact capoeira?
No.
Come on, dude. You don't do the Jenga?
Capoeira is quite hard.
Mama way, mama ya.
Paranauê.
Eu quero voltar, eu quero voltar. Eu
It's
quero
Paranauê.
voltar, minha
By the way, I
mãe
live in Paraná.
África.
Is that what?
Okay, dude.
The song they're saying, it's Paranauê,
Yeah,
Paranauê, Paraná. And Paraná is where I live.
Oh, yeah.
Yeah, that's dope,
I
dude.
thought you were saying empanadas. Them shits are delicious.
No. Those are from everybody knows empanadas don't come from Brazil.
Oh, we have them here.
I know, I'm just messing.
Bacon, these 2 stars that you're using, Cursa and Algo, where are you getting the data from?
Stellar.
Okay, because those aren't in the almanac.
Yeah, I try to use just from the almanac, but it's much harder.
Yeah, well, that's what I did. I was restricted at one point, and I did that.
Hold on. Hold the phones.
Yeah.
Hold on. You telling me this shit that you got ain't in the almanac?
Half of it is.
All right, just DM it to me, and then I'll get with my guy and come back and let you guys know.
I did. Yeah, it's hard to use the ones from the almanac in coastal cities, and when you can all see they can all see each other.
Yeah.
I mean, if you put too many restrictions, it becomes hard to find. Even though there's like almost 60 stars.
This is what I spent all night doing, dude. This is what I did last night. I spent the whole fucking night, and I had to narrow it down, and only when I opened it up to like the very furthest you could see them, did I find 4 stars where it would work.
Oh, really?
Yeah.
Well, you can write a search algorithm for that.
Yeah, well, that's what I was saying that last night. I didn't want to because I didn't feel like writing any code because I feel like I'm sick.
Yeah,
I'm sick of fucking working hard for this fucking asshole, dude. He's a real asshole, man. And it really sucks you came in here, Bacon, after I did all that work. Now you know.
Sorry.
It's not you, man. You want to know what it is? I'll tell you what it is.
Well, you could, you know, my website, the one that does selection navigation.
You know, I was actually thinking about using it, but
yeah, because the 3D version, you can turn on the Celestial Sphere and rotate it around. I think it really helps finding.
I never thought I'd get here, but I really feel bad for asking this. But Kosho, do you think it's just because, once again, the work you put in did not demonstrate the Earth to be a globe?
No. I mean, actually, I said this last night to Matrix. Like, when me and Bacon and what was it, Ruhif and Eggshells, like the amount of energy we've put into like celestial navigation, you actually get an intuition for a lot of what goes into it. And once you get that intuition, I'm sure anyone who put that much work into it would not even entertain the idea of a flat Earth. It'd be impossible to entertain.
Wow, impossible! But so many of us are doing it. Like, what you think it's impossible? Are we just batshit?
No, there isn't any. Like the flat Earther who's probably putting the most work into it is Brian, and he's not even putting enough.
I'm not talking about individuals.
But you've been entertaining it for years. All you guys have.
Oh no, but when I mean entertaining, I mean entertaining it as being possibly true is what I'm saying.
Let me give you one example. Like I wrote a code right now today that you give some set of restrictions for a coordinate. So let's say you want this coordinate to have another coordinate at 200 degrees azimuth, and you want another coordinate to be at, I don't know how many miles you want from this coordinate. You can add a lot of restrictions to a specific coordinate, and this algorithm is going to find which coordinate matches all those restrictions, right? So this is like a general purpose algorithm for a sphere. And just from, for example, one azimuth and one elevation angle, you can always get the right coordinate. If you also can, for example, get your coordinate only from azimuths. You get the azimuths of 2 or 3 stars. You will find that your coordinate is the one that matches those azimuths on the sphere. So it doesn't matter what kind of measurement you have. If it's placed on the sphere, you can always find where's the coordinate that those measurements came from. And this is just by putting them on the sphere. Like I don't know how possibly can any flat Earth method make any sense or get close to work. And I don't see anyone trying to. Like, it's just too easy to make it work on a globe. You just see where on the sphere would that work, and that's where you are.
Yeah, you're going off a map given to you that's a sphere.
Not really. I mean, I already explained that. Your coordinates are not given to you. You can check your coordinates yourself.
There's no but how do those relate? Yeah, but how those relate to the soil? You're not out there in the world doing it. You're sitting at a computer. So you're going off of a map given to you by your computer. If you were out there in the physical world actually mapping the soil and doing distances, that would be different.
No, but I'm not talking about that. Like, what I'm saying is you can get your coordinates yourself. And you can... What this does, what a sphere does, it tells you how that's going to relate to other coordinates. And the relationship that a sphere gives you is the same one that we find in reality. It doesn't depend on any map because your coordinates, again, they can be figured out by yourself. And there's no room for any like brute forcing of or back how you call it backward engineering, because once Earth is a sphere, there's no 2 ways to spread latitude and longitude over it. There's one way. There's no space for, oh, maybe this coordinate's more there, or it's some 1,000 kilometers in that direction. There's no room for that, because if the sky appears to rotate because the Earth rotates, then the time's going to tell your longitude. You can't be somewhere else. And the angle in which stars appear to rotate in the sky is going to tell your longitude. If you see they rotating in that angle, you can't be somewhere else on a spherical Earth. There's just no room for forcing anything to work on a sphere. Like, I'm not using any extra information that anyone's giving me.
Yeah, it's the shitty thing about Bacon is where when I did my celestial navigation thing, I looked up the formulas and stuff, but Bacon learned it from scratch. Like he learned it from brute force, trial and error.
And there wasn't many error, actually. The first fig that I tried worked. And I didn't even know Haversine at that point.
You didn't know Haversine? That's what I'm saying.
No, I had my celestial navigation app working way before I even heard about Haversine.
Yeah, I remember. Yeah.
I think it now uses it. I don't remember. It's quite a long time since I last edited it. But the one I did today, it doesn't use it because it works off of Euclidean geometry. It deals with the points in 3 dimensions. It's actually faster math because it doesn't use trig functions.
Well, I'm so stupid, dude. I've been using the Haversine function. I didn't even realize it was a trig function until recently. But it's basically considered a trig function. Well, I mean, it uses trig functions, but
yeah, that's what I meant.
Trig function. No, but it is itself a trig function.
It's like the Pythagorean of the spherical geometry.
I guess kind of. Yeah. You know what it means, right? Like I don't know what a versine. Versine is basically like a sagitta almost, and Haversine is just half the versine, half versine.
Yeah, I mean, I don't know anything about spherical trig. I know it's very useful if you're dealing with latitude and longitude.
I thought Haversine was like a dude, like it was named after some guy, but yeah, it's stupid.
It is.
So your previous explanation just fell apart.
Two is spherical trigonometry.
I was my guess. I assume that.
Oh, okay. Yeah, I think there's something called the laws of Haversine, something like that. And the Haversine equation uses those laws. Like, like the law of sine and law of cosine.
Yeah.
I think you have the law of Haversine. And from those, which is like a simpler equation, from that equation, you get the Haversine equation. I think it's something like that. But I remember.
Oh,
I know you don't need it.
Bacon's great. Everyone knows bacon is great. Me and you are like opposites. I told you, like I'm kosher and you're bacon. It's like the exact opposite.
You're what?
People like bacon. Not many people appreciate kosher.
Kosher, what's that?
Kosher, it's like Jewish. It's
Jewish blessed food.
It's non-violent meat. Non-violent meat.
It has to be like blessed by a priest or something. Blessed by whatever.
Rabbi.
I'm not gonna lie. Before bacon came on the scene, I had kosher. Before bacon came on the scene, I had kosher as like number 8 of the top Globers, but bacon took his spot.
Okay, I gotta ask who's number 1 and 2. Get his top 3.
It's not important. Just no bacon took his spot.
You don't have
Bacon's
clearance.
number 8, but he's not in the top 3.
Kosher, bacon, and Zanuck.
No, not Zanuck. No offense to Zanuck, wherever you're at, but you're not in the top 3 for sure.
Bacon puts in the work, man. He puts in good work.
And it pays off. I mean, I got $100
from Ruhif.
From MC2.
Oh, did you really? Oh, what was the challenge? I'll just see if somebody would do it.
Yeah.
Wait, MC2 paid you $100?
Yeah.
He is a shill. He gets paid. He gets paid for these things.
That's so funny. Yeah, that's. I'm not gonna say it, but yeah.
It was a great opportunity for he to be embarrassed by flat earthers, because the challenge was simply to tell him what his coordinates were based on the elevation angles that he got from his phone.
Oh, but he didn't say it had to be a flat earther. Or
God, dude, that's like 500 reais.
Exactly.
Holy shit. God, Alio, nice, dude. That's fucking good for you, Bacon. Honestly, good for you.
But Ruhif did it too, didn't he? Ruhif said that he would give $200.
Oh, but Ruhif only accepts if he comes from a flat earth. Toon's challenge could come from anyone using any method. I mean, anyone could use my website and just plug in those numbers, and which was what I did, and just send him the answer and got the $100. I mean, imagine if a flat earther won that challenge. It would be pretty embarrassing for him.
Look, I've been saying this for probably at least over a year, but Bacon is definitely going to be one of the most insane flat earthers when he figures it out. Like he's gonna be like weaponized, 100%.
Yeah, all of them. I think all of the Globers that stay around these arenas, they're gonna be the very best flat earth advocates.
Yeah, same with Kosho. I can see it. You put in the time, you put in the effort, and you'll figure it out.
You wish.
I don't need to wish, brother.
Actually, you say you wish or Jewish? Because Kosho.
That's funny.
Well, Bacon, it's like, do you want to be relevant or irrelevant in the future?
Relevantly irrelevant.
I am what I am.
You know, though.
I'm just saying, being the dude that defended the wrong paradigm, especially as the paradigm shifts, is pretty irrelevant at that point.
Well, I'm fine if I turned out I was defending the bad paradigm. At least if I was following the evidence that I was presented with reasonably, which I think I'm doing. Even if it leads to the wrong conclusion, and then I get better evidence later, and then I changed my conclusion. That's fine. But I need better evidence for that. And so far, it's not looking good for Flat Earth.
Yeah, but you're here. I mean, you feel like you would say you're a truth seeker?
Sure.
So then you're seeking truth in a community of individuals.
No, I'm not here seeking truth right now. I was just here for the conversation.
He's doing God's work.
I seek truth as a hobby.
You know, Albert Mickelson, he actually did a lot of successful shit. Like he was the first person to measure the diameter of like stars and stuff. But even till he died, like even till he was an old man, he still couldn't get over the fact that that his test failed. Like he always saw that test as a failure, the Michelson-Morley test, which is interesting. So I think that if you found out it was flat, Bacon, I think no matter what you achieved, you'd always look back on all the energy you put into all these projects and observations and stuff, and came to the wrong conclusion.
It's a bias thing. It's just like the cheating girlfriend thing. It's hard for you to think that the bitch that was sleeping next to you, hugging you, and telling you that she loves you is sucking somebody else's dick. It's the cognitive dissonance part of it.
Thank you.
I think it's easy. I think it's easy to say the other side is being biased, but I mean, let's say about the things we're doing. So, like, to get your position from star angles, we're the ones doing that. Maybe we're biased, but where is the same from your side?
Well, my question is,
you're not doing anything. You're sitting on a computer and taking digits that someone gave you. You're not out in the world doing anything when it comes.
I have my section. I took measurements myself. It doesn't matter if I get from Stellarium, if I go outside and measure them myself. It works. I also got data that people use when sailing, like Tiny Captain. He actually works by sailing. He sells, he transports things, and he often does celestial navigation. And he sent me a bunch of the data that he collected, and he has the GPS data from his ship that I can compare it to. So he gave me that data so I could check if my methods were also working, like even where he was traveling, which is like in the other side of the world, and it was working pretty fine. So I was using data that people gave me, that is real life data. I also used the real life data that I got myself. So I think it's fair to say that I'm doing something.
What I want to know is why
that data is correct though. Like, all right, the numbers make sense, but we have to assume that the stars or whatever it is that you're measuring actually is exactly where you're measuring it from.
Actually, no.
Accurate, but we could just say, oh, it's an assumption. You can't prove that, and it's true. Other than the numbers, you can't prove what you're saying.
I think Extremis has tried to get in twice.
What I was going to say is we have these challenges from McToon and Ruhif and whoever about doing celestial navigation, and they're doing celestial navigation, I guess, to some extent, and they're having other people do celestial navigation. What I have not seen a single thing from any flat earther, even the ones that say you can do celestial navigation, none of them are actually doing it, or are they also making any kind of challenges? None of them.
The truth.
All they're doing is just talking about it. And just basically the end of their claim is you need a flat plane for that. That's all they say over and over and over.
But the only thing that we're actually claiming is that we don't live on a sphere. Most of us honest ones, we would say that we have no idea the shape of whatever the fuck this thing is.
Good.
Yeah, but
get the claim from if we don't know exactly what it is, right? Where would we get the claim from?
Could it be an ellipsoid?
Doesn't seem to have curvature all over the place. Doesn't seem to be curvature at all.
It's obviously not moving.
It's like you guys have to pin us down to a specific claim to be able to debunk us. Yeah, of course. You can debunk anything we say, right? Because we don't have the answers. But what you guys claiming is true doesn't seem to be true.
It's far from what I'm doing. I'm not claiming to debunk any specific map or anything. It's just that all the relationship we get to, like star angles, they're all spherical ones. Every time.
Yeah, there's one fundamental principle that celestial navigation works by, and that's by creating a celestial sphere, and the principle being that the celestial sphere will tell you something about the surface of the Earth, such that there's like a one-to-one relationship between what's in the celestial sphere and the surface of the Earth.
Like you just said, wouldn't you have to assume, create the sphere in order to be able to adapt the numbers to it?
Oh no, it's used as like the celestial sphere. Most flat earthers don't even disagree that it's a celestial sphere. Behaves like a sphere to the heavens.
Well, I mean, let me tell you, like, one fact about celestial bodies. You pick two stars, you measure the angle between them, the angular separation between them. That angle is not going to change in any time of the night, and it's not going to be different for somewhere else in the world. That is true for any pair of stars you pick. So everyone sees this angular distance between stars being the same all the time, everywhere. And I mean, if you try to picture that on flat Earth, I mean, I'm not sure how to put this argument or how strong it is that this fact can be observed. But if stars are moving around the flat Earth, they're not getting further or closer to you in any significant way because they're not getting closer or further from each other. They appear to be in a constant angular separation between them, which means that their distance to you is not changing any significantly. And it's also the same for everyone on Earth, because everyone also sees them moving around, doesn't see them getting further from each other or closer to each other, as things do when they're getting away from you. Like if you go away from a building or get closer to the building, it gets bigger or smaller. That doesn't happen to stars. And it's the same thing for everyone on Earth. So it does appear that stars are very far away and they're around the Earth. It's just too clear that that's the case.
I guess what you're saying is there's no significant parallax on a given night from the stars.
Yeah, and not just for one particular observer. You can then go to the other place on Earth, get a different observer very far from you, and get the exact same angle. So even if, let's say, you have a celestial dome that is centered at you, so the angular separation doesn't change for you, it has to be centered at other people as well, because it also doesn't change for them. So in order for a celestial dome to appear to everyone like they're in the center, because the angular distance between stars is constant, it would have to be so huge that there was not going to be any parallax. But if that would be on a flat Earth, then we all see the same sky, and we don't. We see complementing halves of that sky when we are in opposite coordinates. So, it's just too clear to me.
Have you guys seen that model that has the observer the sphere of the observer, and it has the flat plane and it has the flat ceiling, and it has like a circle of observature? How the stars of the flat plane would be represented in how your brain would perceive it. There's an image floating around.
You're talking about the personal dome?
I just posted it. Yeah, that's just from Walter Bislin's thing. But you might be referring to something like that.
All right,
yeah, because that's a sphere that around you. That's a hemispherical range of your vision. And whether like a globe Earth or a planar type Earth, you still can only see in that range. So it's not like when you're looking at the horizon on a globe, that's not the end of the globe. That's just the end of how far you can see. Like if you're in San Francisco and you're looking 3 miles off and you can only see 3 miles in, you know, to your horizon, that's not the tip of the globe. The globe's way bigger than that.
So you're talking about a horizon.
Hold on, Karsha. That's why I told you. That's why I was talking about it, because if you take this, just take it into consideration. I'm not asserting that that's truth, right? I can't guarantee that. But if you will take this into consideration, what's going on in the sky, what your mind is represented has nothing to do with what's actually going on in the sky. Your mind, your eyes is interpreting something, is another reality. So we are making calculations and to something that we have no like comprehension of, because I can't, like I said, I can't prove that this is true, but damn, that shit intuitively, that image tells me that this is correct. That we see it in this way, you know, I don't know if the sky is in this way, but if it was, we were to interpret it that way.
Yeah, but this would only work if so this would basically render our reality as a simulation that was created for us.
No, dude, it's just an XYZ axis. It's just the basics of geometry of XYZ. You got the sky above and the ground you're on.
No, but this only works with a personal dome, like where your vision, your personal sky is unique for you and made just for you, such that it looks like it's a shared sky, but it's actually on a sphere, but it's just personal dome on a flat plane.
The personal dome is all the only thing it is what our eyes are able to render at any specific time, right? It's just
okay. Let me
rendering a video that you're editing.
Let me show you something.
It's similar, like. Oh, sorry. Well, I was just saying in a video game where it's like it only renders the local region of the world that you can see, and then as you walk forward or backward in the world, it renders more of it.
Yeah, but that's the thing. It's rendering based on distance, but it's not changing where it appears to you. So on Earth, we don't stop seeing stars because they're a certain distance. We stop seeing them when they set, where they go below the horizon. From one horizon, from the horizon to east to the horizon to west, we see stars between all that range. There's no range that is cut off because it's too far and fades out. All that, everything above the ground, that half sphere of area we have to look at, we can see starting all that. There's no star fading away because it's getting too far. And again, when you have things getting far, they get smaller, right? The angular distance between things shrink, just like railroad tracks, right? As the further it is to you, the closer those lines get. We don't see that with stars.
What do you mean? We don't see them disappear when they go. What do you mean when they go away? Where they do something else that we can't verify what they're actually doing? You're asserting that they might be going far that we can't see them. Is that what you're saying?
Talking about the analogy of video games, like when a video game stops rendering something because it's too far away, it just fades away in the direction that it is. It doesn't set. It just fades away. It doesn't move around because it's too far. It just fades away. That's all we're seeing with the stars. We see them setting, so we can't see them anymore.
No, but it's a video game. That's not your eyeball. Your eyeball.
I was responding to the video game analogy.
But things do set in a video game. Like if you're in Minecraft and there's like something up in the sky and then you run away from it, it's gonna set.
True.
Yeah, but like the moon on Minecraft, the moon on Minecraft is actually going around you.
Did they program it that way?
Yeah.
Oh my god.
That is the personal dome. It works like a personal dome.
But you guys
on my
understanding that the personal dome it isn't something that we're imposing. It's just how it works with our eyes and the way God designed our eyes, right? It's just how it works. It isn't something that you need something external to be able to, like, you guys understand what I'm saying? This is just how your eyes work. It's how your eyes is interpreting reality.
Can you give me your best explanation on how eyes work?
Wait, just really quickly though, since we're talking about domes over us, Futurism.com came out with an article. I posted it in the chat. It says, scientists find a huge Star Trek-esque invisible dome around Earth.
Yeah, let's go only with the title.
Okay. The next,
it's like they're preloading the damage control. Like now there's a dome. The moon is within the Earth's atmosphere. It's pear-shaped.
Look, if you get scared, there's a fact check by Routers. Routers has done a fact check, and they say that Earth is not covered by a dome or a firmament. It's okay.
Oh, thank God.
Thank God they fact checked that one. Yeah, pretty much anything that's fact checked is very sus.
Is it a coincidence that everything that is fact check goes against the government?
Pretty soon it's going to be like, no, there is no satanic cabal that's doing SAR. That's not happening. We fact checked it. We called the Church of Satanism. They denied it.
Yeah, watch in 10 years, they're going to say, no, they did not force you to take vaccines in 2020. That's false.
I mean...
Yeah. Matrix, can you join the live stream?
I'm there, bro.
Right. Okay, so let me just put the camera right above the Earth. Okay, so this, can you see an orange line there?
Yep.
Yeah, that points to where the observer here sees the sun. This is where the sun is on the dome. So the sun is here, but the observer has to see it there, right? Do you think that's related to your eyes can do that? Something being a different direction, being seen somewhere else? Is that what you're talking about when you say that's how our eyes work?
What do you mean?
Because the observer is seeing the sun in that direction, but the sun is actually here on the dome.
Wait. Is this supposed to be like a flat Earth map?
No, there's a specific model that Matrix was saying was how our eyes work.
I don't think he brought up an azimuthal equidistant thing. I think he was more just talking about, I don't want to speak for Matrix, but I think he was saying just on a flat planar surface that you see in a sort of like a dome in a sense. Like our eyes have a distance of how far they can see. And then like, I think it's a mixture of how our eyes work and how the atmosphere allows for as well, because it's like a combination of how far you can see with your eyes, but then also how far you're able to see in the environment due to the conditions.
Yeah, but he's showing the thing that you posted. Walter Bisley.
The problem is that what Bacon is doing right now kind of implies that this model, right, and the
this is what you posted.
It works in any kind of map. It's just how your eyes work. So it doesn't really. You don't really need to have the flat land to be able to do it. It's just how your eyes work. So
what about
the correlation between this and the other thing?
Yeah. What about how the Y? I'm no expert on how the eye works, but
I think you cut out a little bit there. Maybe you're.
Oh, sorry. Yeah, I was changing my mic, I guess. Yeah, I'm no expert on how the eye works. I know some of how it works, how cameras work in general, because I use that to build my renders. None about that had anything to do with this, so maybe I'm missing something. What is it about how the eye works that you think is relevant to make this making sense? Matrix.
There's this video by this guy called Life is Short. It's like a 3-hour video. He goes in depth into the eyes and rendering and the cone shape. So I don't know if you've seen the video.
I've seen it.
I haven't. But did you understand the video?
True, more or less I understood it. And of course, I've also been using my eyes for all my life. I don't think you have to be an expert to understand how your eyes work to a certain degree. You know, maybe every name of every vein or every piece of fucking mass, sure, but you don't necessarily have to be a super expert to
I
understand.
think you do have to study how the eye works, not just using them. I know a lot of people that have used their eyes their entire life and would be clueless on how their eyes work. But if you saw something on that 3-hour video that made you realize that there's something that makes sense that we're missing, it would be very nice if you could tell us that.
We've been telling you guys this for a very long time, so I don't think we have to specifically point it out and be like, here, this is the sentence that convinced me. We've been talking about this for a while, so there should be information out there that you guys should without us having to spoon feed it to you guys. Because how is it that we arrived to this conclusion?
Well, not trying to make those readings match a flat Earth for certain. I mean, get the azimuth of celestial bodies. They perfectly fit a sphere. To make that fit a flat Earth, you need some very heavy distortions or something that you seem to be attributing to the eye. So what is that thing that you're attributing to the eye that you're missing?
I distinctly heard a door open and then somebody snapping their fingers.
It isn't that complicated. It's the curvature of the eye, bro. Your eye is round. Light tends to go around things when there's a roundness and like glass, like something reflective. Light tends to curve over it, right? And if you're perceiving straight light at a certain distance, your eye might curve that light a little bit. It's not very complicated, bro. Not very complicated at all. I think that whole thing about, where did you find this document? I think that's like a red herring to kind of disqualify people's opinions. You know, we have brains. We don't all the time have to depend on science to tell us what is for us to be able to understand things.
Sorry, I had to leave for a couple seconds. Yeah,
I heard
the
that.
Curvature.
That was the famous Brazilian snap, dude. My dad does the same thing. I heard you snapping.
Well, the curvature of your eye doesn't change where directions are.
We're not talking about changing physical locality. Your only thing that is the interpretation of what you're measuring, right? If you physically go measure a distance that you're observing and the distance of a building that you're measuring, right, is going to give you a set distance. But if you're taking a photo and measuring it with the photo, you're not going to get the same physical distance because in the camera, in the eye, in any mechanism that you're using to observe, there's going to be curvature, right, which is going to distort the image. Bro, this isn't complicated.
I don't think so. I don't think so. For example, if you take a photo of a building using a rectilinear lens, right, and you tell me what's the focal length you were using when you took the photo, I'll be able to tell you how high the building is if you tell me how far you are from it, or vice versa.
Are you able to see a straight, Bacon? Is it going to be a straight photo from the observer to the building?
If you have a rectilinear lens, yes.
So if you take a photo of a building, 20 miles, you're telling me you're going to be able to see the entire from down to the top without the bottom part disappearing? Is that what you're saying? It's going to be a straight shot.
I'm not saying that. All I'm saying is that how something looks on the camera when we take a photo of it is not any mysterious. We can solve that beforehand. If you tell me how far it is and you give me enough information about your camera, I can tell you how it's going to look like in that camera.
But does it look the same in an orthographic rendering of distance to distance than taking something from an image? Is it the same? Or do you interpret it the same way?
No, cameras don't take orthographic.
That's the part that you're not understanding.
What am I not understanding? I don't get it.
the difference of outcome between the rendering and the observing of the same distance. It could be the same distance. When you take a photo of that distance, right, how you interpret that photo is going to be different due to whatever took the photo, whatever you're using to visualize the photo, the image, right? But if you do it in something rendering, like physically measuring it, you're not going to have anything visually obstructing anything. Right, this is what I'm telling you. There's a difference between actual measurement and what it actually is, and what you're interpreting with your eyes. Doesn't work the same, because if you're seeing something in the long distance,
I'm not getting you. I'm not following.
From the ground up, do things tend to disappear from the ground up with distance?
Yeah, I lost you. I don't get what kind of point you're making. I really don't.
So do things tend to disappear from the ground up with distance?
Well, if you're talking about very far distances, then I think it's hard to predict what's going on.
And wouldn't that, if you would have taken
I don't, but that has nothing to do with how the eye works. It doesn't matter. One second, Matrix. That has to do with atmosphere, because if you switch your eye from a camera, if you switch your camera by, I don't know what else, you're not getting rid of those effects. You're not getting different effects. You get the same amount of things that are obstructed switching from your eye and from between your eye and a camera. It is not something that is a product of your eye.
Is your eye also the atmosphere, also the sun, also the wind, also whatever elements you have to deal with that are going to be in the way of that visual distance, as opposed to a physical distance?
I don't know what you're asking. I didn't understand your question. Yeah, I'm very confused to what we were talking about right now. Because what we were talking about before was that the readings that we have from the sky matches exactly what you would expect on a sphere.
One of the hardest things about researching deep underground military bases is you get a lot of guys that say they're like retired government officials, but then they start talking about aliens, and it's such a turnoff because it feels like misdirection. I don't know if you know what I mean, but
aliens and reptilians, bro. This shit turns me
dude,
off.
Dude, I know, but the thing is, like, they're definitely fucking digging underground and doing shit. You got CERN, you got the Denver airport, you got Mount Cheyenne, dude. The Thames fucking underwater bridge built in 1825. They built an underwater tunnel. Sorry, not bridge. Underwater tunnel in 1825. You know what I mean? It's just something ain't right there, dude. It kind of gets me thinking, like, oh yeah, then you have like trillions of dollars missing right before 9/11. How much money do you think you would need to go underground and make a breakaway civilization?
Listen, these people, the government, bro, they have unlimited money. That budget thing and that thing that they need money done, none of that shit is true. They have an unlimited amount of money because the 99.9% of the people have no idea how money actually works. So they consistently give the governments and banks their money, their interest, their dividends. They give it away because they don't understand that those dividends and those interests belong to them. So all that money that we don't claim, all of that the government takes. So it's pretty much unlimited.
Yeah, I hear that, dude. I do my very best to give the government anything. It's not easy. It's crazy. The IRS will come and hunt down American citizens and by use of force jail them over thousands of dollars if like they haven't paid the IRS. But our own government can misplace trillions and nothing happens. Fucking insane.
Bacon, by the way, I don't know if Bacon left. I was gonna set him up with data. Data has the numbers on all that shit on the eyes and he has real good numbers on that. He got papers on it.
Well, the beautiful thing is that these people like Bacon and the Koshos of this world here, they're gonna have to back up like Steve Aoki on the moon in less than a year. They're gonna have to rep that. Like, oh yeah, you know, the last time we went to the moon, we were sending well-trained Air Force pilots, you know, with credentials and experience, allegedly. And now, fuck it, dude, we're just gonna send a DJ to the moon. They can just defend that. It'll be fun. We got a lot to look forward to as a community. The more they claim to do, the more CGI we get to pick apart.
But my question is, do you have to be a everythingist? Like, do you have to be a scientist, mathematician, fucking genealogist, biologist? Do you have to have every fucking PhD to understand these things?
Well, they want you to believe that. That's how they compartmentalize knowledge, you know. But obviously you don't.
And when you do research on these things, right, on credentials and these things, most of the people that come up with these formulas, right, with these useful things that we're using to today, most of those people didn't go to university. And if they did go to university, was after they became a genius.
Yeah, dude, it's just a new age religion. It's a very popular new age religion. That's what we're dealing with right now. This is probably how the pagans felt when like the Muslims rolled in, or this is how like a tribe felt when Genghis Khan. Well, actually, no, Genghis Khan let everybody practice their own religion. But you know what I'm saying? You know what I'm trying to say.
Yeah, you know the pagans are us, right? We're the pagans. We are
Dude,
what they used to call the pagans back then.
Right. According to them, like, yeah, sure. Like, I don't really get excited for too much stuff these days. Like when you're a kid, you're excited for like Christmas or whatever. I am so excited for them to fucking send Steve Aoki to the moon. I can't even tell you guys. It's gonna be so funny.
Well, we can't wait to rip that fucking video apart.
Exactly, dude. It's gonna. This is it. This is it. The deep fake technology is right where it needs to be for them to like. I think for them to finally feel comfortable enough with producing, you know, a movie, basically, produce a film that they think we'll believe.
I don't think these things are hard to understand, man. I think these people use those PhDs like crutches, you know, to make it seem as if one doesn't have these PhDs, one cannot understand truth. It's very disingenuous how that is done. Because people usually they tend to fall for those kind of things, right? They always fall for like the con man with the suit and that talks nice and stuff, right? You know, because it's like it's the way the person looks. For some reason, people think because he looks nice, he must not be a con man. Because he speaks nice, he must not be a con man. Because he's in a podium or has a fucking white lab coat, or he must not be a con man.
I think a lot of it too is like, if there's a chance that one of the most commonly held beliefs is not true in your society, and you realize that, and you're like, oh shit, like if I accept that this is not reality and that everybody else is being deceived, now my place in this society is going to be one of an outcast. Like it's like a burden, right? And a lot of people don't want to deal with that, dude. They want to they still want to go to whatever it is normal people go do and feel normal. I don't give a fuck about any of that, so it was not very hard for me to be like, oh yeah, what else are they lying about, But most people want to fit in.
They don't want to deal with the implications of us possibly not knowing exactly where we are, who we are, or even when the fuck we are.
Dude, exactly. It triggers like the ultimate soul search, right? Who are we? Where did we come from? Why are we here? Like where are we? It's a fucking heavy shit.
Yeah. And you could turn yourself crazy thinking about all these things, bro. Thinking about God and your possible position in this place and what you're meant to do, bro. That kind of shit drives people crazy.
Well, in today's society, the people that aren't crazy are the well-behaved people who pay their taxes and vote and manage their emotions through the use of SSRIs. And it's, that's what normal is. Fuck, dude. Sign me up for Crazy Town.
Makes me think about all them people that supposedly hear voices and shit that they call crazy. Makes me think, what are these people actually hearing, and are they crazy?
Yeah, that's a good point.
Imagine if they're not crazy and they're actually receiving something from somewhere, right? And now all these people just conveniently having to be locked up in a psych ward. Wouldn't that be very convenient for somebody that's studying these people and what they're actually hearing?
It absolutely would.
You could experiment on them, even figure out where the signals or the voices are coming from. And who would know? Because all you have to do is call anybody crazy. All these people are crazy, so whatever you do to them, whatever kind of torture you make them go through, hey, people are going to accept it because you know what? They're crazy.
Well, I'll tell you what would be interesting if there was some kind of head of the thing where you could see what all the crazy people's voices were saying to them. You know what I'm saying? So say you had everyone's records and you could just single out like what are the crazy people hearing and then just like search for matches and shit, you know what I mean? Or some kind of significant thing.
They probably have a working theory on what's going on. They probably categorize everything in the computer programs, and whoever's really in charge of the programs, probably he just checks up on them. Every time somebody makes a catalog on a specific patient, they check them just to see what's going on. They probably already know what's going on. At this point, they're probably just documented what's actually going on instead of figuring out what's going on. If you understand what I'm saying.
Like say you get 100. I don't know how many crazy people there are. Say there's like 1 million crazy people, right? And like hundreds of thousands of them are getting like the same message via a voice in their head or whatever, right? On a certain day or whatever. Like it'd be interesting to have those records to hear what the crazy people are hearing.
And to see if it correlates, yeah, of course.
Just to see, like, I know, like they did like studies on ayahuasca or DMT or something where like the people didn't know each other and they didn't talk to each other, but they were getting like they were like having the same like trip kind of or whatever DMT thing happens, the same visions and hearing the same things or something. So yeah, I mean it would just be interesting to see what the crazy people are hearing.
Well, it's no different from well, I think it's kind of no different from people who have near-death experiences and all kind of describe similar things happening.
Oh, I could talk about that, but I don't remember. I've had 3 near-death experiences, but I don't remember what happened in between those. There's actually a show called the AO or the OA. I think it stands for Original Angel. Very interesting show, and it's about like near death experiences and reincarnation and multiple multiple realities. Very fucking interesting. I think it's one of those shows where they low key reveal some truth. It's called the OA, the Original Angel.
Bro, they're talking about making a show after me and calling it the OG. You know what that stands for. Yo, did you guys see that movie, The Platform, yet? I was telling Heads the other day to go check that shit out.
Yeah, it's good. It's good. It's very indicative of human nature, bro. Very
Yeah, I was
indicative.
telling him that. Yeah.
All they literally had to do was share, bro, and they all would have made
Everybody would have been fine. Yeah. Like everybody would have been fine if the people at the top didn't go nuts or didn't eat one day or something. You know what I mean? They could be like, all right, I ate yesterday. I'm not going to eat today. I'll make it, and then we'll all be fine. Dudes were like, I don't want to spoil it, but it was.
All right,
It
so
was good.
if you use that mentality, right? If you use how people really are, how is it, right? Let's just say God has a set of rules that he's left on the earth for us to follow. So if you want to take the analogy of the people of the platform and how stubborn they fucking are, right? What has God to do for those people that choose not to follow the rules? And if so, because you don't follow the rules, you tend to fuck up civilizations. What is God supposed to do with these people? Probably Sodom and Gomorrah them the fuck out of there, right? Just drawing them the fuck out because they seem to serve no purpose to his plan. If they don't follow his rules, fuck them.
I mean, what do you think? We the first world's got that coming to them? Some Sodom and Gomorrah society collapsing event.
I think that's part of human nature, bro. And I think what makes the elites different from us is that they know these rules, they respect these rules, and they follow these rules. We don't know and respect nothing other than what the elites tell us, and it's always usually backwards, right? So while they're following these rules, being blessed by God as they should, we are fucking most likely worshiping the goddamn devil himself and thinking we should get fucking prize for it.
You got something against the goddamn devil?
Yeah, I'm pretty sure Jesus Christ and everybody and every Christian is a devil fucking worshiper. Why would the elites give us the good God? Does that make any sense?
That's true. That's a good point. Speaking of good points, did you care, Jeremy, if the observations were done at night, or can they be done when the sun is up? You understand what I'm asking?
And you're going to do it all off the sun?
No, you're not doing it off of the sun. You're doing it off of the stars' positions, but the stars' positions don't have to be like does
No,
it have to be actual.
We're not doing that.
Okay, so it has to be done at night.
Yeah.
All right.
Let's actually be able to see the things we're going to measure angles to, because that is why. See, that's the goofy shit that you guys be doing. You'd be like, yo, here's the angles to the stars, but we can't see the stars.
I'm just trying to find out
That's
the
goofy, dude.
I'm trying to find the restrictions. That's all I'm doing.
All right. I mean, that's pretty common sense. You'd want to see the thing you're going to measure an angle to. There's no way that's going to fly right off the jump.
Listen, man, these are your restrictions. I'm just trying to find them.
Just be normal for once.
Yeah, you be fucking normal, dude. Fuck you. Hold on.
Bacon did not send me good information. We might have had a miscommunication error, but
Yeah,
I also don't think he knew what I needed.
Here's an issue I'm running into. No, it's fine. I just, it has to be in the past. I'm just trying to find the perfect date to where all these stars were out at night for all these locations. So I almost got it.
Guess it has to be in the past. We're not going to do something that hasn't even happened yet. How'd you measure an angle that you didn't even have? It didn't even happen yet.
Almost there.
That'd be like giving you a measurement for how big a piece of wood is, and you haven't even cut the tree down yet.
Oh, that's good. Yeah.
And you're going to tell me like how big this piece of wood is that you're just going to randomly make out of it.
Right. Yeah. Great point.
I might not have been the best analogy.
Okay, so let's be clear one last time. All 4 of these stars, is there only going to be, okay, so is there only going to be 1 observation point, or is it 4 observation points?
Bro, there's 4 stars.
Yes.
4 GPs.
That's right.
Every guy is under a GP. So there's 4 guys, 4 GPs, 4 stars.
Okay.
You with me so far? It's nighttime.
That's very difficult.
These are stars. And then every guy is going to look at the other 3 stars and do celestial navigation on them and get the angle.
Okay, but here's the problem. Hold on. Never mind. Hold on.
You good?
Almost. Hold on.
How many GPs are in the almanac? This has to come from the almanac, I think. I don't know. Make sure this all comes right out of the
I just found a perfect time. It turns out that one of the GPs is not, the sun is up. The sun is barely above the horizon at this time. The sun is 8 degrees above the horizon at this time.
You have like a whole giant area to work, half of the Earth to work with. Huh?
What are you saying? I can't hear you.
Wait, so at some point in the past.
What's going on?
Can you hear me? Or is my mic clipping?
What?
Does my mic sound okay?
No.
What's the problem?
Well, it's fine now.
Okay.
Dude.
So you have half the Earth sky to work with for these GPs, right?
Is that what you think?
I mean, I think I could get Bacon to do this for last night.
Yeah. All right. Dude.
Bacon, where are you at? Is he in here still?
Fucking hell, dude. Just give me a second. I just gotta find the perfect time and date. Just hold on.
I bet you I could get Bacon to do this. The Atlantic.
Yeah, well, he was here.
He didn't know the exact information I needed, though. He didn't give me the correct stuff. He sent me a DM and gave me some stuff, but
yeah, I know, but that's what I was worried about, was that because I could do it using any 4 random stars, but specifically, you probably want them restricted to the stars that are used for celestial navigation. So
yeah, definitely. We're gonna stick with celestial navigation stars.
All right, almost there.
I mean, one more second, 8 hours later.
Dude,
my SpongeBob voice.
The reason why you're not doing this and somebody else is because it's not as cut and dry as you would think, dude.
It's because I already explained to you why you're doing this. It's because I have to be able to delegate things. I can't do everything.
Yeah. Even Bacon said, dude, this is not easy if you restrict it to the stars for celestial navigation. You make it so they're all visible at the same time. They're all visible.
Bro, can you use the moon? Is the moon in the almanac?
Yeah, the moon's there, but you're not going to use the moon, dude.
It could be one of the spots.
No.
It gives you a lot of spots, doesn't it? The GP for the moon?
But you can make corrections for the moon.
No, just do the stars. Just do the stars. No goofy moon shit.
And who's the dude that you're gonna talk to? 10th man? Jesus Christ. I know that's like a biblical name, but it sounds like
I thought it was a basketball thing.
I thought it had something to do with like a train.
I thought it was a basketball thing, like the 10th man.
I thought he was like the 10th man in a train. All right, hold on. Let me see. See, the problem is I have to check different dates. Then I have to go back and I have to recalculate the fucking star's position because they slightly change. But let me see if this one changes. 29.
What's up?
It does slightly change. This
Just use the obvious. Be obvious about this. Obviously, we're going to need to make these angles at nighttime, right? Obviously, we're going to use the almanac, GPs. Just do the whole celestial navigation thing. It'd be nice if the 4 spots were over some flat level water or something.
See, now I gotta change his fucking position. Hold on. Okay, I think I got it. You there? I got your date and time, dude. I'm only gonna tell you this once, so you might want to be writing this down. Yo, dude, are you there, Jeremy? No, Jeremy, I got the time and date for this observation in the 4GPs. And the angles to the stars.
Yo, my AirPod died for the past like 30 minutes. What happened?
I gave the data to you already, so.
You gave me the data in the DMs?
No, I said it out loud.
Bro.
So that's it, dude. I gotta go. I was kidding. No, I just finished it just now. But did you see the map in the text chat? I posted the map. I'm gonna post the spreadsheet that has all the data. I'll send it to your DMs too.
All right, good shit.
Yeah, it is. Just give me a second. Wait, this is not good. Oh wait, shit! I forgot. I gotta change the date. Okay, so just give me a second.
Bro, you've been saying give me a second. I'm not even lying. At least 24 hours now. It's fine. Take your time, but
My girl hates when I do that. Okay, hold on. Okay, so I'll write this down for you too, but just so you're clear, the date is November 15th, last year.
date, the time.
Yeah. At times 1:14 in the morning, UTC time.
Zone. Is there a time zone?
No, it's UTC times. Make it simple.
UTC. Okay. Write all this down. This is critical information.
Yeah.
You know the time, the date.
It's all in the spreadsheet. I'm getting the angles as well. I just gotta get the. But it's weird that they're all. I thought I made them as far as you could possibly make them, but they're all relatively high in the sky, which is not a bad thing. Oh, there might be.
I should have spent more time with Bacon, telling him what I needed instead of roasting you during the time he was here.
I heard you saying you needed those 4 points over water, and I find those points more or less when I heard you saying that a couple weeks ago.
Yeah, what we need
yeah,
is
that's why I have them.
We need the time, the angles. They got to be from the almanac. Like, there's all kinds of prerequisites with this.
Why do they have to be from the almanac?
You do celestial navigation?
Yeah, but any source does. Like, it's not like the almanac gives you different data than the Stellarium gives you.
I don't know, bro. We got to use
the exact same data.
We got to use the almanac, dude. I don't know.
It's a weird requirement, but
it is. Yeah.
But all right.
Is that how celestial navigation is done? You have to have that almanac, right?
Yeah, you need to know what's the celestial coordinates of the star, which Stellarium also gives you, and it agrees with what you find in the almanac.
And technically, you could, like, let's say somebody was out at sea and they had an almanac for every single star, not just the most common ones. It would work the same way. I'm just wrapping it up. Just hold on. Yeah, it's weird because when I search for these stars, I try to make them like I thought I had to expand the range because like I couldn't find 4 that matched, and so I thought some of them were going to be relatively low in the sky, but they're all above 45 degrees, so it's a good thing.
Oh, this Gleam guy doesn't know the difference between the horizon and horizontal. What would be your simplest way to explain that? The difference between horizon and horizontal.
Well, I mean, the horizon is not horizontal. It's always below horizontal. So.
Well, not always, but mostly.
Yeah, right. But I mean, like
before Jeremy jumps in.
Yeah, no, yeah, that's good. Yeah. Almost always. Jeremy is probably like getting to his mic. He's like, "Holy fuck! Did he just say something? It's always above it, always below it." Shit.
I couldn't get to my mic quick enough just.
Did you hear what I said?
About the horizon always being below horizontal, yeah.
You bring up, you have like just shit that you just always bring up, even though it's like a anomalous shit.
Bro, I bodied. What happened with Bob last night? Was that anomalous?
Now, did you see him in the text chat? He was like, he told me several times. I just didn't respond, but I was doing other stuff. But he said, "Hey, redo the equation, redo your math, and make sure to do this, and make it like wingspan or whatever." And then I just didn't do anything. He said, "Hey, listen, again, can you redo that and post it in the chat?" I just didn't do it. But based on the first thing he said, like I said, from a most extreme example, actually, you can make it more extreme.
Your shit sounded pretty ridiculous, I got to say. 400 miles. I was actually with Gio, and Gio said, your shit is ridiculous. I agree. Your shit is usually, like you said, the horizon below horizontal. Your shit is usually ridiculous.
To go back to the time when I was arguing you about the same thing Bob was, you're wrong. And in most cases, if you vary from that path, it's not going to change your distance by very much. The only way to make your argument is to
you just said 400 miles for 1,000 miles.
Yeah,
you said 40% last night.
Exactly, because I had to make it ridiculous so that you were right. That's the only way that you can make you right.
Why? I'm right with Gio's 5 to 8 to 10% or whatever he said.
Yeah, but that was a guess. That wasn't.
Dude, Bob's shit was a guess. Your shit is a guess. Gio's shit's a guess. Anything I said would be a guess.
My shit was actual. If you do what Bob said and you had a 4 mile range, which is what Bob said. He said you have a 4 mile range, you get to stay within. I said if you bounce up and down in that 4 miles, like you go from the top to the bottom of that 4 mile range throughout the entire route, then you can add 400 miles to it. That would be the only way you could do that. Otherwise, yeah, by not varying very, very much, like just by over the whole span of it, like let's say you go to the top of the 400 and the bottom of it the whole time, you're going to add a lot less than 1 mile.
Okay, how quickly do they adjust? How far off of their straight line path do they get before they adjust?
I don't know. What did Bob say last night?
The length of a wingspan?
Yeah, but I don't think that's true.
Bob Doobie does make a lot of shit up. I'll give you that. I don't think that's. I don't know.
I just don't think that's even practical. That once you're off the width of a wingspan, you can make a correction. That's like a guess or something. But I think it's time based. I think he said 4 minutes.
Yeah, so you could go for 4 minutes at, what do they do, 500 miles an hour? How many miles is that?
500. It's almost 10.
So it could be.
So like 8.
No, it wouldn't be that. It wouldn't be that much though, because you'd have to go in straight vertical or horizontal or straight left or right or something for it to be the maximum case. But
well, no, like if you hit the bottom of that 4 mile range after 8 miles. So what I did, I did it. I basically did it for every 2 miles. No, did I do 2 miles? I did 4 miles. So in 4 miles, you hit the bottom.
4 miles, you're at the bottom, and then in 4 miles later, you're at the top.
Yeah, that's what I did.
Okay.
And if you do it like that, actually, I might have even done 8 miles. Let me see. No, I think 4 miles. Yeah. So basically, just break my shit in half. It's still 200 miles.
I would say the one thing you can get out of distances though is if I drive my car from New York to LA and my odometer works and it says I drove, I don't know, 3,000 miles, whatever. New York to LA, let's say it's 3,000 miles. If my car says I drove 3,000 miles, then it was definitely not longer than 3,000 miles. But you could be sure on that.
That's true.
As far as what it actually is, it could have been 29.99 or 29.87, whatever. Just pick something.
These are all things I've said to you, dude. These are arguments I've said to you when you were the one making this bullshit argument that you never know any distance. And I said,
but you don't have the distance. You just have, what it can't be. I mean, all right.
Yeah, you know the maximum.
You have a cap on it. Great. Now what?
I mean, that tells you something. Holy shit! Hold on. I'm in the wrong place.
One more second.
No, never mind. I just wrote this down wrong. Yeah, these are good elevations. I don't know why.
Right where you got the elevations from. Write down all the critical information I'm gonna need, please.
Yeah, whatever, dude. I don't know how I got these wrong. Well, like I said, I thought that I was at the limits to how far. I thought that was going to be difficult to make sure they were all be able to be seen at night. But so far, every single last one of them, every single last one of them, you can see all of them, and it's at night for all of them. Well, one left. When are you going on Nathan's show?
Whenever I get a chance.
Yeah, well, don't bring me up, all right?
That's what I'm gonna do is mention your name when I sound just like you.
Yeah, just don't do that, dude. I don't want to be associated with this.
I feel like I'm gonna say, Coach, help me make this on purpose now. Like first thing.
Yeah, Cass did that to me during his debate with Whitsitt. I was like, "What the fuck, bro?" Because he asked for something, and then what was it? Oh yeah, for these quotes or something like that. So I gave him some of those quotes, and then he's like, he said that during the debate. Like I was like, dude, like it would be one thing if he was actually arguing good, but he was really shit during the debate. Yeah, you're gonna get massacred on Nathan's show, so. Yo, Jeremy, are you still there? There is one slight problem.
Yo, what happened?
Nothing, dude. I posted it for you already 5 times.
Oh, don't post it for me. Send it to me. I told you I don't communicate with you in Livestream 1.
I haven't posted it yet, dude. Hold on.
Don't ever post, or you can post it if you want, but please DM it to me.
Didn't post it, dude. Just give me a second.
Okay, don't post. Don't ever post it. Just send it to me in DM. Or you can post it if you want, but
You're very confusing, dude. You said I can post it if I want, and you said don't ever post it.
yeah, you can send it. Whatever you do, send it to me in a DM, please. Mad difficult to even interact with you. That's the Glover way, though. That's why you're top 20 now.
You know what's funny, man? I don't know a single Glober who's had to make several accounts because they couldn't get into their account or they didn't know how to, or can't communicate in text chat because they don't know how to, or it's mad difficult for them, as they say. I know
you make it complicated. Like I'm not checking the text right now, so like if I don't check it for hours, we'll by. I have to search and shit. It's just much easier just to send it in DMs.
That's fair. All right, give me a second.
You make everything like 10 times more difficult than it has to be.
Oh, this was.
That's like what you're known for, actually. Remember, I used to roast you about that like 2 years ago in Gems. I'd roast you about how you made everything mad complicated. Was that you or somebody else? I think it was you. Huh?
I think it was me. Well, I posted it in text chat.
Dude. Send it, please. For the love of God, send it to me in the DM. Bro, there should be 12 angles, 4 positions, 1 time.
It's not 12 angles.
Bruh. There's 1 guy. There's 4 guys. They're each getting angles. Listen to me. There's 4 guys at 4 GPs. They're all going to do celestial navigation to the other 3 stars.
That's right.
That's right. 4 guys, 3 stars each. That would be how many angles?
I count 9.
You got 9 out of that?
Yeah, that's what I got.
4 guys are going to each take 3 angle measurements. You got 9.
Yeah, this is why you're outsourcing, dude.
No, this is an example of you get what you pay for. Is what this is.
Honestly, dude, if
4 guys, hold on, listen to me. 4 guys are going to take 3 angle measurements. How many angles is there going to be?
I count 9.
4 guys are each going to do 3 angles, or they're each going to have 3 angles. You got 9. This worries me, Kosho. You worry me sometimes. This is one of those times.
Oh, I know you're right. I was actually looking at what I did, and I counted 9, but I was looking at it wrong.
You're scaring me already. All right, and I know your history, so I mean, this is not a good start. You need another second?
Oh, I posted you the wrong thing, so just give me a second. Anyways, as you can see there, the first thing, that first chart is not necessary, but I made it. I've added it because it was already in the spreadsheet. But that's the great circle distance. Okay. Actually, it might be
the amount. Whoa, dude. There's one distance, dude. The amount of miles between the 2 points. What do you mean, great circle distance?
Yeah, well, that was for me. Okay. And
why did you say great circle distance?
It's got to be wrong. So
you're telling me you sent me wrong information.
I did something. I don't know. I may have done something wrong, but we're gonna find out. Yeah, I might have to look at this twice because something's not matching up. But either way, that's not important.
Whatever you send me, I'm sending right to Bacon and another guy, so it's fine. Just try to get it right. Let's not look stupid out here.
Forget about the first chart. The first chart's not important. The second chart is the elevation angles at the time. Oh, I didn't give you the time. Hold on. Okay. Yeah. So there you go. One slight issue is there may be some seconds involved. This is only the resolution of this test is only by the minute, but they may need some seconds.
Are you talking about time or degrees and angles?
Time. I gave you a time on there. I didn't add any seconds. The seconds might be necessary, but they may not. Depends on.
Oh wait, so this all has to happen in the same moment in time.
Yeah. That's right. This is the same moment in time. It's just 1:14:00. No, 0 seconds.
Perfect. Why are we talking? Okay, so what's this issue with the seconds that maybe I missed on?
Well, the thing with the seconds is at this time, this is the time that those stars are at their GP. But it's not exactly. It's like 89.59 or 89.99, basically. Not exactly 90.
Why can't you get 90?
Because of the seconds. That's what I'm saying. It doesn't matter.
Goofy app or what would? No, it doesn't matter. We got to get. It is going to make a difference.
Not very.
I guarantee you will get a different number. Therefore, the difference.
Well, if 1 degree is 60 nautical miles, then 0.1 degree, 0.01 degree is a lot less than 1 mile, or a little bit less than 1 mile.
Well, okay, what app are you getting these angles from? That it's only in minutes and no seconds.
Heavens above.
Okay, that app sucks.
No, it doesn't suck, dude.
Yeah, that app's trash. I would delete that from your phone or your whatever you got right now. What you need to do is get this one with the seconds, a good one.
My program gives.
Is there any programs that use seconds that are actually?
Yeah, mine and Bacon's.
Okay, hold on. Whoa, some personal app you guys made?
Yeah, dude, I've made it a bot.
Oh, hell no, dude. Is there any Stellarium or something?
Yeah, Stellarium too.
Okay.
So we'll update those. Forget about it for now, though.
Yeah, let's update it. I'll just wait for the final draft.
Yeah, well, it's going to look exactly like this, but just update it.
So if it's going to look exactly like this, then why are we updating it?
Well, if you notice, if you see like elevation from GP, if you look at the elevation from, like, let's say Alpharats to Deneb, or Deneb to Alpharats, they're close but slightly different, like 46.55 and 46.58. I think that if this were done at the precise second, that those angles would be identical. So yeah.
What am I looking at? There's a guy at the GP. Who's the GP for which angle it is? Okay, I'm on Deneb Alpharats.
Yeah. So the way that I did it was the purple. What? The purple is the dude, and the yellow is the stars.
Star above the GP.
If it's in purple, he's looking at those stars in yellow.
Okay.
Yeah.
You could not have made this more confusing, but
dude, yeah, come on, dude. Honestly, I thought about that. That's why I fucking made them 2 different colors. Okay.
Okay. What about the one that's not? What about the ones that are the same colors?
That was my personal chart. That was for me to figure out which stars.
Bro, there's so many of these charts. Which one's the real one?
Well, the one that says elevation from GP. There's one from distance to nautical miles, or
I see it.
GP nautical miles, and then distance to GP in kilometers. Those ones are relevant.
All right, nice work. We're gonna go with this. Wait, is this good? We need to get dude. We need the seconds, bro. These distances are everything. If your angles are off by a matter of degrees, and
no, it's not degrees. It's it's like 0.01 degrees.
by parts. If your angle is off by parts of a degree, my distances are going to be off
by less than a mile. But
you don't know that. You just made that up, like Bob made the mile up last night with the airplane.
No, I thought no, dude. 1
Stop
degree.
making stuff up.
1 degree is 60 nautical miles, right?
Yeah.
That means that if you divide 100 by 60, right? That means that gives you, what is that? 1.22 miles.
Times the square root of the observer's height in feet. What's up?
So if you're off by 0.1, if you're off by 0.1 or 0.01, then you're off by 1.22 miles or 1.2 miles. 1.26.
How big are these dots? Hold on, let's see what these distances look like. Oh, is it on the big map you sent me on
The
that?
map that I posted. Yeah, that's right.
All right, so hold on. Dude. Did you really use 2 spots almost on the same latitude?
I didn't. Listen, dude, that doesn't matter. Why does it matter?
Where's the 4th spot?
There's one in Canada, in Newfoundland, one in Portland, 2 down, one in the Bermuda Triangle, one in the Gulf.
Bro, you couldn't use something over in like Mexico or something? Like what?
Yeah, dude, I was really had so many stars and positions to choose from. These were the only 4 stars that worked.
Bro, I don't even know if this is gonna work. This is a pretty big this is a pretty big shape though.
Yeah, it's just big shape, but it's big enough. I mean, it's
it's a big shape.
If you were to draw this out on a flat piece of paper and calculate the distance from Washington to the Bermuda Triangle, and then compute it with these stars, you're gonna get 2 different things. So that's the last thing I didn't add. That's right. I do have the distances on Google Maps, but you're gonna want the ones from the Celestial Navigation. Let me find the fucking seconds, dude.
It's fine, bro. We're gonna update this, and it'll be different, and then we'll have the updated version, and we're good.
Yeah.
This is good. I don't like the bottom where these 2 latitudes. It's fine though. This should work.
Okay, but see, so there's one thing that I might have written down by mistake. Let me see. Yeah, there's something seems wrong. 75. Hey, give me a second. There's a big variant.
You're doing this to me on purpose.
No, dude, there's a huge. Sometimes I gotta double check my own stuff. You know what I mean?
This is such a weird shape. Is this gonna work?
It's gonna give you something. You just gotta calculate. Just use a triangle calculator. Use some kind of calculator that tells you the what's the equation for that? Actually, let me see.
We'll figure that out after. Just get all the angles and the distance. Just get all the angles right. And the time to the seconds. Can't we measure to the billionth of a second? You couldn't get into the just regular seconds?
Dude. No.
I'm just saying, we're so sophisticated and we can measure to the zillionth of a second with an atomic clock.
Yeah, we're talking about what the almanac is telling us, though. The almanac has to tell you where it is. If the almanac's not telling us where it is, then, or whatever we're using.
Oh, I see what you're saying. Okay.
Yeah, what the fuck?
Is this like a farmer's almanac?
No. No, dude. Have you never looked at the almanac?
I've never seen an almanac.
Oh my god, dude.
I've seen a farmer's almanac.
Dude, there's a way. If you literally type in nautical almanac, it'll pull up any almanac from any year.
Never heard of it.
Yeah. Well, I mean, I'm telling you that this is when you go and share this with those dudes, this is how they're going to act to you. They've never seen this shit either. Okay?
No, they must have.
Yeah, they must have, but they haven't. But what is this?
Where's George at? We could use George right now.
For consumer and brand accounts?
What's up?
What the hell? It says, what? First of all, I just did all this shit in Google Drive, right? Oh, Google Plus. Okay, never mind. What is this doing? What's going on? Hold on, man.
First thing you got to do is stop playing games with Google. I know what you got going on over there. You got some weird shit going on.
It took me to
How
Google.
many Gmail accounts you got?
Several thousand. Over 1,000. Over 1,000. 1,030. Yep. All right, hold on. Alvarez, and then
1,030. Very
Yeah.
precise.
So something's wrong here. This isn't a good.
How long can you go without logging into a Gmail account before they delete it, or will they ever?
That's a good question. I think there is a time limit, but they haven't deleted any of mine.
All right.
So, for instance, like the time that I have, this star, the Alpharats, it's at 89 degrees 58 minutes. So
you're only 2 minutes off.
2 minutes by angle, yeah. Like the
how much is the angle off? I thought you were talking about, dude. You're fucking me up with the minutes and seconds thing.
Yeah, well, that's what I mean. It's 2 minutes by angle, right? So it's like a couple of seconds in time off. I just don't know how many seconds.
Well, how much is 2 minutes in angle of 60? How many degrees is that?
Well, it's like 0.98. So I'm sorry,
it's almost a whole degree.
No. I meant it's okay. So it's like 89.98 is what I'm saying.
Oh, so it's only 0.02 minutes off?
Yeah. 0.02, yeah.
Minutes?
No, 0.02 degrees.
Oh, 0.02 degrees. Okay. How much distance?
So if I go 1 minute later,
this ain't gonna work. This ain't gonna work, bro.
I'll just find the seconds. I'll find the seconds. But if I go 1 minute later, it's 89.75. And if I go 1 minute prior, it's 89, basically 89.75. So it's 89.75 in both cases. So
you can't get it to be 90. Go 1 second later.
Well, no, it's they're both off. 1 second later and 1 second prior are both off, or 1 minute later they're both off. So I gotta find what second gets it precisely at the GP. But the thing is, once I find that second, all of these stars will be at the GP because all these stars, the locations I gave to them are like anywhere I translate. If I anytime you change it, they're all going to be the same angle in reference to their star. Anyway, there's one thing. Oh yeah, sorry. I needed to make sure this is correct. Yeah, because I have something weird going on.
I don't understand why is this so hard.
Yeah, I know you don't understand why it's hard. It's because you're not doing it. That's why you don't understand. Remember, Bacon even said, it'd be difficult. He didn't say he wouldn't do it.
I mean, are the sailors using the almanac, right?
Yeah.
There's four guys.
Not anymore, but still, I mean, they used to.
When they were doing this, they were using the almanac. We've got 4 guys lost at sea right now. They're all under the GP when they're at 90.
Not at all. Not at all. The thing you're requesting is not normal. Okay, it's not a normal thing that people.
I'm pretty abnormal. It seems like every time I go shopping or run to the store or something, I'm looking for this weird thing that they may or may not have, and they sometimes don't. Right? You ever find yourself in those situations? Like that happens to me often, where I'm looking for this weird thing that may not even exist. I'm not sure.
You always bring up shit like that, dude. You always bring up shit.
I know.
That's one thing that's cool about the flat Earth communities. They bring up these questions and these random things that no one's ever heard people ask for.
Yo, Coach, I got a question for you, bro. Why the fuck your profile pic is like a fucking 9-year-old Puerto Rican kid with a suit?
It's supposed to be me as a baby. That's the AI made that picture of me as a baby.
Bro, that's a black kid, bro. That shit look like a Dominican kid, bro.
Well, I'm black, and I've pretended to be Dominican before. So you're from the city, right, Matrix?
Yep, yep.
You from Queens?
You're from the BX, right?
I'm from the Bronx, bro.
Yeah.
Oh, I'm from the Bronx.
Kosho don't know the city, dude. You've never
I
even
don't know
been
the
to the
fucking
city.
city. You know what I did?
Probably never even been to the city.
Fuck you, dude.
Do you have any
The other night.
pictures of you in the city?
That's where I'm from, man.
Do you have any pictures of you in the city?
A picture of me in the city? Is that what you said?
Yeah.
No.
I mean, we ain't buying it then. You could at least Photoshop one and been like, yeah.
Let's see. What part of the Bronx do you live in, Matrix?
You got MapQuest up right now.
What do you mean, what part?
What do I mean? What part? How do I fucking clear that up? What do you mean? Like what part of the Bronx? Like what do you mean? What? Like you live near like Fordham, near somewhere else?
You know how like Brooklyn's broke up into like Bed-Stuy and Greenpoint and like all kinds of like little borough type things.
Well, the boroughs are already in the city, so the Bronx is already
not boroughs, but little smaller sections.
I guess what street? Like what's a big street? What's that one street called?
Bro, Kosho wants your GPS location so he can watch the ISS pass overhead and hold hands with you.
I'll tell you. Do you know where Valentine Avenue is? Matrix?
You got MapQuest up. Kosho got MapQuest up.
Or Webster?
Valentine Avenue? Yeah, I know what Valentine is. They said, hold on, man. I'm playing Call of Duty right now. That's why I have to pause the game and unmute and shit.
Can you hear us though?
How can you pause Call of Duty? What are you playing? One player mode?
I'm playing online. PC.
How'd
you pause it?
How'd you pause it? You fucking liar.
But I'm
I hate calling people out for lying, but
No, I'm just with you. Yeah, if you can hear us though, that's where I'm from. I'm from Valentine Avenue. The building. I won't tell you the building because I might narrow it down. My docs.
No shit, you live in the Bronx?
No, that's where I'm from a long time ago.
Yeah? Oh, nice. Bro, this the hood, my nigga. So if you from Valentine.
Yeah, no, dude.
You grew up in the hood.
he never left the house, bro. He never let his mom never let him leave the house.
Shut the fuck up.
He was probably 2. How old were you when you left the city?
I mean, I lived there. I went back. So when I left, I was probably 8, but I'd go back every summer until I was like 12. Dude, if you're smart, you get the hell out, dude. I mean, now it's actually a lot cleaner, but
So many people come to upstate New York from the city. That Chinese bus runs fucking nonstop, dude. They're constantly bringing people just that are like, yo, fuck it, I'm out. Kosho, please don't fuck this up, bro. When I give it to the guy to check it, I need it to be right. I need 90 degrees, bro. Come on, please. You're the genius at everything, remember? Don't let us down. As soon as we get this shit all straight, I'm gonna get the geometry guys on it. We're gonna see what's good with it. Gonna help someone.
all right, sorry. I didn't hear anything you just said. It was probably insulting. I don't know what it was. Jeremy's talking shit, and he lives fucking in Canada. Probably have a fucking Canadian license, driver's license.
Bro, every time I try to go into Canada, I used to get pulled over on the side. They would check the whole car, check us. Huge fucking hassle.
Yeah, I saw this show. Like you watch, like Locked Up Abroad. I think it was Locked Up Abroad, and it was this dude who lives. I think he lived in Canada. Yeah, was he? Yeah, I think he lived in Canada, and he was a Canadian hockey player, and then he got into like selling weed because they would like because he was a hockey player, like he would just say he was going to hockey games, and he would just have it in his like hockey bag or whatever. I think he was actually a pro hockey player. But anyway, and he got caught. So they were actually making a lot of money. That dude.
Oh yeah, a lot of weed comes in from Canada. They used to. I don't know about nowadays. Probably growing here now.
Isn't it legal in New York now?
Yeah.
Yeah, but like
there was just one of the. I don't know what he was. Some fucking board official on the government thing or something. But he's like, "Yo, what's going on?" He's like, "We passed this bill to make marijuana illegal, and now or decriminalize it or whatever." And he's like, and it's taken him forever to get like the go ahead for like the dispensaries and shit. Because right now everyone goes to Massachusetts, and it's dumb expensive. The taxes are fucking crazy.
Well, you understand that that's illegal.
It's double the price. What's illegal?
To go to Massachusetts and get it.
Well, it's legal there. It's legal here.
Yeah, but you're crossing state lines, and
how do they know?
It's a federal crime.
It's a federal crime, anyways.
That's what I'm saying. It's federally illegal. You're crossing state lines and buying something that's interstate commerce. So it's a federal offense, and it's criminal.
Well, I don't do that, so
it's just fine if you don't.
I've never been to the thing, but if you go there, it's all filled with New York plates. Anyways, the point is, it's double the price of Cali right now.
It makes
like
sense.
a gram of THC juice costs about $70, $60-$70 for the vape, THC vape, and it's a half a gram.
No shit.
In Massachusetts, but in Cali for a whole gram, so double the price, it's like $25.
Yeah.
So it's like a third of the price for double the amount. It's crazy.
Supply and demand, dude.
It's not what's going on. It's the taxes it's Massachusetts has wild taxes, I think.
New York has wild taxes, dude. Like it's cost.
I think they're going to have low taxes on the weed, though. Yeah, but I think they're going to have low taxes on the weed because they know they're going to fucking crush it.
Yeah, but dude, look at cigarettes, dude. Their cigarettes is like $16 a pack or something like that for Marlboro.
They're bugging. Yeah, they're like $14 a pack.
Dude, that's already double here.
That's upstate in the city. They're probably even wild. What are they, like $20 a pack in the city, Matrix?
The Matrix would know. I mean, I remember 15 years ago it was 15, 16, so it's probably $20. You get a carton.
I actually don't smoke cigarettes.
Yeah, no, but I mean, you know how much it costs?
Nah, I just smoke weed.
Yeah. I gotta buy it for my girlfriend.
How much are they there in Texas? Probably cheap, ain't it?
$8 for Camels.
Yeah. When we went to Florida, I grabbed a couple. To Florida, I grabbed a bunch of like menthol vape cartridges for my wife. She quit smoking cigarettes, and they were dummy cheap.
Yeah, you gotta buy well, I guess she does smoke cigarettes.
I roll my own cigarettes. They're dumb cheap.
Yeah. If you want to buy fucking cartons, my mom used to do that when we'd go to Mexico. She'd buy like cartons and cartons of cigarettes. Haggle with them.
In Mexico?
Yeah.
Bro, when you start getting cigarettes from other countries, they stop being Class A cigarettes. Like if you buy Newports, they'll be Class A cigarettes. One time I ordered them from Russia, and they were Class B or C, I forget.
Yeah, because they were probably made in China.
I don't know. I'm just saying whatever. Once you get, what do you think? You think Mexico's It doesn't matter.
Yeah, I think Mexico's better than China. Yeah, and I think if you buy shit in Mexico, okay, most of the shit we buy now is made in Mexico.
You think Mexicans are better than Chinese people?
Yeah.
Wow, that's fucking racist, bro.
Well, I got news for you, dude. It's true. In my opinion. Maybe not at karate, but yeah,
like that.
I mean, they do a lot of fucked up shit though, dude. Like, I mean, weed though too. You get weed from Mexico, so it's like swag.
Oh, dude, that Mexican brick weed back in the 90s, bro, that shit was brutal. They used to compress it as much as possible, so it would literally be a brick. Like now you buy a pound or whatever, it's like nice and fluffy, takes up the whole bag. Before you would get like a pound, it would be like this teeny tiny little brick, just compressed. I don't know what the fuck they were compressing it with, but
well, someone told me they put Dr. Pepper in it or something, and to keep it like wet or something. I was like, it kind of makes sense because it shows up as all shitty as fuck. It's so much shittier than like good weed, you know. It's crazy. I think so. I think it's that, and it's also the way they grow it. They don't really take care. You know, they don't care if there's males in there.
They just pop a seed out there, and they're like, well, yeah, half the shit used to be seeds and stems back in the day. Yeah. I haven't seen a seed in fucking like 20 years.
Dude, when I grew shit, that's because the guy I used to get it from, he got a batch that had a bunch of seeds in it. I was like, dude, let me keep some of them. So I kept all those seeds, and I grew like so many plants with those seeds. I grew a bunch because I grew a shit ton, and then I had trial and error, and then finally I had a couple good ones, and then I grew them to maturity. It was the best weed I ever had. Hey, dude, I don't really feel like doing any more of this shit, dude. I don't feel like going and looking up these seconds and all that kind of shit. I'm not gonna do that. I was supposed to be looking up. Oh, you know what? There is something wrong on here. Whoops. All right, hold on 1 second. What the fuck? I made a big mistake. I'm glad I caught that, dude. If this was somebody else, they wouldn't have caught that. Wait a minute, now it's even worse. Hold up a second. Okay, I see what the problem is. Okay, so I did make a mistake. So that picture that I sent you is gonna be wrong for a couple of reasons. But I'll update it with the seconds, and it'll fix all that. It's gonna be hilarious, dude. You're just not ready for it, dude. You're just really not ready for it, and it's gonna be hilarious. Actually, I mean, like I said, as a friend, I would say don't do it because, I mean, when I told you that you're not gonna come in here, I say that because I've had experiences in there where I didn't go back in gems. Yeah, usually I'd be in gems and then I go back in gems or something, But I would just be it'd be such shit that I wouldn't go into gems afterward. I'd be done with Discord for a day. You know what I mean? I would just fucking go away and do something else. Sometimes 2 days. But the main reason is because they get mad at me when I go on Nathan. So, so I guess it's a little different. Fuck, I did what Percentage said, and I downloaded that game, Kerbal Space Program, or Kerbal Space, whatever, and I didn't do the tutorials or anything, and I fucking sucked, dude. I couldn't even get the rocket off the platform. I'm blowing it up. Okay, I saw another mistake that I made. Hold on. Yeah, just a couple typos, man. And actually, these typos are making my other data look much better now. Like it's matching the other data, so that's good.
Yeah, what happened? What happened?
Pretty quiet tonight. Pretty quiet. Every time I explain to this guy at work how the Earth's not round, he says, "What about the sun?" I said, What about the sun?" I said, "You got one somewhere in the lab we can look at?" He just looks at me funny. And I'm like, "What about the daughter?" Yeah, wherever Jesse Gordon's got a building that's missing, half of the building, 200 and something feet, I just challenge him to fly out 1 foot above sea level or any water he's got that equates to that distance, and then drop your drone down 240 feet without getting it wet while it's over water. Curb water. Should be a piece of cake to go on the other side of that hill water and not get wet, right? Drop down below the water, the horizon. How do you drop down or go below or past a horizon in a boat when a boat's connected to the very thing that you're calling the horizon? And the boat is the thing you're using to establish whatever a horizon is. Because without an object, you're just looking into the distance. You know what I mean? So a boat can never leave the horizon. Only an airplane could drop down below the horizon and not get wet. I never really knew what that song meant until I realized Globers are going out, flying out over the water hump and dropping down, and they're going underwater but not getting wet. I never really knew what that song meant. It's a cool song. Yeah, you can never not drop. You can never drop below the sea's level. You can only drop below the horizon's level, which is just from your feet, an imaginary horizontal line from your feet out. You can't ever drop down below that where there's water.
Hello. Room is dead tonight.
What's going on?
Like Saturday service or something. What's going on here?
I don't know. What's up?
Not much, Just got bored of some conversation I was listening to. Thought I'd pop in and see what you fools were doing.
What was it? What were you listening to?
I had Mr. Batman for a little while. Stopped into T-Jump server for a minute. Yeah, they were.
I don't even know what you're saying. Never mind.
And gosh, yeah, I didn't figure you would.
Never mind.
Just a lot of bouncing around, listening to nothing. To sum up. Trying to enjoy this beer. I was looking for something new I hadn't had, but I was hoping to get like a porter or a stout. But I saw this winter ale, and I'm like, I like winter ales. It's pretty good.
Oh, nice.
Freezing Season by Flying Dog Brewery. What you been up to, Jeremy? How's life?
Killing him. I've been killing him, bro.
Yeah, have you? You doing pretty good, man. How the kids and the wife and everything? Good?
They're good. Good. Everything's good. Yeah.
Nice and strong and healthy and smart.
It's sweet.
I'm gonna turn the noise suppression on. Somebody's vacuuming. I hope it's not fucking with my sound.
I'm doing dishes. You can hear that?
No, I'm vacuuming. Like, I didn't hear you doing dishes.
I didn't hear you vacuuming. We're good. The noise suppression is excellent. I was actually sanding a deck one day, and that shit was dumb loud where I was, and I was fine on the mic. I think the noise suppression is too good, and it causes a delay sometimes.
Yeah, the only problem I normally have with the noise suppression is just that it cuts off. It doesn't pick up my voice all the time.
Yeah, I got some of that going on too. Yeah,
It doesn't pick up laughter. You won't pick up when you laugh.
Bacon, here's what we need, bro. I don't know how hard this is. We need, in one moment at the same time, I need 4 dudes at 4 GPs. I need them to all be able to celestially navigate, take the angle to the stars with a sextant at those 4 GPs to all the other 3 GPs in this 4-point thing we got going.
Well, it doesn't have. Well, why would it have to be at the same time?
It all has to come out of the almanac.
Yeah, but it doesn't have to be at the same time, right? For example, when a star is over my head, I can then tell the other 3 guys that, like, the star is overhead to me.
Well, yeah, if I get the
take your measurement now.
If I get the distance to 1 point, that distance isn't going to change. We can always just be at that point later, and then do the other measurements.
Sorry.
Why do you want to go through all that trouble? Just come to the globe side.
Why didn't Kosho think
take
of
it
that?
as
Bacon,
faith.
you're on point, Bacon. What's up, Damon?
Why go through all that trouble? Just come to the globe side. Forget all that measurement and stuff. Just take it by faith.
Forget the measurement.
Just
forget
go
all
along
that
with
measurement mumbo jumbo.
Yeah, fuck all that. That's too much work.
Bacon, why didn't Kosho think of what you just said? It's because he's not as good as you. Why didn't Kosho think of what you just said? Why does it all have to be at the same time? It doesn't. You could do one. You could do one GP. You got the 4 GPs. You could just do them at different times.
Yeah.
I guess
I mean, it would make sense that when the star is overhead to one person, that the other 3 take the measurement to that person, because that person can confirm that the star is actually overhead. But not all. All right, go ahead.
The reason why I would want it to be at the same time is to just sort of take out that variable that nobody could contest any kind of funny business because it would be taken at the same time.
Yeah, well, I mean, if they take at the same time when the star is overhead to that person, yes, that'll be ideal. But then when the star is overhead to another person, that's when you want to measure to their position. Like, you don't need the stars to be aligned above the 4 people at the same time.
You don't, and it makes it way harder, right? How much easier would this be? How much easier would this be if it wasn't all at the same moment?
Well, I wasn't trying to go for all at the same moment, and it was already quite hard. So imagine if you need them to be at the same time, it would be much harder. But it's not that easy, even if you have flexibility of the time.
Really?
Yes, because... Sorry?
I'm not understanding why it's hard.
Because you don't have stars like in all latitudes. You only have 59 stars. And you probably want to do that in the northern hemisphere, because where most people are. If you pick stars on the southern hemisphere, it's very likely you're not gonna have them where there's people. So you do that on the northern hemisphere. So you have half of those stars. Now we're down to around 30 stars. And
well, it could be a little bit in both. It could like cross the equator or something. Whatever's.
Yeah.
Okay, you do one GP. My initial thought was to do it all at the same time to eliminate any wonky shit, but it really doesn't matter, because if you do all 3 of them, okay, there's a star at a GP, the other 3 guys do it, and then later on the other 3 do the other stars. Yeah, it doesn't matter.
Yeah, exactly.
You still have their points. Yeah, Kosho should have thought of that. That's why you took a spot, bro. Nice job.
Thanks. Well, but,
how do we know he didn't think about it and just rejected it?
The other problem is... sorry, go ahead.
Go ahead, Megan.
Yeah, the other problem is you can't pick stars that are too far away from each other, because if you do, then one person can see that star, but the other person is still during daylight. If you want all 4 stars to be both visible to the other 3, and also be the whole thing have to be in nighttime. So you have to pick a certain portion of the sky to do that. You can't just blindly look at their latitudes, because that will give you stars that are over daylight. So it makes things a little bit harder. And the other thing is to keep looking in the map, trying to find place where there's people that also match the latitude that you are.
It doesn't have to be. This doesn't have to be. This could just be at sea, whatever. Like this could be in the middle of the Pacific.
Oh, but then people have to go there to take the measurement.
Yeah,
isn't that easier to just here's a populated city, let's call someone that lives there or something like that?
What exactly are you trying to do?
What am I trying to do? I'm trying to get 4 points
from the beginning.
Can I explain?
I'm trying to get. Go ahead. Yeah, go ahead, baby.
Right. You know that if you get 4 points on the surface of a sphere, and then you measure the distance.
Any surface.
Right. Let me explain it this way. So if you get 4 points on the surface of a sphere, that gives you 6 distances. So you have 6 pairs of points among those 4 points. So you have the 4 distances around it, and you have the 2 diagonals. If you try to use those same 6 distances on a plane, you can't fit them all on a plane. So if the distance comes from a sphere, they don't fit on a plane. But if they come from a plane, they also don't fit on the sphere.
Yeah.
Right. So here's the thing. If you have enough distances between 4 points, you can distinguish between a plane and a sphere.
Kosho would have never been able to explain that. That's why you're just better than him. Nice work.
I just want to be mean to Kosho.
Why the Kosho bashing? I mean, he's not even here to defend himself.
Yeah,
he's messing with Kosho. Yeah, well, but the idea is that one. So
did you follow that though? Did you follow that, Damon?
Yes, I follow you.
And there's the claim that you can turn
you.
elevation angle into distances. So, like if you get the distance from Google Map, you're going to easily get someone saying, "Well, we don't know that that's the right distance. We don't trust those distances." Right? So some flat earthers trust the 6 nautical miles per degree. So if we then, instead of going to Google Maps, we go to elevation angles to stars, now they should accept those distances, at least the ones that trust 6 nautical miles per degree. And so if we get the same distance that we get from Google Maps, then we can distinguish between a plane and a sphere based on those distances. So does that make sense?
I mean, this is all interesting, but all this stuff has been done like over and over and over again. I mean,
I think so too.
Like, why are we doing it again?
To German's satisfaction.
If it's been done, let's see it.
No, Jeremy.
Let's see the 4 points.
No.
What do you mean no? Why no? I thought it was yes. You were just saying yes a minute ago. Yes, this has already been done. Yes.
Well, yes, but I mean, I'm in the secret society and you're not. You refuse to come along to our secret society. Why would I let you in? You're rejecting.
I don't know.
You're rejecting what you need to believe to be in our secret society.
We're science deniers. I know.
Yeah. See, so yeah, we're not letting shady people into our society. Fuck that shit. No. Yeah, I ain't showing shit.
Area.
Wouldn't believe it if I did.
So Bacon, ultimately we need 4 points where they can all see each other at nighttime and they can all make the angles to the stars. It doesn't have to be anywhere. I mean, it would be nice if it was in cities and shit. If it's not, whatever. If it's not, whatever. I don't know where these guys are getting their angles from. I mean, can we trust Stellarium? I don't know. Or what app would you use to get your angles, Bacon? Let me ask you that.
I use Stellarium pretty often, and
Stellarium.
I think that it's pretty accurate because when I took my section measurements, I checked them against the Stellarium, and it was very, very close.
Very, very close.
Yes, there was at most like an arc minute difference.
An arc minute.
Yeah, that was I think the worst that I got.
Quick question, Jeremy.
And also, there's the fact that people use Stellarium to do astrophotography, which also requires a lot of accuracy.
Have you seen the YouTube guy, the science guy, or not necessarily science guy, just kind of I don't know. His name's Vsauce. Have you seen that YouTube channel?
Michael Stevens, yeah.
Love Vsauce. It's great.
Cool guy,
that's
right?
That's good shit.
He does some good shit.
Yeah.
You seen the
Action Lab, Vsauce.
Have you seen his video called "Which Way Is Down"?
I don't think so.
Oh, man,
that's one of the best. Is it the one in which he mentions like how local gravity works?
I'm not gonna lie, it sounds like the worst one.
Like when he explains how centrifugal force affects gravity, how the density of the ground affects gravity, the uneven distribution of mass of the Earth affects gravity, the bladness, all that.
Bacon, let me ask you this: if we had an uneven distribution of mass underneath us, and the Earth was flat, could you make different weight changes at different latitudes from that?
Probably, yeah.
Yeah.
Like if we had a less dense Earth around the equator as we have on.
I
on the
posted
poles.
that. I posted that video in the chat. It's pretty good, Jeremy. I think you should watch it. Really, it's not that long even.
I know which way is down. I didn't need to have a formula or a theory or a law. I didn't need any kind of law of down. I didn't need any of that, bro. I know which way down is.
Which way is down?
So
Which
if you had
way
a
is-
sinkhole in the earth, that would throw off the plumb, so the plumb wouldn't be plumb, would it?
What?
If you had a sinkhole under the ground, that would throw off plumb, because plumb wouldn't work, right? Would it? Because there's no mass there. Logic.
You should watch the video.
Anyways, you find down by you could hang a plumb line, whichever way the metal point. You got a string and a metal ball, whichever way the string and the metal ball are pointing. Boom.
Good. That's very good, Jeremy.
That'd be one way.
But if you had a sinkhole, it wouldn't be correct, Jeremy, correct? According to the globe.
A sinkhole?
If you were on the side of a, if you were,
have you heard of a geodesic?
If you were in a,
what is that?
If you're on like the side of a mountain or something, yeah, it would throw the plumb line off.
Yeah,
an underwater chasm. That's
like down wouldn't. If
empty.
you were at the top of the plumb line, down would not be. I mean, I guess that would be down the plumb line, but I don't know.
No, if you had an underground cave, which is like to the left, and you were going down plumb, the plumb would not be correct because the mass is out of place.
But I'm sure there's a few things that could throw plumb off.
Mass is certainly the key, right? So if the
Earth, there's other key factors.
If the Earth is around, it even if it was flat, and there was something called gravity, as we know it, not that could happen, but let's just say that if there's certain areas of the flat Earth that are more dense than others, you would have variations in technically what down would be, because if you stand next to a large mass, like a more dense area or massive area,
that would throw off
down
plumb, right?
Down would be affected to some extent, right?
If you had a cloud, say you had like a cloud, say you had a cloud on the side of you, like not straight up, but like off to the side a little bit, like I don't know, some degrees, that would throw off down. They do it. They have a building in like Europe or Germany or something, and they test this. They said when the wind blows hard, Kosho was telling me all about it one day. When the wind blows hard, when there's weather, when there's clouds, like all kinds of stuff be throwing this direction of down off.
I don't know about that.
Well, I do know about it. So does Kosho.
I just said I don't know. I don't know what you're saying. Are you saying wind affects down?
There was a whole bunch of shit that affected it. Yeah, storms. There were storms affected it. Clouds.
Really?
I think he said there was something about the wind. I don't know. Different pressure. There's a whole bunch of areas. This is like one of the most controlled things that they have. It literally changes the rate. The rate of gravity changes in one spot. Like just because you have the same amount of mass under you doesn't mean gravity stays the same in that spot. In fact, we know that does.
It would, unless mass is changing, then gravity is the same.
No, it does. No, I just told you there is
or
a building.
If you have other unless there's other forces such as the centrifugal force or other forces.
Dude, I just told you there is a building somewhere. This building doesn't move; it stays in one spot. This thing doesn't move. This whole mechanism is not. It's static.
Tall buildings move.
Dude, there is a building that it stays in the same location. If you want to say the building's moving and that's what's throwing it off, all right, that's not what they're attributing to it. The scientists and people that are actually doing it are attributing it to weather patterns, and that. So,
well, explain what you mean though by like you haven't finished the thought.
Jeremy, buildings move because the Earth's crust shifts over time, right?
What? Okay, yeah,
this is globe logic.
It's true.
I'm just telling you, I don't know the name of the place or the thing or anything, but
that's
there is
true
a building
that
somewhere.
the Earth's crust is moving. However, that's not what we're talking about here. He's saying that the wind is affecting gravity. I don't understand.
Yeah, wind, clouds. There's a bunch of different effects. There's a bunch of different things that these scientists who are measuring gravity, the downward rate at which things fall.
There's only two things that can affect gravity, and that's mass or another force acting against it, or opposing it in some sense.
Well, maybe check with Kosho and get the name of the place, and then you can look into this and see what's up with it. But gravity does change, and if you have a static spot, gravity will change in that spot. Not constant.
The direction of down might change, if that's what you mean.
The rate at which it falls changes.
The magnitude.
The rate at which it falls.
Well, the magnitude of gravity, it can only change if there's changes in mass or there's another force acting upon it.
Whatever. I don't care. That's what you think, fine.
Or distance from.
I mean, name another thing. Name another thing.
I think Jeremy's talking about going up in the air because it'll get less with the square of the distance.
Yeah, if you go up, yeah. Away from mass, yeah, the distance.
There's another thing. Electrostatics, or would you say that was part? What did you say could change it? A force or a mass?
Electrostatic.
What did you say? A force or mass could change it?
I'm saying that changes in mass or the distance between those two, the masses, or another force that's acting against it in some way, such as centrifugal force.
Or magnetism, or electrostatics, or
well, I mean, magnetism, generally speaking, is like pretty obvious, right? Like, so if
it's included in the forces thing.
Yeah,
I'm just telling you, there is a building.
Well,
I'm just telling you, there's a building, and it's not moving, and gravity's changing at this point. It would also have to change.
Gravity's changing. Well, gravity's changing.
Even in your own
what do you
paradigm.
mean? What kind of building? How tall is the building? What's it made of? What are you talking about? When you say the gravity's changing, is it change when you move up and down the building? Is it changing where you're standing still? Is it changing? Like, you're not giving me any details.
There's a spot
I'm
where they
trying to
drop
get it out
things.
of you, but you're not giving me anything.
There's a spot where they drop things, and the rate at which this thing falls changes. They keep dropping it from the same spot.
And
what?
So what's your take on that?
They don't attribute it to the wind. They don't attribute it to the building shifting or whatever. They attribute it to weather patterns.
Well, okay, that makes sense.
Whole bunch of different things.
That makes sense. It's simply like when you do it in a low pressure system, or if you do it in a high pressure system, I would expect the air resistance to cause different.
I'm pretty sure they're doing it in a vacuum, dude. I'm pretty sure they're doing it in a vacuum.
What? In a vacuum?
I was gonna say humidity could affect it,
but
you
say it in your high voice? Yeah, in a vacuum.
How do they have a?
Why'd you say it in your high voice?
It's not changing unless there's a mass change.
How do they have a vacuum
or centrifugal force
tall enough?
Yeah, and there's mass changing when a cloud goes overhead or a cloud's on the side of you. The mass changes. Yes.
Oh well, that's what I'm saying. There's mass.
There's also electrostatic forces with lightning storms and stuff. There's a bunch of different things that are changing this. They had a bunch of different things they were attributing it to.
How much
None
is the
of them
rate changing?
were the building. None of them was the building change. How much is it changing? It doesn't matter.
How much are the? Well, I mean, is it within the error of the instruments measuring it? Is it so minute that like it can be contributed to things like clouds passing
That's a
by
fair
or something?
question.
What? I mean, come on,
Yeah,
dude.
well, whatever it is, it's changing, and also it would have to change in your paradigm. Even the direction,
We're not saying that it can't change, so I'm not bothered by any of this. I don't know why you are.
Well, even if the direction of it would have to change in your paradigm when a cloud, if there's a cloud directly above you,
Sure,
and then that
absolutely. The direction of down changes depending on the mass of underneath of it,
or on the side of you,
other
or on the
forces
side of you,
acting
yeah,
upon it.
In any
or
direction.
on the side of you, yeah.
Absolutely.
So, what's your point?
Nothing. That's what I'm saying. Like your point is kind of like I'm wondering what you're trying to get at. Like, who cares?
I was just talking about how down changes in your paradigm.
Yeah, it does. It absolutely does.
But you know how you can
how they
tell
measure?
whether it's gravity or something else, Jeremy? There's something that you probably haven't thought about.
No, but I'd love to know how they measured plumb lines not being plumb.
That's easy to do.
The rump is fold. You sure the rump is folded on this one? Are you sure this is easy?
Yeah, I'm very sure.
Oh, okay. How they measure plumb lines not being plumb?
Well, reciprocal zenith thing was the easiest way. You can
No,
measure
there's a
up
plumb
hill
line
5
at the
miles.
Schehalian.
If you
there's
You can measure up a hill 5 miles. You don't have to
about
worry
a
about
single
traction.
plumb line, Zanuck. I'm talking about a single plumb line not being plumb.
If you
Not being plumb to what?
take several plumb lines at various distances in a straight line, they should be at an equal sort of like an equal sort of set of degrees off if you're on a sphere. So if,
we're talking
if any
about
of
one
them
plumb line.
if any of them measure
I can't do this
slightly
with you guys
off
right now.
from what we would
Damon, he's saying one
expect,
plumb line.
I'll come back later maybe.
Damon, he says it's one plumb line.
Also,
and I want to know, it's got to be relative to something else, Jeremy.
oh yeah, that's true.
No, they can just tell if one plumb line's not
So what?
plumb.
How do you tell? What do you compare it to?
That's what I was going to ask you because they've done this and rump is folded on this. You told me it was easy just now.
I'm not
Now that you
folding on
understand the question,
It's
I said the
easy by
rump is
using
the
another
rump
plumb
is
line.
folded on it.
When they're flying over,
I said the
over
rump
the
is
land,
folded on it. I can't do this with you guys right now. I'll be back later.
Oh, Jesus.
Can't do it ever with us, guys. Later's not.
You're
gonna
literally mishearing everything I say.
I'm not. You're saying how does one plumb line vary?
Yeah, one plumb line not being
With
plumb.
respect
How do
to
they
what,
tell
the
that?
instrument?
How do they tell that?
Oh, because they have an instrument that actually is moving over the surface, and they can see the variance of it. And if the variance changes as they move, then they'll know some variance in the plumb line. And that does happen. That's what geodetic surveying is all about.
Yeah, what's the instrument?
The gravimeter.
We have one plumb line. So they put a gravimeter. You're making up shit worse than Bob now.
How do you?
Okay, we're gonna tell.
How do you
we're
think
gonna tell
they
one
use?
plumb
What do you think
line's
they
not
use in an
plumb
airplane?
by using a gravimeter?
Yeah.
Are we gonna tell one plumb line's not plumb by using a gravimeter? Is that what you're saying?
Yeah.
Yeah.
That gravimeter
The
will have
the gravimeter's plumb wouldn't be plumb either. It wouldn't even know the difference. It would be on the same plumb. It would be on the same thing. The
plumb line
line's
by definition is
so
plumb. You
stupid.
freaking weirdo.
Yeah, the plumb line can change.
Okay, do you know what the Schehalian? You know what the Schehalian experiment? I'm responding to Damon. This isn't the Zanuck show. I'm responding to Damon.
Just gonna tell you that they can measure variance.
Have you heard of the Schehalian?
By the way.
I'll be back later.
Down is simply the direction in the most of most mass. So, the Earth has varying degrees of mass density throughout it. The geoid, if you look at it, is not a sphere, right? The forces of down would be all over the place. I mean, it changes, depending on where you're at on the Earth. What's so hard to understand about that? And a single plumb line is fucking plumb, meaning it's going in the direction of fucking down. Weird.
If one of you guys want to have a one-on-one about it, let me know. I'll be happy to. Otherwise, we're not doing whatever this is.
Another test where you want to make sure it's not electrostatics is the instantaneity of of gravity versus the time it takes for electrostatics. Electrostatics and magnetism all take the speed of light to affect on their subject. Where gravity is instantaneous, and that's a big factor too. No one's ever talked about that yet.
That's true. Well, I mean, electrostatics is easy, right? Like we know what that is and how things are affected by electrostatics. All you have to do is take various objects and basically do I don't know, like any of the gravity experiments using mass, attracting mass. Cavendish is a good one. You use various objects with varying degrees of electrostatic forces and see how much it changes or if it changes. And then you can be like, look, if we have electrostatic force or non-electrostatic force and these two objects, there's no change. It's always the same. Then obviously the electrostatic force doesn't make any difference. Fucking easy.
I'll put
He
the
wants to watch the
gravimeter
video.
so you can understand. He thinks whenever we mention these tools that we're like making things up.
You made that up because if you're using a gravimeter at the point where the plumb line's not plumb, then the gravimeter would also not even the gravimeter would be on the same line the plumb line's
As
on.
Damon said, it's always plumb.
It's not.
It is always plumb. Now the variance is what you're talking about.
Down points to the center of your sphere, right?
Jeremy, you're frustrating yourself because you're talking over me. You think other people are talking over you, but you're talking over me. Yeah, seriously, we're having a really easy conversation. You're just blabbing things out like you're on drugs or something. Just settle down.
I'm high a little bit, but
I know you are. I can tell. A lot of experience being
around. Does down point towards the center of your sphere?
Not exactly.
Generally speaking, yes. Generally speaking, but not necessarily.
Not exactly.
Okay, listen. Do you guys know what the Schehalian experiment is?
Do you know what a gravimeter does?
Do you know what the Schehalian experiment is? I know what a gravimeter does. Yes. Do you know what the Schehalian experiment is?
I don't know what the Schehalian experiment is.
I asked you
we'll go
first.
1 for 1. We'll go 1 for 1, Xander.
I already asked you before.
You asked me if I knew what a gravimeter.
I'm challenging you to know. Tell me what it is.
You asked me if I knew what a gravimeter was. I said yes. Now I have a question for you in response. Do you know what the Schehalian experiment is?
How do you spell it?
Dude, I don't fucking know. Schehalian.
Yeah, me neither. How am I gonna Google it?
That's funny.
Bro, I have no idea.
Just trying to Google it.
I'm trying to, but Google.
Well, dude, Google
I don't know what to tell you.
Just sound it out as it sounds. Google corrects it.
Yeah, but I'm not a native speaker. I'm very bad at guessing how things.
Try SHAHAL.
Oh, I think I found it. It's actually.
See, Google's the best.
Okay, this is
You
what I
have
found.
to know how to spell, and Google fucking finds it for you.
Yeah, but it has to be somewhat close. And my first attempts weren't close enough. I think I got it now.
Let's see.
I sent on the.
Yeah, there you go. There's a geoid. That is, I believe, about 10 times. Something like that. It's definitely exaggerated due to the mass, the varying masses of Earth. This is basically the force of gravity.
Oh, that thing that Zenix sent that ignores like a centrifugal force, right?
No, it doesn't. We just say centrifugal force is even throughout, and then therefore it's zero. So yeah, you can void it out.
I mean, if you're measuring downward acceleration, a reference to the ground, then
the Earth,
dude.
But all I'm saying is that the centrifugal force isn't doesn't have to do with the mass. It has to do with the speed of the Earth's
I know.
rotation. So
I
the
know.
rotation is even enough that you can generally call that zero and still
No.
make this geoid.
No. The thing that Zenik sent, I don't think that. I think that was measured in a way that isn't affected by centrifugal force, because you can see
That's
that
what I'm
the
saying.
equator is nothing. Like there's no a line that follows the equator there.
Well, that's okay. Yeah,
And
but the thing that this is representing is the varying masses of the Earth, which affects
exactly.
gravity, right? So
Yeah, so it's mass wise, only mass wise. Like if
Yeah.
you try to if you try to do those readings from the ground and you don't take into account centrifugal force, you will not get that. You get something different. This is probably coming from satellites.
No, this is just a geoid. This is it's not the exact shape of the Earth. It's just a sort of variation of the masses of the Earth. And so like the red zones would be higher gravity gravimetric forces, and the blue would be the lowest gravimetric force. And this is what it's depicting because of the varying masses within the Earth.
Yeah, but what I'm trying to say is that won't match local gravity.
Are you guys going to ever start talking about the actual Schehalian experiment, or?
Sorry, go ahead. What about it?
Distracted.
I don't know. Is that what I thought? That's what you guys were going to start talking about. Didn't you just look it up and you're looking at it right now?
Oh, I found the name.
I thought that's what you guys were about to start talking about.
All right, give me a minute to read it.
We were discussing whether it needs to be zeroed out or whether the centrifugal force has to be inputted in to give you an accurate reading.
Zanuck, a gravimeter, listen to me, Zanuck, a gravimeter gives you the same reading the plumb line would get. That's why they couldn't use a gravimeter to check and had to go through these extravagant lengths. Otherwise, they would have just used a gravimeter. You can't tell if a plumb line's not plumbed from a gravimeter, bro.
They're giving you strength. They give you the directional change is what you do at geodetic surveying. The strength is used by a gravimeter. We know the plumb line and the direction changes. That's geodetic surveying. The gravimeter is the strength. Get it? It also can do both technically, but it generally is not.
Bro, the plumb lines, if you're next to a mountain because of mass attracting mass, the plumb lines aren't plumb. Because now there's a giant amount of mass on the side of you. Okay?
No.
How do you tell that? Is not definitely not with a gravimeter.
goes towards yes, the strongest force of gravity.
Of you.
No, it's being created from this giant mountain on the side of you.
Oh my God. Hold on a second.
Or sorry, what'd you say? It goes to the what?
Right, so apparently they used a pendulum and saw how much it deviated from what they would expect. To the center of mass? Doesn't sound
That's
right.
where your plumb line's supposed to point, to the center of mass, right?
Yeah, but center of mass is not the exact center of the Earth, right? Like there are two different
He's thinking
things.
that the mountain's going to throw the gravimeter off, and it's not, or even a plumb line.
Hey, but this plumb line doesn't point towards the center of mass. It's being thrown off. It's being thrown off by the mountain.
The consistency of the Earth, the consistency of the mass is not uniform, but the mountain is not down. What's down? The Earth is down. How much attraction will the gravimeter or the plumb bob have with a mountain to the side? Nearly nothing, because the mass.
A measurable amount.
Hold on,
apparently.
You're not listening. See, when you start talking, you don't listen.
You asked a question. I answered
no matter how large the mass. I know you're stoned. Just relax.
You asked the question. I answered it, bro. What the fuck?
Stop it. The mass to either side of you is a micro fraction of what is beneath you. So that is not going to vary the plumb line. It's about what's beneath you. That is what's going. and over in relative small angles, very acute angles. That's how you differ the plumb line
Apparently,
direction. Not by a mountain, not by a mountain next to you.
Apparently, you're wrong because the mainstream disagrees with you, and the mass
Who's
of this
mainstream?
mountain made this plumb line.
Discord?
The mass of this mountain made the plumb line be off because mass attracts mass, and the mass from the plumb line and the mass from the mountain has it deviating, so it's not pointing towards the center of mass anymore. The mountain, this giant mass on the side of you, has the plumb line shifted.
No, because there's no force of that. There's no mass attracting
Okay,
mass.
what's the
plumb line doesn't
Schehalian
have any
experiment?
mass. It's beneath you. There's much more
what do you think
mass beneath you than there is to the side of you.
Yeah, but it affects it.
What do you think the Schehalian
There's a
experiment
slight effect, but it's almost immeasurable.
No, it was measured.
It's not because of the mass. It's not because of the mass of the mountain.
You on this.
It's because of what's beneath the mountain that is also next to the straight line, plumb line direction. So if the plumb line direction is down, the mountain has mass that's going down as well, and that mass could be denser than what's been right beneath you. That could be true. You could cut the mountain in half, and it wouldn't change that plumb bob. You could take you could level the mountain. That's not what's making the plumb bob deviate. It's not the mountain left to the left or right of you.
It's what's saying on the
That is exactly what it is. That's exactly what it is, Zanuck. You never heard of this up to 5 minutes ago. You're wrong on everything you said so far.
I've been talking about geodetic survey for 5 years with you guys. How do they think they determine the mass variance in a mountainous region where there's lakes and streams and they have a house? How do you determine where the water's going to flow? Because by using geodetic surveying techniques, these varying plumb lines that you measure, and they don't always go to the mountain.
I'm telling you right now.
Are you talking about this specific?
They measured
mountain?
it. They measured the plumb line not being parallel, or sorry, not being plumb. Zanuck measured it. Your own guys.
That's not being plumb. That's like plumb is whatever plumb is. Like that's by definition what plumb is.
Well, did you notice this mountain? Did you notice this mountain?
If it's not plumb, would they measure it again?
Guys, come on! I know you can hear me.
You cut bacon off.
No, bacon was
bacon. If it's not, if it's plumb, then if it's
plumb lines can go toward the mountain. If you look at the picture, they can go toward the mountain or away from the mountain. Bacon and Jeremy, look at the picture.
Bacon, don't respond to him. Don't respond to him, Bacon. Bacon, if it's
you
plumb,
can go both
what
ways. Look at the picture.
Bacon.
It goes away from it
plumb,
and it goes toward it, which is right. Be stupid.
Bacon, if it's plumb, what did they use to measure against it not being plumb?
Apparently, they were using the sky.
Yeah. So what's different? What was different with the sky than was different with this plumb line?
Yep. The plumb line, like if they know their coordinates, they know what star should be overhead. And if their plumb line is slightly different, then what if, like, let's say you pointed directly to the center of the Earth. Let's use a perfectly sphere Earth to make it simpler. So
that's the problem right there, Bacon.
No, I know. Yeah.
He's not getting the geoid versus the ellipsoid. So confused, Jeremy, all the time.
I'm not confused.
You are. You're looking at the spheroid rather than the geoid. Where a star should be overhead versus the plumb line is due to the shape of the Earth not being perfectly round.
No, it's due to the mountain on the side of it.
Having completely different.
It's due to the mountain on the Bacon. Tell him it's due to the mountain.
No, it's not, because look at the picture, Damon.
Zenny. There is.
There is here.
Hold on, guys. Rick, he ain't gonna listen to us. Let Bacon tell him.
Okay, there is the effect of the oblateness and Earth's rotation. That's one thing. And when you're using, for example, GPS coordinates, the latitude is based on that. So your latitude is already taking into account the oblateness and the rotation of the Earth. But it's not taking into account the density of the ground.
Yes.
Yeah, it's not taking into account.
The Earth looks like a big blob. The point I'm trying to make is we're looking at that relative to where the star should be, and that is the plumb line. But the geodetics do not show. That's why the ellipsoid is different than the geoid. It's nothing. There's no news here. This is all things we know.
It's because of the mountains, Zanuck, on the side of it.
It's not because of the mountains. Stop saying that. You're laughing like an autistic child.
Bacon, please help me out here, will you?
Look at Damon's. I can find data that shows this too. Damon is. Why do you do this, Jeremy? You make it
Sorry,
seem
my
like
bad.
everyone's talking over you, but you're talking over me.
My bad. That was my bad.
Look at Damon's picture. It shows sometimes the plumb line goes toward the mountain, and sometimes it goes away from the mountain. It has to do with what's beneath the earth.
Bacon couldn't even figure out how to Google search this 5 minutes ago. He already knows more than you about this.
I already told.
I'm not so sure about that.
I haven't looked at it. I haven't even looked at it yet. I'm just doing it by understanding what he's talking about. I haven't looked at it. I have no idea what you're talking about, but I know what it's not.
Well, but this experiment specifically trying to get trying to measure the density of the Earth based on how much a mountain would be affecting a pendulum. So that in this specific experiment, it is because of the mountain.
Like I said, you can have the plumb line go toward the mountain or away from the mountain. Depends on what's beneath the mountain that's affecting it. Just because of the mountain there. Hey, look,
like I said, Bacon found out about this
step-
5 minutes ago. Bacon learned about this 5 minutes ago. He already knows more than you.
He doesn't. I mean,
He does. He
a
knows
lot,
it's
but
because of the mountain. He knows it's because of the mountain.
No, it's not because of the mountain.
But that's what the experiment says. I mean,
know, but they didn't do it all. Whereas the independent variable is move it to another mountain and see if it happens again. It won't. It's not going to happen uniformly because you can have sometimes plumb line. I know this for a fact. Plumb lines can go toward the mountain or they can go away from mountains because it's not about the mountain. It's about what's beneath the mountain.
Yeah, but this is not. I mean, I know that if you pick a random mountain, this experiment might give you the opposite result. But they picked this specific one. But this experiment picked this specific mountain because they thought it would work for this mountain. So I don't think like your counterpoints might necessarily hold for this specific experiment.
How big was the?
Your counterpoints suck. And how the hell have you never heard of this before? You've been in this shit for years.
Was it a large mountain? I mean, it was a large pendulum.
How'd you never hear of this?
Okay,
guys.
So we have a large enough mass, and that's determining that there is some attraction to that mass to the mountain. But we know that there could be variations geodetically that would counteract that deviation on other mountains. So is the hypothesis that all mountains have attraction vector that is lateral? I gotta look. No, now you're gonna make me look at it. You know, I don't like.
Even without the measurement, this is what you would expect in your model of mass attracting mass. Why are you even fighting?
No, because I'm telling you, the mass next to a pendulum, I don't care how big the mountain is a fraction of what's beneath it. So yes, while it will have some effect in deviating the line, it's going to be almost immeasurable because of the fact that there's so much mass beneath the mountain.
Oh, it's measurable. They measured it.
Can I talk now, Jeremy?
Yeah, my bad, bro. Go ahead.
That's okay. So, like, do Globers really think that with 4,000 miles of mass, one mountain is going to make a difference? Is that a thing?
Sorry?
Yeah, it has some difference.
You heard what I
There's
said.
some effect, for sure, but it's very small.
I said, do Globers really think with 4,000 miles of mass that one mountain makes a difference?
Well, if it's perpendicular, so yeah.
It's also mass. This mass attracting mass thing is also distance related. So,
I mean, it's much bigger than a lead ball used in Cavendish, so why not?
But wouldn't that mean that sinkholes under the earth and underground water wells and lava flows and Earth's crust, which is denser, says science, wouldn't that also throw it off?
Yeah, isn't that how they?
And it does. That's what I was explaining earlier with this building they have where they just drop that shit all day.
Yeah,
clouds. They take clouds and weather patterns affected and shit.
If I'm not mistaken, let me just answer that to Gordon. If I'm not mistaken, they use instruments specifically meant for measuring gravity to find like minerals and stuff like that. Exactly because of the thing you're asking.
Right. The thing is, that's why they use a really big, large ball. So the larger the ball, then it has a larger mass attracting to the mountain mass. But if it's not a large ball, then it would be such a small influence on it. So the plumb lines are going to be, in this case, would be variance on the size of the mass that is pendulum. That's not how most gravitators or gravimeters work. So he's right, and Bacon's right as well. I mean, the article's right, which I haven't looked at yet, I'm sure. But you can have deviations that are stronger from different mountains. And he said this, they picked a particular mountain that had this maybe a sheer cliff. It had very dense, maybe it was granite. I don't know what they had. There were a lot of dense minerals. and it showed some effect on this very large pendulum that deviated the plumb line laterally. And I get all that, but it's all very, very small considering what's beneath it. It's a small change. The vector does change. There's no question about it because mass attracts mass. You're just not thinking this through, Jeremy. You think it's a gotcha. It's not a gotcha.
And Zanuck posted like this third grade colorful Play-Doh Earth ball. What happened to the Earth?
Oh, those are just corrupted. Those are just what exaggerated by about 10 times the mass effects on the variations of mass within the Earth. So the Earth isn't uniform in mass, and so gravity is affected in certain areas. If you're standing over a certain point of the Earth, you might have a bit of variation from another point, and this would basically affect down as compared to the center of the Earth physically.
So you say exaggerated, so not true.
No, I'm saying there's the effects, but so that you could see them more clearly for the point of illustration, to more clearly represent what's being talked about. They exaggerated the variation, so it's varied as you see it there. However, the variations are more defined because they've raised the amount of the variation by a certain degree. In this illustration, I believe it's 10 times. So whatever variation there actually is, they multiplied that by 10 to have larger variation for purposes of illustration, that the Earth is not uniform in its mass.
So they determined the Earth is a uniform in mass, and to demonstrate that, they made an example illustration that's 10 times exaggerated.
Right, exactly. To give you a better visual aid.
Yeah, because I think it was deGrasse Tyson who said that Earth, if the Earth were a cue ball size, it would be more accurate, more spherical than a cue ball.
Well, yeah, that's true, but that's physical measurements. This isn't like the actual shape of the Earth. This is the mass variation within the Earth. So certain parts of the Earth is more dense than others, or has a more concentration of more dense elements.
So that little blue spot on the Earth, I guess there's an ocean there, a little sinkhole in there, and things are lighter there, and they're heavier on the red mountain continent.
Well, I don't know what the actual this doesn't depict topography at all, really. It only depicts.
I'm looking at a blue and a red color, and that obviously depicts gravity. Is that not right?
It depicts variation in mass, which affects gravity. Yes.
So you would weigh more on the red mountain than you would in that blue ocean dot. Yes or no?
Yes, that's correct.
I just want to make sure I'm looking at it right. That's all. That's why I.
Yeah, no, I understand. I'm sorry. I was trying to make sure that I was being clear about what I was saying, and I didn't want to say something incorrectly.
Now, so with these,
I was being a bit pedantic.
Without exaggeration, would these differences throw plumb off?
Yes, but at the most about 100 meters from one point to the next. That would be the most variation
100
that you
meters.
could get.
Can you do that in arc minutes?
What's that?
Can you do a measurement in arc minutes that is thrown off? What is 100 meters with
yeah, I'm sure you
line?
could. Meaning, like, if I had one plumb line and compared it to another plumb line, the largest variation would be 100 meters. Let me make sure I get that correct. Hold on.
I actually don't know how to do that, so I'll take your word for it.
Oh,
That makes sense, Jeremy.
That's in comparison to level. I'm sorry.
Oh, my bad. What'd you say, Godric? Godric, say it again.
The dude said,
right.
Yeah, 2 plumb lines.
So
it's off
yes,
by 100. It's off by up to 100 centimeters, 100 meters.
No, and
That
so
didn't
I
make
was
sense to me
incorrect.
either.
I was incorrect. It's not in relation to like a plumb line. It would be if you were to draw. See how there's variations and on it's not a perfect sphere, right? So what it's saying is that if you were to take a level at any given point, it could be off as much as 100 meters from level. I'm sorry, that's a hard way to explain. They say explain extremely well in the video, but I'm not explaining it well. I'm sorry. It's off by 100 meters. Like if you were to take, like a perfect sphere that's perfect in mass compared to the Earth, it would be off by 100 meters compared to a perfect spherical Earth that's perfect in mass. That makes sense. I'm sorry, that's stupid, isn't it? I don't know how to explain it. Watch the video.
But you don't mean a plumb line is off 100 meters.
No, I don't. As if you were to draw a geoid.
It's an interesting article. So
that follows the variation in
process. They did much more accurate results. Had much more accurate results later in history.
Can I post a clip?
Yeah, sorry. What? Why is the answer in meters? It should be off in arc
I
seconds.
told them I don't get it.
It should be like arc seconds or fractions of an arc second or something.
What are you talking about?
The amount the plumb line's off.
Because if you put it like if you put like a dangling string, let's say a mile down a hole, that might move more at the bottom than just a regular plumb bob on top of the earth because it's so long.
Like the measure, that makes as much sense as him giving me the answer in meters or decibels.
I think he's talking about where that GP would change
second or like minute.
I think he's talking about the
hours.
GP difference. I think he's talking about the GP difference. 54, 50 odd arc seconds, I think, is a deviation, but I haven't looked into it very deep. I would guess that might be what he's talking about.
Yeah, you didn't even know if the mountain was causing it to be off. We know you didn't look.
No, we know it causes something, but I'm telling you what they've done.
Causes it to be off of plumb.
Yeah, if he's talking about distance, it's probably the distance from the GP.
Or are you a science denier? This sounds like you're denying science right here.
No,
I just said the GP difference would be 100 meters. I bet that guess is pretty accurate.
They did the test. It's because of the mountain.
The Earth. So if the Earth's surface was all water, the changes in mass below it of the Earth would create a 100-meter deviation in the surface.
Yo, this is a cool story.
At its maximum.
This is a dope story.
I don't want to explain it. I don't want to explain it to you because you're not going to accept anything anyway. So why the fuck do I do this to myself?
You're just explaining. You're explaining some hypothetical thing. In the meantime, we have the experiment with the measurement and everything. So I don't know what you're trying to do here.
Hypothetical thing. It's actually. Oh my god.
You just said the world's covered in water.
Why do I torture myself like that?
I know. I wonder why I do it too sometimes. You just gave us a hypothetical in which Earth was covered all in water.
Okay, that's
maybe what it is you're not explaining the bullshit right.
Well, honestly, you guys just got nothing better to do.
Well, I do, but for some reason I'm not doing it. I don't know why. I guess because I'm a lazy piece of shit.
Priorities, man. That's what it comes down to. Get them in order or not, whatever you choose. I don't know. I'm okay with either way.
Look, I work fucking hard and like.
I do appreciate your time, though. I appreciate your time, though, Damon. Because I feel like you're genuine.
Of course, I'm genuine. Why wouldn't I be?
But maybe it's like you're trying to explain bullshit because I want to science that, you know.
Some people are disingenuous for fun. It's like a pastime for them.
It's not bullshit. It's just that it's not necessarily particularly complicated either. It's just that if you don't have some sort of like visual aid or like simple understanding about what's going on, it's hard to just put into words. And then there's nuance to it too as well that's hard to explain because you could say something and it's true, but it's not always true because of certain situations. So like then you get yourself into mud because then people like you who are like
somebody like me. Yeah, somebody said
somebody that's a little too skeptical sometimes and like wants to poke at things.
Somebody said no matter how much specialized knowledge you have, if you can't explain it to the average person, it's worthless.
But that's the thing I'm talking about, right? Like I'm not a fucking physicist, right? Like there's people out there that know this shit better than I do. But like the weird thing to me that always like weirds me out is that when I'm talking to people like Jeremy or somebody, they're actually intelligent people like that. They can like learn things and like figure things out in their heads and like explain like even complicated things. But yet,
what do you want to know?
But then when you try to explain to them something, they're like so overly skeptical about what you're telling them that they won't even bother to like try to understand it. They just immediately reject it out of hand. And it's like,
wait, so what is it you want to know? What's the question? Well, yeah, what's the question that you want the answer to?
Jeremy can learn things. Jeremy, there's hope.
Well, what's the question you want the answer to?
Me? I don't have a question. It's Jeremy that has the
You just
question.
said you were confused.
I'm confused by people that reject information that's given to them out of hand without even attempting to, at least entertain it for a second.
We gave you the information in the experiment that showed that the mountain was causing the plumb line to deviate.
Yes,
You are the
exactly.
one denying. You're the one.
No, I'm
denying
not. I'm giving you a goddamn geoid that's showing you
Let
that.
me try to start over.
Why that is why it is.
Damon, listen,
You're talking
Damon
about
submitted.
condemnation without investigation, right? But that's not what you're experiencing.
Look, Damon.
Never mind.
Damon.
Okay,
Damon,
I didn't mean this to be like that. I'm sorry. If that's the
Damon
way you took
offered
it, that's
what I
not the
call
way
a-
I meant it.
Damon offered what I call a Play-Doh colored ball in a picture in the live chat, and he explained that was a 10 times exaggerated picture of why gravity is off.
Probably
And
1,000.
gravity being
I'm
off.
sorry.
Oh, gravity's off.
It's off.
It's not gravity is off. It's that since mass, the mass of the Earth is not completely even. The Earth is fucking huge, whether you think it's flat or not, right? Am I wrong in saying that the Earth is fucking big?
We're an ant on an anthill. I get that.
Right. Okay. If it is indeed a globe, obviously, I understand that you don't think that it is. But if you were to imagine it to be a globe, there are certain parts of the Earth, even though quite spherical, that the mass of it is not even. So, much like, aluminum is less dense. It's less dense than, say, hematite or gold or platinum. Right? If you were to have a large area, I know this isn't the way the Earth is, but if you were to have a large area of platinum, like say that takes up many square miles, and right next to it is a large area of aluminum that takes up many square miles, you would have a variation in mass of the Earth. And so therefore gravity would be less over the aluminum than it would be over the platinum. This is the idea that I'm talking about, and the geoid that's represented there is actually 1,000 times exaggerated. The variations in mass of the Earth, showing the variations in the effects of gravity due to mass.
Exaggerated for illustration.
Yes, of course. Otherwise, you would just get a smooth object like the Earth.
You just explained that they drew a geoid, very colorful. That's 1,000 times exaggerated.
My God, why do you keep bringing that up?
Well, because when you explained to me it was
What's your
10,
point
I was
by
willing to
bringing that
accept
up? What
10
is your fucking point?
because they're teaching you confusion, man. This is
Oh
confusion.
my God. Oh,
If you have to
it would
think
be
that the Earth is
confusion
a
if they
sphere
said this
and
is
a
the way
geoid at
the
the same
Earth
time,
is. That would be
that's
confusion, but they're not.
Because then
They're
when you can
saying
believe
the
that,
variations of the fucking Earth are in such a way that are not that fucking great. So to show you the variations in a visual way, we're going to exaggerate those variations so that you can see them. Otherwise, you're just going to look at a smooth fucking sphere and not see the goddamn exaggerations in this model. I mean, the changes in this model. So you think that you have something by me saying they've changed this by 1,000 to show the variation of mass. But I don't know what that is or why you think that, because that's fucking stupid if you think you have something. Like what? What do you think you have when somebody says that? It's fucking.
like, don't get triggered, man. I'm trying to point something out.
No, you're not. You're just fucking naysaying for no reason.
No, I'll tell you why. Because you have, if you go to education, you have to believe that the Earth is a sphere, that's a geoid, that it's oblate, and it's pear-shaped all at the same time. And that's what I call confusion. Because if you believe that shit, you'll believe any damn thing they tell you.
Well, if you don't understand it, I guess you could draw some strange conclusion like that.
Yeah, I mean that's a straw man, first of all. So if you believe those things, then somebody has taught you extremely wrongly, or your your capacity to learn things is minute or something. I mean, something's not right, obviously. But if you want to find the truth, or if you would like to not straw man or exaggerate things for purposes of dismissing them, then that's cool. We can have that conversation. But if you're just gonna say, oh well, this shows 1,000 times exaggerated, and say that you have some sort of point for that,
diagram that you're following a diagram that's 1,000 times exaggerated. Now I'm doing
what is the diagram showing? Is it showing the shape of the Earth?
It's showing that gravity's off.
Where is the diagram? Where is the diagram, by the way?
It's showing you the fucking
Where is the
mass
diagram?
of the Earth.
Scroll up.
The
Scroll up.
fucking mass of the Earth.
Presented what I call a
I didn't present it. Zanuck did.
Zanuck, sorry, Zanuck.
Okay, Zanuck
colorful. It's
posted
red,
something.
yellow, and blue.
At 10:22 p.m., Zanuck posted the gravimetry diagram.
And I asked Damon if I was in that little blue hole, which is like an ocean or whatever, I would be lighter. If I was on that red mountain, which is more dense, I'd be heavier. And he said yes. And first he said it was 10 times exaggerated. Then he said
correct.
It was 1,000 times
That's
exaggerated.
correct.
I thought it was 10, but it was 1,000. I'm sorry.
That's the conversation. That's what the conversation we're having. That's fine.
The illustration is 10,000. The data, they've taken the data and they multiplied it by 1,000, so that when they made the diagram, you could see the fucking differences in a visual image that small. If you didn't do that, you would looking at a smooth fucking sphere, which wouldn't show nothing in an illustration. What don't you understand about that? Fucking Christ.
I'm not seeing the picture.
It's like you're not even trying to fucking understand. You're not even trying.
And
somebody
by the way,
him the picture. We posted it.
By the way,
it's an article. It comes with an article. It's not just a picture. It's a picture.
It's an article link.
Yeah, here.
Oh, it's not an article. It shows the goddamn picture. It's a green, red, and blue and yellow fucking oblong-looking thing shape. It looks like a goddamn asteroid, colorful asteroid. And it says gravimetry at 10:22 p.m. in the a live stream 1 text chat.
I call that confusion, and because it takes 1,000 times exaggerated to see anything difference, maybe it's not really happening.
Well, if it's not really happening, you can multiply by 1,000, and there would be zero difference.
If it wasn't happening, even the exaggeration would be smooth.
I was looking at the wrong freaking chat. My bad.
And by the way,
you see it now, and this is what they teach kids, by the way, in school. There you go.
I don't remember seeing that when I was a kid. I only saw that.
Do you know why you didn't see it as a kid, Bacon? Because you was a kid. When you were a kid, everyone fell for that space moon landing bullshit. So nobody questioned science. Since the flat Earth is pushing back, and making all kinds of ridiculous bullshit.
I also didn't learn that in school.
Articles to push back into flat Earth. Flat Earth is checking gravity. We're not finding curvature. We're not finding gravity.
You're saying that you're teaching it to kids. No, they're not showing this picture to kids. No. I only saw that picture after Flat Earther showed me. Not on the school.
Okay, so I see the picture. I mean, what's the big deal about it? What's the topic of conversation focused on?
Originally, it was Jeremy talking about the Schehelian experiment, and that the plum basically moved towards the mountain because it's more. The mass deflected it that way.
These guys are
okay.
I was speaking about this geoid here that shows an exaggerated diagram of the variations of mass in the Earth, and about how it affects technically what down is, because if you call down the center of the Earth, that's not necessarily true because there's different variations of mass of the Earth. So it could throw it off from the exact center of the Earth by, a certain degree.
Every object has a center of mass. Down's supposed to point towards that center of mass.
No.
However, what's up?
Center.
Not necessarily.
Jeremy, do you
Every
drive a
object doesn't
forklift?
have a
Have you ever
center.
driven a forklift, Jeremy?
And that part's true.
Yeah,
The
I've driven a
second part's
forklift.
not true.
Yeah. So do you
second
understand what the center of mass
That it
on a
points to the
forklift
center of mass.
could change depending on the variations of the boxes on the skid, as well as how far out on the forks the weight is, and how high up it is, and how far tilted back you have. Right. That changes the center of mass. Correct.
So where's it supposed to point, Bacon?
That depends on the distribution of mass of the object.
It's supposed to point where?
That depends on the distribution of mass of the object. Like if it's a sphere and the distribution is even, then yes, it always points towards the center of mass. But
And if the distribution is not even and you have a mountain on the side of you, it's going to make it be off.
Yeah, not always points to the center of mass. Even because the distance matters. The distance to each point on the object matters.
You know what doesn't make sense about the picture though? Like if it's color coordinated, then it shouldn't be geometrically coordinated as well.
Seriously? Let it go, man. Let it the fuck go.
Let what go? I just joined in here. I haven't said anything besides asking you what you're talking about. This is my first take on it.
It adds to the visual representation.
Yeah, but just a perfect sphere that's color coordinated would get the point across clearly, and I think it's completely unnecessary and even detrimental.
But wait,
to have a misshapen sphere.
A geoid it's representing something, and the reason why it's different in shape is because it's representing that. Like you can say you don't care about that, or you don't want it, or you think it's superfluous, but it's still just a diagram that's representing something. So if you don't like it, that's fine. Yeah, bitch about the artist who is representing data. I don't fucking give a fuck. The point is that the point of the whole fucking idea is that the Earth is not equal in mass throughout, and so therefore you have a little bit of variation in the effects of gravity due to mass, the mass variations within the Earth.
And you also could have mass on the side of you, which would cause it to be off also.
Yes, Jeremy. Yes, of course. Yes.
Well, Xanax in the middle of this.
You could have a large goddamn fucking Godzilla standing next to you, and yes, it would create the plum blob would move slightly towards the Godzilla.
Okay,
fuck, who gives a fuck?
Because I give a fuck, because Xanax right in the middle of denying this.
No, he's not. He's just explaining
He
it
said
in
it
a more
wasn't because of the
detailed
mountain.
fashion.
He said it wasn't because of the mountain.
Okay. It was because of the mass distribution.
On the side of the plumb line called the mountain.
Whatever.
The mass distribution on the side of the plumb line called the mountain. What's up?
So what's the big deal?
Nothing. There is none.
I don't know. I don't even know anymore.
Jeremy smoked too much weed. He doesn't care.
Damon's drunk. I have smoked a little bit of weed.
But
I had 2.5 beers. I'm not drunk.
But how can you determine between standing on uneven ground and gravity and the plumb line not being straight towards the center of the Earth?
What?
They actually did it for you. They did it for you. That's the article. They did the whole world for you, and you follow the article. And you don't have to.
Basically, his question is how do you
spirit
tell?
level is going to be spirit level is going to be affected just like the plumb is. So how can you? So how can you determine whether you're standing on slanted ground or if the plumb line is actually tilted?
Bundy, you want it? Your question should be how do they measure how the plumb line's not doing?
Well,
how do they measure how the plumb line's not doing what it's supposed to be doing?
Locally, the variation is going to be very small. So compared to like a level and a plumb, they'll locally be very perpendicular. However, if you were to take the level in the plumb and then you move many, many miles away and do the same thing, there may be a variation that's not directly related to this, the spherical nature, the physical spherical nature of the Earth. It might be a small variation due to the mass of the Earth affecting gravity in such a way that it's not pulling it perfectly straight to the center of the Earth.
Sure,
So
but
you might have some variation.
How would you be able to measure the difference between the top of two plumb lines that are a sufficient distance apart versus the bottom of the plumb lines at that same distance, and notice that like the bottoms are closer than the tops of them are? Like, how do you even compare two plumb lines?
Well, I mean,
theodolites.
There's certain surveying techniques that you can use to do that. I don't know about them. Somebody else would probably know better.
What was the question?
The reciprocal zenith angles.
How can you determine that two plumb lines have a larger distance between the tops than the bottoms of the two?
Oh, yeah. Measuring reciprocal zenith angles is the typical way.
So involving like stars at a certain time of day at a certain place on the Earth?
Now, two theodolites, two theodolites get a certain, a significant distance apart, and they have to look down at each other. And
so we're not using plumb lines anymore. We're just using two theodolite measurements.
It's basically a refraction argument, because there are refraction measurements. You can see when the main surveyor did his reciprocal zenith angle measurement that he did in fact have refraction calculations in the measurements.
Either way, it's not a direct measurement. It's just some sort of an association, right?
Do you have a definition?
It's a direct measurement.
Yeah, you're misusing direct measurement, I think. I looked it up and it doesn't mean what you think. You keep using this word. I don't think you. What was the line from The Princess Bride?
You keep using this word. I do not think it means what you think it means.
Yeah, I do not think it means what you think it means. Yeah.
Inconceivable. Sorry, I love that movie. I have it memorized. Anybody want a peanut?
Anyways, I do think I am using direct measurement properly.
Who said that?
Fundy.
Okay, I was not watching in this server, but I'll find a definition and you find a definition. Let's see. I could be wrong, but I did look it up, and as best as I could tell, it means a measurement where you are directly reading a value, just like
you killed my father.
Like a bathroom scale, you step on it, it reads a value. That's direct reading. A theodolite would be direct reading, and stuff like that. Jesse, then you have to calculate refraction into what you read on your thing. So the number you come up with, I don't think would fall under the category of direct measurement. I could be wrong, but once you add the refraction calculation,
still trying to win,
obviously. Right, but at least we should agree whether or not the actual angle reading is a direct measurement.
The angle reading is a direct measurement of the angle that you're reading directly.
That's not its actual position, so then you add refraction calculations into it. Now here we are.
Well, that's it. Even though there's some controls and adjustments and some tweaks needed, it is as direct of a measurement you can take of an angle of a star. But that has nothing to do if you can apply it to the plumbs, but like I was saying, it's not a direct measurement of the difference in length between the top and bottom of two plumbs.
I like plums.
I don't know why are you talking about stars? There's nothing to do with stars.
Delicious.
I was talking about two plumb lines and measuring the difference in the length between the top and the bottom of them.
Well, there's a proverbial plumb line at each theodolite.
Sure, it's not a direct
proverb,
measurement of length, though.
There's a proverb written about plumb lines.
What?
There's a proverb written about plumb lines.
The proverbials.
Yeah, there's actually no. They're not like measuring the distance between the tops and the bottoms of the plumb lines.
Yeah, nothing directly.
There was a man named Herb who.
Is this a riddle or?
Who went out carefully, the hogs trying not to disturb.
No, we're not doing this Dr. Seuss shit. Listen, Fundy's right.
Sat down and wrote a proverb.
It doesn't change the fact Fundy's right. The end result in this is not a direct measurement.
It's direct measurement.
The end result is not. The angle measurement may be, but we know that's not the actual position.
Name is Indigo Mental. Kill my father.
Prepare to die.
But still, I mean, is stepping on the bathroom scale a direct measurement?
Yes.
Is that how you measure weight?
Yeah, I'd say so. Even if there's tweaks and adjustments and recalibrations needed, there's no more directness that you could use, even if the reading needs to be taken with a grain of salt and adjusted, compensated properly for.
Tell me stepping on your scale is a direct measurement of weight. Again, I got something for you. If that's really what you think. If that's the road you want to go down.
Sure, it's
the
Globers.
The Globers.
I'll say it though. What? It's a direct measurement.
Yeah, it's direct.
This ain't for you, Fundy.
It's
I'm not
two masses being pulled together, and there's a scale in between, which measures the effect of those two masses pulling on each other, and then represented as a weight.
So you're telling me when you step on the So you're telling me stepping on the bathroom scale is a direct measurement of weight. This is what you want to. This is the road you want to go down.
Exactly how I just described it.
Okay,
that's not what you said.
This is how we're measuring weight.
It's really about the acceleration of the scale upward into the mass.
Or no, it could be the other way. It can be the other way. Flip the scale around. It does the same thing.
Measurement of weight. Is that a direct measurement of weight? This is the road you guys want to go down. Are you sure?
It's not very relative.
Stop repeating yourself and just get to your point. Then you obviously want to make one.
Well, if we have W equals mg and I step on my bathroom scale, I have a mass to me. If I add more mass, I should weigh more, right?
Correct.
Okay, I'm going to add more mass. I'm going to grab some helium, and I'm going to now hold on to it. And now we're going to see how much I weigh.
Yeah, but that would be you would have a different measurement even if you were to rotate yourself in a circle, so that centrifugal force was fighting against gravity.
W equals mg, right?
Now you have a buoyant force, right? Because the helium balloon is less dense than the air around it, so the air is being surrounded by the balloon, giving
W equals mg, right?
It equals out from the side, and then it pulls up because the air down below it is more dense than the air above it, and so
you can put a cylinder.
For that, man.
You have a net upward force away from the center, so therefore you should be lighter, not heavier.
You could put a cylinder. MG. You could put a cylinder on the scale, zero the scale out with the empty cylinder. You could get on the scale, measure yourself, then fill the cylinder up and measure that as well.
I'm on the scale. I'm on the scale. I wait, dude. Are you guys just gonna go back and forth?
You can't measure a helium balloon on a scale.
So I'm on the scale. I weigh $160. I get some more mass. Okay, I'm going to add more mass to this. I'm going to hold on to more mass. I'm going to have more mass.
Of the balloon
W equals
negative.
mg. W equals mg. I now have more mass.
The weight of the balloon.
I now have more mass. The gravity didn't change. The weight should be more.
Is the acceleration of the balloon? Is the acceleration the acceleration of the balloon is not going down; it's going up.
The gravity
it's a negative weight, not a positive.
Okay, did the gravity W equals mg? Did gravity change? We know how we're
mass
getting weight
times acceleration. Mass times acceleration. You take all the forces, right? All of the forces is the balloon going down or up?
Well, I think the better question to ask is, when you're stepping on the scale with the helium balloon, are you stepping on a scale in a vacuum, or are you just doing it in your bathroom? There That's we true. go. There, Highlander's on it. You were given the wrong answer. You might have had a couple too many.
No. It's the answer I gave is correct. We weren't talking about a vacuum.
That's the only way that's the only way your
if you do-
formula works. That's the only way your formula works is in a
No,
vacuum.
it doesn't, because
It
acceleration
is. That's why Highlander just brought it to a
no,
vacuum,
because
because it doesn't
you
work in your
have to take
bathroom.
the sum of all acceleration. So there's the balloon. If you let it go, which direction does it go?
Dude, this formula doesn't work in your bathroom. It only
Which
works in a
direction
vacuum.
does it go? Why can't you answer the question?
It's
I see your
supposed to go
point,
down
Jeremy.
because
That's
there's more
a
mass.
good point.
What?
Just
Yeah,
It
it's
goes
supposed to go
down.
down
the
because there's
formula.
more
The
mass.
helium balloon goes down.
You have more mass. It's supposed to weigh more, right? Weight is
The
the downward
helium
force.
balloon goes down.
Is weight the downward force?
Does the helium balloon go down? You won't answer the question why, Jeremy. Why
It
won't you
doesn't
answer
go
the
down.
question?
It doesn't go down. I answered your question.
Right. It
Time for you
goes
to answer
up,
mine.
correct?
Time for you to answer mine.
It goes
Okay,
up, correct?
Time for you to answer mine.
It goes
Yeah, it
up,
goes up.
correct?
It goes up. Time for you to answer my
So
question. You ready?
if I have
You're not going to
a
do it, I know.
mass,
Some helium balloons go down.
if I have a mass that's going down and a mass that's going up, are they going the same direction?
Dude, I'm not doing with this with you where you just have this thing where you won't let me talk.
Hey, Jeremy, if you had a big enough helium balloon, you would float.
Well,
Does
I
that
mean,
mean that you're weightless?
Yes.
If you make me a temporary mod, I'll make him let you talk.
Fuck off. I'll shut up. Fine.
I'm good. I can't be doing this anyways. My whole family's sleeping. You guys are nuts. It's the same. It depends how much helium you put in the balloon as well. Because if you don't put in enough helium inside the balloon won't rise. Yeah. So the point is, if that's how you wanted to get Highlander, you were right to take it to a vacuum, because this formula doesn't work on your bathroom scale. It has to be in a vacuum. Yeah, but that's not what I said. You said, "Is it happening in a vacuum?" Yeah, but I didn't say the formula doesn't work in your bathroom. I just asked where you were doing this test. Yeah, it only works in a vacuum. You can't do it on your bathroom scale. It doesn't work. Because if you add more mass with W equals mg, you're supposed to get more weight, which would be downward force. So in your bathroom, that's not happening. In a vacuum, maybe. Definitely not in your bathroom. You still didn't get the point of my second statement, which was how much helium are you putting in the balloon? Because if you don't put enough helium in the balloon won't rise. Yeah, which should say to you that there's more than one variable that you need to take into account. Okay. We got W equals mg. Right? So if you fill it's like the other gentleman said, if you fill the helium balloon enough where the helium balloon is then going to rise, yeah, then you've created a buoyant force. What's G? And W equals mg. You want to go through this, or do you not realize that it doesn't work? I just think, like the other gentleman said, you're not taking all the other factors into account. Do you know what G is? Are you talking about small g? W equals mg. What's G? G is the acceleration due to gravity. Okay, and that's not changing, right? That's the same. Is that always the same number, or is that changing? What is G? How about that? Let's say that. What's G that we're going to use for this equation? Well, if you were to ask me personally, I would say it's the force of gravity. It's a number. But then you're going to go down the route of gravity is not a force, then, aren't you? No, bro, this is a number. What's the number for G that we're going to put into this formula?
9.81.
9.81. Very good, Zanuck. We have our G. We have our mass. I'm on the scale. I have a mass. I weigh $160. I add more mass by grabbing this giant helium balloon that's filled with a massive amount of fucking helium. So much so that it's rising. It's actually lifting me up a little bit. Now, according to this W equals mg formula, I'm supposed to weigh more. It doesn't work on the bathroom scale. It may work in your vacuum that you suggested. You're wise to suggest that.
Because of not taking into account other forces. Put that
Don't
same
care, Zanuck.
scale. Put that same scale in the pool, and you'll see it lighter as well. Just you alone.
The formula ignores the medium that the object is in, right?
No, it totally does ignore it. Because everything has weight. When everything creates forces, such as buoyancy, which creates a force upward based on gravity.
It's transferring some of your weight to the floor, is what it's doing, and the floor is not on the scale.
Wow.
The helium displaces air, which is heavier than the helium, which increases the pressure of the air on the floor.
So you're saying W equals mg does work on your bathroom scale?
If you had all of the air in your bathroom also on the floor or on the scale, if you're weighing basically you're reaching onto this rope and you're lifting some of your weight onto a support system and the support system is not on the scale, so you're transferring some of your weight to off of the scale.
No, it's on the scale. I'm holding the helium balloon. It's in my arms.
But the helium
balloon
balloon
is under my shirt.
It's part of a system that is not part of this scale.
Mass. It's this mass system, dude. Okay, what's G? We can go over it if you want. W equals mg. What's G? Zanuck said it a minute ago. It should be easy.
Yeah, 9.801 or 066.
9.8. All right. Now I have mass, and then we're gonna add the balloon. So we're gonna add that mass. So there's gonna be I have a weight of 160, right? And I have X amount of mass. Then we're gonna add more mass, and the weight should go up, right? Because W equals mg. W equals mg doesn't work. Then you're saying?
Ah, shit, Jeremy. You know what? Honestly, I'm switching sides here. As long as the bathroom scale is the entire floor, like if you could make the bathroom scale to fill the entire area of the floor of the bathroom, and you introduced a helium balloon into that room, I think it actually might make you way heavier on it.
Okay, so this definitely ain't gonna work on a bathroom scale in your bathroom, right? You need some kind of special scale.
Not normally.
With the room sealed.
Yeah, not normally.
You have to have the whole room sealed.
The whole room sealed with the entire floor being the surface of the scale you're standing upon.
And the walls going up to 120,000 feet too.
That's one of the prerequisites?
Yeah, because you have to take in account all the mass involved. You can't just use it on part of the mass and stuff. Yeah.
So this definitely isn't going to be working in anyone's bathroom then.
No, yeah, not in a typical bathroom with a typical
not
bathroom
in any bathroom.
Scale.
How high up do the walls got to be?
Oh, 120,000 feet should
do.
So
no bathroom then. Definitely no bathroom.
Yeah, no.
You still forget. You can have it in a box.
Do you guys have another global
in a box. There we go.
Wait, you heard me talking. You can have a box.
Here, we got a box.
Put the helium balloon in the box, and it's filled with air, 14.7 psi. Same exact thing will happen. That box will weigh less than as if you took all that air that's in the box and put it in a little tiny container, and put all the helium in a smaller container as well, where it wasn't floating.
I don't understand. What do you want to do?
Well, you can compress gas,
I'm trying to
right?
say, you have the air in the box. You still have hydrostatics. So even though it's 14.7 and sealed, so there's no atmosphere above you or below you, but you still have a gradient inside there. That gradient determines what force is going to be pushing up on the balloon and what force is going to be pushing down on the balloon and pushing in from the sides as well. Because the molecules are going faster down than they go in the other direction, they will have less weight. That box will have less weight with the helium balloon in it due to the fact that it's supporting that balloon upward. So it's not till you condense that helium to the same density as the air around it that you would have the weight of the helium. Otherwise, it's not going to be able to weight on that scale. The box will not have a true weight. It'll be buoyant because the buoyant force around the box outside the atmosphere. The atmosphere outside of the box.
So scales don't actually measure weight in a sense.
No. Not in the W equals mg sense. Absolutely.
No, you just have to incorporate all the different forces. Anytime you weigh something on a scale,
but
you have to take all the
scale.
forces in. Hear myself talking. Hold on. You have to take all the forces into account. The net force is the gravity, is the weight, rather.
Which can't be taken into account because
it can be. Sure. We know whenever anything that's sitting on a scale will displace air, and that displaced air has weight, and whatever that displaced air weight is, that's the force acting against your measurement for everything you weigh on a scale, no matter what it is. I don't know why this is so hard to understand.
I think they do understand it, Vanek. I just don't think they want to admit they understand it.
I understand it better than you guys do. Someone a minute ago.
Why don't you tell me what I just told you then, Jeremy?
Somebody a minute ago told me weight was.
Show me you understand it.
Hey, Zanuck, whoever said it earlier said it best, and he said that if you're on a bathroom scale and then you introduce a helium balloon, is that you're now involved more so in a system that the weight is being applied on a surface wider than the scale you're standing on. So a bathroom scale isn't accurately measuring the weight because now you're weighing down upon, even more so, upon the floor off the side of the scale. And the scale can only measure the weight pressing down upon it, but the object on the scale is weighing down on more than just the scale. So the scale is only measuring a portion of the weight.
No.
Because you're also weighing down on the floor.
Which weighing on the floor?
Your body is also weighing down on the floor beside the scale.
So are you telling me? Hold on. So are you telling me that? Hold on, Zach. So you're telling me that I can stand on my scales close enough to the edge because my belly's rather large and it hangs over the edge of the scale that I'm going to weigh less because my belly.
That's not what I'm. No, you got it wrong. No, you got it wrong. That's not what I'm saying. I'm talking about the helium balloon. If you got a big, let's say like a typical latex balloon, and it's like 6 foot in diameter, right? Its buoyant force isn't directly aimed towards pressing down in its buoyant force onto the scale. It's also
it goes up. Only up.
Okay. Well, let me reword it then. The displacement that's giving it its buoyant force isn't weighing down on air beneath it and around it, obviously not above it, but around it and below it. The buoyancy of the balloon is adding pressure not just onto the scale but onto the floor, in the air between it and the floor surrounding the scale.
No,
that would be why you're going to weigh less on the scale holding onto a helium balloon in a room.
It weighs less because you have a buoyant force of the air pushing up on the balloon. What he was talking about, what I think was a Jace or who was
but the buoyant force is still in communication, for lack of better words, with the medium that you're in, and what's supporting the buoyancy of that balloon? Well, that involves the floor surrounding the scale, not just the surface of the scale alone.
You think of the pressure acting on the floor itself?
Yeah, who said it earlier? Who said it earlier? He said it best, that you're now involved in a system larger than the scale alone.
Well, then, he said if the entire floor was the entire floor.
That was me. No, that was me. I said that. Someone said something before me that really nailed it home.
I think who was in there that said that. I think you or someone else.
Hey, Xanic?
Jesse said that. Jesse said makes the entire floor the scale.
No, that was me.
All right.
So look at it this way, Xanic. When you inflate a helium balloon, you increase the atmospheric pressure over the whole world a very tiny amount. That increased pressure is your weight that is now no longer being on the bathroom scale is now distributed over the entire rest of the world.
Yeah, there you go. Like you said, you're now involved in a larger system than just the scale. Now you're incorporating the floor surrounding the scale.
What are you guys talking about?
Yeah, I get what you're saying.
The force invariably comes from the floor because that is where the hydrostatics is the highest, and that's where it's causing the hydrostatics. That it has something to run into. And as you go higher, that's why there's a gradient that's less as you go up.
It's sort of like if you have two ski poles, and you're holding them in both your arms, and if those ski poles are touching the floor and you're resting, you just loosen the tension in your arms, you're still grabbing onto the ski poles, but they're connected to the floor on both sides of the scale. Well, that's going to take away the weight of your arms on the scale that you're standing on.
You just said that.
Yeah, and that's what holding onto the helium balloon does.
Holding onto it, no, you get the helium balloon that you're trying to weigh. You're holding onto it, but the floor is a source of the force that's acting up on the balloon from underneath. The air that is pushing down on the floor is also pushing up on the balloon.
But we're talking about a bathroom scale, not the whole floor being a scale.
Yeah, even the bathroom scale. Everything is pushing up. Everything around the scale is pushing up, including the scale too, by the way.
No, not the scale.
Xanic is trying to get into an argument with me about how he thinks
the scale is still part of the floor.
The Earth is rising up to meet you when you free fall.
Still pressure, Jesse. There's still floor. Now to get this straight, Jesse.
He's trying to bait me into that argument. It's not working.
Jesse, there's still air molecules hitting the top of the thing. Hydrostatics is still, whether it's the ground or something on the ground, is still acting on it at a vector that is straight up, all directions, because it's also scalar, but it also is straight down as well.
And the scale is not sealed to the floor, so there's the same air pressure underneath the scale as there is on top of the scale.
That's true. That's true. Yeah, but let's say it's sealed. I was saying the floor is the scale. Oh, you said it's not. Yeah, it's not the scale. Yeah, if it's not the scale, it's got air pressure underneath it. So everything but the scale, right? Because the scale has air pressure underneath it. But everything around the scale, all the floor around it, is a source of the force. Source of the force, of course, that is pushing up on the balloon.
I see that thing that Bacon posted, right, about the potato Earth. Where's the 70% of the abyssal plains on that model that you got there?
That's an exaggeration.
The reference tank is exaggerated 1,000 times. That way.
Oh, they exaggerated it like 1,000,000 times.
No. Exactly 1,000 times. It said that in the article.
Oh, okay, so literally 1,000 times. I thought it was a joke.
So the abyssal plains is that little circle, that blue circle, probably. I'm just guessing. That's less gravity right there.
That's 70% of the Earth's surface.
The Indian Ocean. That's in the middle of the Indian Ocean.
Is that 70% of the Earth's surface?
70%.
They don't look very plains to me.
And by the way, you're heavier on that mass continent where it's red. So just tell fat people not to go there because they won't make it.
So you're heavier in vagina. Yeah, I'm just wondering where the abyssal plains are. Because, this thing that I posted, it talks about 70%.
70% of the abyssal plain of the ocean?
Well, it covers 70% of the ocean floor, but it's over 50% of the Earth's crust.
Okay, gotcha.
Oh, so I talked to Bacon. Me and Bacon were brainstorming. He had a brilliant idea, of course. I don't know why you didn't spot it. Anyways, you might want to get up with him.
It's fantastic.
I just
I don't know why Jeremy's trying to put me against you.
No, I'm not. I'm just saying. No, that was good work, Bacon. You know, you're on top of shit.
But what was his idea? What is it?
I don't want to take over the whole VC with it. Let's let Larry continue with
Thanks
his
for that, then, dude.
abysmal plane thing, and then Bacon will fix
I used to call
all
the
your
abysmal
mistakes.
planes too. That's the abyssal.
Bacon will fix all your mistakes later. Don't worry.
I already fixed. First of all, I already told you there was mistakes when I posted. I fixed them already, but it doesn't matter. Yeah, they're abyssal planes.
Where are they at?
I got a question that's kind of blowing my mind right now. Can I ask it?
I think so.
Okay. So honestly, I feel like this is some sort of like paradox or glitch or something. There's got to be a way to resolve this. Okay, so here it is. Say you have like 2 bathroom scales, and even though these don't exist, let's say there's like a 6 foot by 6 foot square bathroom scale. Okay, and then in the center of it is like a 1 foot by 1 foot bathroom scale. Okay, you're standing on the, and you know the 1 foot one is on top of the 6 foot by 6 foot one. You're standing on top of the 1 foot scale, and which is on top of the 6 foot one. And like I said about the ski poles, right? Imagine they're just like crutches, basically, that you can just like prop, vertically on the floor and rest your wrists on, right? Like in some sort of like Christ cross position or whatever, like a T shape. So if the if you're holding up those ski poles, the scale you're standing on is going to measure the same weight as if you rested the bottom of the ski poles on the 1 foot scale, right? Like lifting them up versus setting them down on the surface of the scale isn't going to make any difference at all, right? It's going to be whether you're like holding something or it's rested on the scale surface. It doesn't make a difference, right?
Yeah, it's not going to make a difference. That's right.
Okay, so neglecting the weight of the 1 foot scale, the weight measured on the 1 foot scale and the 6 foot scale are going to be the same, right? The only difference would be the weight of the scale, the smaller scale, right? Like the 1 foot scale would say like you weigh 200 pounds. Okay, you weigh 200 pounds, but you're standing on a 5 pound scale. So the scale below it is going to register 205 pounds, right?
That's right.
Okay, so now you take those ski poles and you widen their stance so that they're standing on the 6 foot scale. Okay, so now the entire weight of your arms are unburdened from the 1 foot scale in the center of the 6 foot one. You feel me? So now the 1 foot scale is going to register a lesser weight, right? Because the weight of your arms have been unburdened from it, correct? Because the ski poles, they're planted on the surface of the 6 foot pole or the 6 foot scale, right? So now the 1 foot scale is going to be unburdened from supporting the weight of your arms because that burden has been transferred via the ski poles, right? Onto the.
It depends how much pressure you're pushing those poles down at.
Well, if your arms are outstretched and they're leaning on the poles, right? And let's just say your arms are stiff, right? They're not pushing down, but they're stiff, right? There's going to be a weight, or there's going to be a certain unburdening of the weight that the 1 foot scale is taking on, right? You're going to weigh less, right? Simple enough, right? You're going to weigh less if you're resting your arms on an outside surface?
Depends on the force that those poles are putting on the scale below it.
Okay, well, come on, man. Like, let's just put it this way then. If you're standing on a scale with like armrests on both sides of it that are connected to the floor below, if you don't put your arm, like say like they're even crutches or something, or just something you could like support your entire arms on. Like you just like put them out in a T position, and there's like blocks that are the same height as your armpits to just rest your arms on. That's going to take a drastic amount off of the scale. All right, so the ski poles are going to do something, right?
Yeah, depends
Why don't you just think about yourself being weighed in water? Just think about the concept of it.
Let me stick to my point.
It's easier to think about. Yeah, but that's also a good point too, because now you have the weight support on the floor, not on the scale anymore.
No, but let me just stick to my point, please. See, here's my final question. Because if you via the ski poles lessen the burden off of the small scale onto the larger scale, how could the total amount of weight registered be less? Because when you undo the burden via the sky pole or via the ski poles onto the larger scale isn't going to weigh or register a larger weight, right? So how can you go from weighing 200 on the first scale to now like 180, but the weight on the lower scale isn't any less, or it is less? I mean, like the bottom scale weighs with just holding the ski poles up in the air, right? Both scales registered 200 and 205, but now the upper scale only weighs 180 or only registers 180, but the bottom one hasn't gone up at all.
I don't see the problem.
You know, there isn't a problem. It sounded crazy in my head, but I guess you can just lift off by being supported.
What happens if the bottom one went up if there's more weight?
You know, there isn't a problem. You know, that's a silly situation, honestly. It almost seems it's like a parlor trick or something. Like something like someone at the bar would fall for.
Just think about the gallon. Let's go back to mine now. So we just did yours, and yours didn't make my whole sense.
Yeah, go ahead.
So you got a gallon. You got a gallon of cement, a gallon jug of cement, and you put it in water. The water, that gallon weighs about 8.5 pounds. You know this because you weigh it on a scale on the land. Put that same scale, it's waterproof. Put it at the bottom of the pool. It's still saying 0, even though it's in water, heavy or medium, because not Jeremy, but I think who says that? Is that gone now? Oh no, Jesse said that. Jesse said that you have a pressure underneath the scale, and the scale, the same situation. So it still says 0. And you weigh that cement jug of water jug, a gallon jug of cement, which weighed 50 pounds on the surface. So what's it going to weigh underwater on the scale? Same scale, but put in the water.
I don't know, like 30, 40 pounds.
There's an exact number because I gave you how much a gallon of water weighs 8.5 pounds. So what's this thing going to weigh?
You're saying a gallon of cement?
A gallon of water weighs 8.5 pounds, but the same gallon is filled with cement and it weighs 50 pounds. So what is this going to weigh underwater?
Which one? The gallon of cement?
Yeah, the gallon of cement.
41.5.
Right. Exactly. So the same situation. This is a more visual way to think about it because I think the gas is kind of messing you guys up. The atmospheric, the hydrostatics of gases are a little different than hydrostatics of water as far as clarity to be able to understand what's going on. Yeah, that jug is going to weigh exactly 8.5 pounds less. Why? Because it displaced 1 gallon of water. That volume of a gallon of water is what it displaced, and that weight of a gallon of water, as we already established, is 8.5 pounds. So it ends up weighing 41.5 pounds underwater.
Are you sure it's that cut and dry?
Absolutely.
Yeah.
Absolutely. That's why everything has buoyancy on the Earth that you weighed. Even though it's in air, it still is a little less than the scale will register.
And even
Because
we're buoyant.
if you're a bean pole, stand on the scale, you're still having the buoyant forces acting on that surface upward. And it's going to be less, whatever that area displaced weighs, that's the weight it will weigh less than if it was not, or if it was in a vacuum. So that's a good way to visualize it. Just it's the weight of the medium that's displaced acts up on it. Because pressure is a scalar quantity, not a vector quantity. But gravity has a vector. Acceleration is down. That's 9.8 meters per second. If it stops accelerating, then you have 10 newtons.
Are you sure that putting a solid into the space where a liquid once was is a direct replacement though of weight in respect of buoyancy?
As long as there's a gap between it and the ground. If you place it so it's flush with the surface, then that's the only way. And it's also not, so if you have like a pyramid shaped and you make it flush with the surface, then you could claim that wasn't buoyant, but most other things, yes.
Okay, and it would be a little bit heavier if there weren't a gap, just a little bit.
And lighter. What do you mean?
Lighter.
Yeah, like it would be lighter because it's buoyant.
No, if they're like if the ground was the scale instead of like the scale being like on 4 pegs or something, is that what you're talking about earlier, or I might be misunderstanding when you said a gap?
No, I'm saying like if an object, like a solid object in any medium. If there's space for that medium to get in between the bottom or on the sides of it, so it's like if you had an upside down pyramid, that would be buoyant, obviously. But if it can be flush with the surface, then
okay,
then it's not going to be, there's not going to be any weight subtracted. But by weight subtracted,
lift.
I just mean buoyant force upward.
Right. Yeah. You can't get underneath to provide any sort of like lift on it on a surface to touch.
And often buoyancy is applied to the sides of an object, but like I said, as a pyramid, it's the sides of it are pointed towards the top of it.
Outward. Well, yeah, like an upside down pyramid balanced on its point versus a right side up pyramid are gonna weigh a little different on an underwater scale, perhaps.
If it's flush, yeah, if it's flush with the surface.
He's only talking about when it touches the surface, and I don't. Yeah, we're talking. Let's say you're hanging on a spring scale. You're hanging it from a spring scale in the water. Doesn't matter what
Yeah,
shape
that's
it
a
is.
better way to put it.
It's all the volume.
Yeah, hanging from a spring scale.
Yeah.
Yeah, that's way better. Hanging from a spring scale.
That's usually how you would weigh it, yeah. But if you like when they do cold welding, that's basically how they do it. They just make them flush, so there's no gap between it, and it's basically welded underwater.
I'll be back.
Hey, Coach, Bacon has brought to my attention.
Yeah, quickly tell me Bacon's idea, but then I'll be listening, but I won't be able to speak.
Right.
What was Bacon's thing? What was it?
We go wait till you're all let you talk.
What? I can't hear you.
You're cutting out.
We can.
So Coach, you're saying if you drop the box and it went flush, Coach, you dropped the box and it went flush with the bottom of the pool, then suddenly it doesn't have any buoyant force acting on it?
I'm more comfortable saying a pyramid.
Why? Still has the right angles to a downward vector, but that's not what pressure is. Pressure is scalar, and there's a pressure differential regardless of what shape it is.
Yeah, I know, but that's why I'm saying like a pyramid, because even though there's a pressure differential, it's acting on the side, like at that point, it'd be acting on the sides of it only because it's flush with the surface.
So you're saying that a pyramid would have more weight measured on that scale if the scale was embedded in the ground, it was part of the surface. You're saying if it was welded to the...
I'm not saying more weight. I'm just saying it won't have less weight because of buoyancy.
Guys, real quick. I just found
it. Have more weight versus when
versus
more. Really?
Can you guys hear me?
Yeah, we hear you. Hold on, Zenny.
Real quick, I have a setting on my phone. It's mic mode. It has standard, voice isolation, and wide spectrum. What does that mean?
I don't know.
It says wide spectrum is unavailable.
Whatever you're doing works now.
All right. Bacon's thing was they don't all have to be done at the same time, Kosho.
Well, that's fantastic. You
because
didn't
you
say
only
that.
need to get. If one guy.
That's Bacon's bright idea. That's something that you just fucking took off the restrictions. You told me before that was a restriction.
You should have thought. You should have thought of that. Yeah, but you should have known we didn't need that though. Bacon was smart enough to know
I'm gonna kick
that
you
we didn't.
That's dude. These were your restrictions, man.
This is why Bacon's getting better than you, because he's just smarter than you.
Yeah. Okay, dude. Okay, dude. What you did was you unrestricted him, and there you go. Okay?
Well, it wasn't necessary. He knew that it wasn't necessary. He's like, why? He's like, it's not necessary. You didn't even bring that up. Just use your head with this one, bro. I'm gonna need you 100% on this.
I quit, and I'm taking a shower now. So,
but no, Kosho,
no, you can't quit.
Let's go back to your. We have a glass surface underneath this pool. It's a glass pool, and I got this pyramid. And I got one that's a pyramid pointing downward, tips pointing downward. The other one, the base is going to be flush. It's going to be so flush, it's going to be perfect. We're going to weigh these two scales. We're going to lower these things down, weighing it the entire way down. Are you saying that when it finally hits the surface, that it'll have more weight to lift it up until the water gets underneath it?
It's got to be flush with the surface. And I'll say this, I gotta get in the shower right now, but I did an experiment last year based on Jeremy and.
I remember we were talking about this. If you have a fish tank.
Yeah, listen, asshole. Fine, you tell him. Do you tell him the experiment? I gotta jump in the shower.
No, go ahead. Go ahead. No, go ahead.
I want Kosho to tell the experiment.
No, you tell him.
No, I want Kosho because Jeremy gets things wrong.
Yeah, Kosho, you tell him.
Well, I mean, I barely remember it, to be honest, but I did the experiment, and I had a fish tank. What else did I do? I poured water in it. Oh, that's right. I had a foam. So you have to get a. I got something that normally would be buoyant. So normally it would be buoyant, but in the case of making it flush with the surface, as long as you do it correctly, I think I had a dome shaped. As long as you do it correctly, and it's perfectly flush with the surface, it will not float upwards because of.
You create a section. You're going to reduce the pressure in the void as you try to move it away. You'll have a space.
Well, no, I didn't create a section. I mean, when I say dome shape, I mean solid.
That was one of the arguments. That was one of the arguments that you were going to create a suction.
Well, of course, if there's
you can use suctions
air gap. No, but I'm not talking about. There was no cavity. It was a completely flush with the surface.
Styrofoam.
Well, no. That was what I used styrofoam at first, but then I put tin foil at the bottom of the styrofoam thing. I glued this like tin foil shit to it. I did this it took a lot of work because the first few times it failed. So I can't remember.
Just imagine this probably looked like
you created a section.
This probably looked like the lunar lander.
See, you're confusing that. So this is where this is a logic you're using to why something has buoyancy.
No, why it will not have gained the buoyancy.
Or not have as much buoyancy. That's the reasoning.
Well, yeah. Well, if you make something flush with the surface, then it's not going to. The pressure that's being applied to it is being applied basically in the opposite direction. So instead of it getting underneath it or getting on the sides of it, it's basically helping to keep it not.
But you created a situation where you'd have suction. If you move it now, There is nothing. There's nothing. There's no space between the surfaces. So by moving it upward, unless it can leak in some progressive fashion, it'll create a suction. It'll create a
That's
vacuum.
what I tried telling him about the suction.
That's
saying,
invalid.
you know,
That's an invalid. It's flawed.
No,
logic.
I
that's
tried
what
telling
suction
him that
is,
with the
though.
suction 2 years ago. He didn't listen.
No, but listen to suction is not a thing. So what suction is exactly that's what suction is the pressure acting on the outside of the thing and not filling in the gaps. That's what the pressure.
You're creating a vacuum because you want to make in the pressure. Yeah, the pressure is going to keep it from going up because the pressure is going to be greater than the zero, which will be a space because you have no mass there, and you're making a space where there's going to be no mass. So yes, the pressure around it would keep it down.
Well, yeah, wouldn't the point that if the water couldn't get under it?
Hold on. Here's a test. Here's the answer, Kosho. If you took a scale and tried to lift it, you would find that object weighs more underwater than it does on the land.
Yeah, if you tried to lift it,
it's perfect enough.
I guess if you tried to lift it, but now if you're not trying to lift it, but just
you just want to keep it. It's stuck. You just say it's reduced. It eliminated its buoyancy. Is what you said.
Yeah, I don't even remember you doing this. You actually did this?
Yeah, I recorded it and everything.
I don't see it.
I had money on it.
Wasn't the idea that if the water couldn't get underneath it, it couldn't push it up?
Right. Well, yeah, exactly. Yeah, not just, but it's not just that. It's the same principle that is suction. So the fact that it's not being able to get in and displace it and move it, it's also being applied on the outside of it. So in a way, it's both not allowing it to be buoyant, and it's also
posting in the live stream the video. Let's see it.
I gotta get in the shower. I'll post when I get out.
Okay, we're never gonna see it. We've never seen it. Never gonna see it.
It's on my computer, dude. But
bro, I've never seen it, and we were talking about this for like a week.
Yeah, I remember I got drunk and went to the fucking HEB in the morning and fucking got the shit and did it.
Did you use aluminum foil or the gold NASA?
I can't remember. I glued some shit and I did it a couple times because it messed up. And then
probably so sloppy. I can't wait to see this.
Pondering.
Anyways, what's up? What did you say, Dan?
Still pondering the idea.
Pondering what?
Well, he's hell bent on thinking that it's this vector force of the pressure, and since pressure is scalar, there still is the same pressure differential between the top and the bottom, regardless if it has a lower surface. I'm not convinced that it's going to be.
Listen to me.
Heavy.
Just hold on. Drastic topic change. I got a drastic topic change. Did you ever get your boy Rumpus straight about the 3-point line of sight points?
I think we did. Yeah, we did.
I don't think we did. You said this. You said this about Bob before. You're like, yeah, Bob's all straight, and then come to find out Bob wasn't straight, and he totally disagreed with yourself. Remember that?
Right.
Bob, your Glover daddy.
Some of those angles would change. I think someone was correcting me in the chat that the angles didn't change. If it went longer, you'd have bigger, different angles, but no, the angles stay the same. Those don't change. But it is what we talked about. You just take the different angles of the top one, middle one, and bottom one, all three different angles, and then add those together. That'll be the
three line of sight points, 180 degrees.
Same altitude.
3 points.
Mm-hmm.
Between those 3 points, line of sight, they'll always be 180 degrees.
If they're all the same height.
Height doesn't matter, dude. You have 3 points.
Yeah, that's like we talked about that. Yes.
Any 3 points anywhere on the fucking universe. If you have
right. Right. The single triangle. Yes, all will be 180.
Why? There's a lot of people out there still. To this day, I had it out with a whole bunch of them on Jose's one day about this. They were trying to tell me 3 line of sight points would have more than 180 over the surface of the sphere. I'm like, yo, you guys are tripping.
I know, right?
I think if you measure the azimuths between them, then yes.
Yeah, azimuths, but not the points, not 3 points.
What do you mean not 3 points? Why not 3 points?
If you can see them, they're all straight lines. They're all straight
Because
lines.
if you do the azimuth,
above the surface, doesn't matter the altitude above the surface because they're all going to be they're all going to be adding up to 180.
It's going to be 180. Yeah.
It's not until you have 3 different triangles. Different.
You need like 9 points or something, or 9 points.
You just need three angles of all 3 different triangles at different altitudes.
Yeah, 9 points.
No, but Bacon. I think the point Bacon was trying to make was what I was making yesterday, which is, if you're 2 people are disagreeing about that, it could be the case that one of them is considering azimuth angles, like angles along the surface. I mean, versus angles from line of sight. Like
but that was obviously we're not talking about that. We were talking about not taking things over the surface because we said line of sight. Jesse was Jeremy was very clear about that. Line of sight. If we have 3 line of sight points, it's going to be perfect triangle, 180 degrees, no deviation. The spherical excess is made up of multiple triangles of different altitude.
Yeah, our rumpus was that.
Well, no, but the thing is, spherical axis is specifically doing it in such a way that you're measuring angles considering the surface, because
it's excess, spherical excess.
No, because they're not measuring that. They're not measuring the distance of the surface. They're measuring the distance between them, and it's a straight line.
Not measure distances.
3 straight lines. They're going to be. We don't care how far away they are. They just care about the angles.
Yeah, I know, but they only consider the component in the horizontal axis. So by doing that, you're essentially measuring the angles as if they were on the surface.
No, we're measuring as they're above the surface, line of sight. That's
what Zenik. Like when you measure from one, like there's a point you can see, there's a second point you can see, and you want to measure the angle between those 2 points.
Mm-hmm.
As you move from one point to the other one, you make a rotation. That rotation has an axis, right?
No.
If you tilt,
no,
what do
no
you mean
rotation. Line of sight is line of sight. You're making a chord.
What?
I just want to say that spiritual access is access to like angels and other celestial beings.
Okay, I have a camera pointed to point A. Then I rotate the camera so it points to point B. And I want to measure how many degrees I rotated the camera till it pointed to point B. Actually, there are more than one way to do that. If the rotation of the camera is perpendicular to the plane between you and the other 2 points, then that's the angle that is going to give you 180. But if that angle tilts away from it, if the axis tilts away from it, you're going to measure more than that angle is going to be greater. You're going to increase the angle you're reading just because the axis of rotation is tilted.
Not if you sight that tilted tangle upward on a point on that axis that is high. It would be higher. It would be positive to the same height as yours.
I didn't get it.
You're going to have a rise in that other axis. And that other axis will have a spot that you will be hitting from your elevate or angularly risen or increased camera angle. And so that angle will be between the 2 points. It just still will be adding up to 180. I know what you're saying. You're saying that between you and that point, if you incorporate the angle and then have to add that to it, then it would be in excess. But that's not. That's why you always show it in 3 triangles, and then not using the angle, but using one angle of each, because as you go up, those angles would increase. All those angles would increase. Alternate angles. One in one corner, next triangle above it, a different corner, and the third triangle, the third angle, and all 3 angles then now will add up to greater than 180.
I don't get it.
I don't either.
The bottom triangle has an angle. You see, you have A, B, C, and I'm A. I'm looking at A, B, and C. I measure angle A, and B and C are connected. We know there's angles there. All those angles will add up to 180. Then we have another triangle above it, and we look at the angles. But because the axis that we're on at B, or the point that we're on as we go up, that'll be a different angle for the other 2 angles in that triangle as well. And then you take not an A angle, you take the B angle. Then make a third triangle above it and take the C angle. Because the lines, the edge, the point A, B, and C are on lines that are going up parallel to the plumb line, those angles will have an angle that is greater than 180. Some angles will be greater than 180 because the plumb lines have been extended upward and are all angled away from each other. That's the spherical axis. I mean, it could be said in different ways, but that's the most simple, I think. But did you hear me? I think my screen went dead.
We heard you.
I heard it, but I still didn't get it.
Three all the plumb lines at A, B, and C are all diverting outward because they're on a sphere. And you measure angle A on the bottom triangle, angle B on the second triangle, angle C on the third triangle. All those angles together will add up to greater than 180, but every triangle line of sight to every one of those plumb lines will add up to 180.
Yeah, the angle of the triangle, yes. But if you're
the plumb line,
measuring,
if
you're measuring
the line that is angled away.
If you're measuring the angle around your plumb line, using your plumb line as like an axis of rotation, that won't be the angle of the triangle. That will be the azimuth, which would be the angle on the surface.
Angle from the surface, angle off of level.
Yeah, the azimuth would match the angle of the surface. If you draw lines on the surface, that's the same as take the azimuth.
Right, but we're not measuring off the surface. We're measuring off line of sight.
Yeah, but you're using only the horizontal plane to measure, because that's where your axis of rotation is. So you get azimuths. So you get an axis.
With one triangle?
Yeah.
So tell me how many. I'm at A, B, and C. What am I measuring at A, B, and C? What measurement am I using?
Sorry?
I got a protractor and I got line of sight, and whatever I do, I'm going to measure it very accurately. But I have a basic protractor that's very accurate. How do I measure this circle axis with 3 points on 3 mountaintops that are surrounding me, all at either the same height or different heights? Same height, let's say. They're all at 5,000 foot peak positions, all the way around me, all 3 points. What do I measure?
You're at A, you measure the azimuth of B and C, you take the difference. It's your one angle. You go to B, take the azimuth of A and C, take the difference. That's the second angle. Go to C, take the angle between A and B, the azimuths of A and B, take the difference. That's the third angle. Then you add those three. It's going to act as 180 on the sphere.
Is it because each observer is having to look down from their horizontal? Is where that comes from?
Yeah, because the pivot that they're actually measuring the angle along is not perpendicular to the other 2 points.
Exactly. Yeah. It's not perpendicular to the triangle that it forms. If it was, then it would give you 180.
But the azimuth, what azimuth are you talking about? The variance off of?
No, the axis of rotation, like the pivot of the angle. Like when you're rotating your scope from A to B, that rotation has an axis. If that axis was perpendicular or orthogonal to the plane of the triangle, that would give you 180.
Yeah. But since you're on one, then you go to the other, and it's gonna be off. But that's kind of like doing reciprocal zenith angles. You're measuring the differential in the azimuth, right? Hello? Test.
Not really. We hear you. We just didn't know what to say.
I think we all agree on our side that these angles, the plumb lines, will not be parallel. They're all going to be at diverging angles from one another.
Can you get a direct measurement of that?
How do you measure the angles?
Can you get a direct measurement of this? The
Yes.
thing you just said. How?
Sight one and sight the other and get an angle.
And that's the actual position?
Yeah, because we're going lateral.
Oh, you're saying with a spherical axis?
You could just take multiple observations, multiple measurements, and then average those and come up with a pretty solid number.
You'd come up with a solid average apparent position. Yeah, that's neat.
Yeah, well, as long as the numbers are fluctuating up and down, that wouldn't affect the azimuths, right? Which is what we see happening.
What do we see happening?
Positions being affected, like up and down, being moved up and down because of atmosphere.
Oh, you're talking about the spherical axis one then. Cool, let's see the measurement. Jesse might have one. Hold on, let me check Jesse's DMs.
Also, what's the error rate of these measurements? Is there like 2% or like an arc minute? What's the error rate of the measurements? Don't you consider there's error in each measurement? Even the small one?
Oh yeah, all measurements have an error. Or a margin of error.
That's why you could take multiple measurements and average those
So
and
what's
get a
the
more
error
solid
rate? That's
number.
the question.
Hold on,
you can have a solid number, but wouldn't that just be a lot of different measurements with a lot of different errors added up? So it wouldn't actually average out the error rate.
Well, there's the margin of error, and there's also the margin of precision of the tool you're using, which adds up. It's one factor in the margin of error. But it's interesting that every measuring device used properly will still have a margin of precision, meaning that even without human error, the tools themselves can only be so precise.
Well, it looks like we got about 34 minutes of deviation for these three measurements I posted in chat. 3 mountaintops, Wheeler, White Pine, Noki, whatever. And it shows what these angles are. And there's an excess of 180 by 34 minutes for the half a degree. And so when you see this picture, Bacon, is this what you're talking about?
Jesse, I just checked your. I sent you a DM on those angles you sent me.
Bacon,
Oh, good.
Or Jesse, you're looking in there right now?
My name is Inigo Montoya. You killed my father. Perpetual die.
Jesse or Bacon, are you there?
Those were the.
That's how he said it the first time, but near the end, he was like screaming that shit. My name is Inigo Montoya.
Jesse and Bacon, do you see that picture?
Yep.
Okay. So what angle, are we not measuring those angles?
This looks like I have a textbook. You didn't do these measurements yourself?
This is out of a...
Yeah, I think so, yeah. Like we are measuring the horizontal angles, yeah. I think that's what's being demonstrated, right?
So those horizontal angles. So where would your angles? So where would your angles measured by be different, or is it the same?
Wesley, polish my horse's saddle. I want to see my face shining in it by moon.
Bacon.
What?
What angles would you be speaking of here?
What angles? What?
When you do your measurement off of the azimuth, what angle would you be getting?
If the Earth is curved more than 180.
No. Tell me how you do it with my picture here of these angles. How do you do it with one triangle?
I'm not sure if I'm getting the question. Sorry.
How do you measure spherical axis with one triangle?
Well, you get the
Can't do it.
you get the azimuths.
He doesn't know.
Show
the points you can see.
Use my picture. Use the
It's
line
not
that
possible.
is only on that page and talk to it directly. What do you do? Vertical at A. Do you move vertical at A outward? Do you move vertical at B outward? Do you measure theta, beta, alpha?
Yeah, you're measuring the angles on those horizontal planes, right?
Okay, I mean those would all add up to 180. Even if B and A were was
yeah, but
obtuse angle.
That's if those vertical lines are all parallel. If they diverge, then that wouldn't give you 180.
They wouldn't?
No, not if they diverge, because then those horizontal planes wouldn't be parallel to each other anymore.
No, we only have one. Remember, we're only worried about one triangle.
Yeah, but each one of those measurements is over a different horizontal plane. But if they're all parallel to each other, that would still give you 180.
But we're not. Yeah, those all would be parallel for sure. We're not talking about B and A being parallel. We're talking about A, B. Hold on. We're talking about A, B, and C verticals all not being parallel.
I DM'd you, Jeremy.
Any one of those triangles would still have an additive angle of 180. You can't have a triangle that doesn't have an additive angle of 180. So even if you make those divergent, even if you make those azimuths diverge, the triangle still a triangle. It still has angle that up to 180.
There are four triangles here.
No, just talk about one. Just the top triangle, let's say.
And none of those are the ones that I'm measuring.
Let's say B, A, B, and C diverge. There's an obtuse angle between all of them. They're non-parallel. They all have an angle that's from the bottom, angles up, away from each other.
Mm-hmm.
They still will form a triangle that has an additive angle of 180 degrees.
But that's not the angles you're measuring.
Well, I know that, but I'm saying that's what you're saying. You're saying if I make those diverging verticals, that suddenly that triangle has angles greater than
No, not that triangles, because that triangle is a planar triangle. That's not what I'm referring
making a planar triangle. I'm going to shoot line of sight from one pot to another. And even if you use the C point, the B point, and the A point, even though they're at different altitudes and completely different angles in those verticals for each one of them, it still adds up to 180.
Every time you connect three dots on on Euclidean geometry, on an Euclidean space, they're gonna add up to 180.
The only way you can really do this is if you measure three different heights on those verticals and measure the C, the alpha angle, and the beta angle, and the third angle.
Danik, are you alpha male or a beta male?
Alpha.
Danik, probably Jesse can answer your question.
Yeah, I mean, I know you're thinking about it, but I mean, just if I'm wrong, let me know. That's why they show this like this, because if you could, that's part of the argument with Rumpus. Rumpus thought that you would just measure any of these angles and you would have an spherical axis. I think a lot of people think that actually. If you dig a little deeper, you realize that it's not going to work because it's all line of sight. It's not along the surface of the sphere, because that would definitely measure spherical axis. We're talking about measuring things with the theodolite. Bacon?
Sorry.
Yeah.
What was that?
My.
Keep reading, Zanuck. You're not there yet.
Zanuck, you're quite low today.
Keep breathing, or what? What do you say?
No, reading. Studying.
I'm not studying. I'm on the showing the
That's the problem.
No, I've already read it. I'm asking you. If it's not true, let me know. Where do you think there'd be an excess of angle? If you have line of sight, that's how you measure it. All three of those triangles, even four of the triangles, even if they're at different altitudes or elevations, along those diverging verticals would have angles that equal 180.
Yeah, but I was never talking about the angles of the triangle. that you
That's
create
how you
between.
do spherical access, as far as I know. But I mean,
No,
I'm asking
it's
like
not.
what it says. We are concerned about the azimuthal difference, as you said, measured at
Yeah.
each location. We measure
Yeah.
A, we get a measure angle alpha. We measure B, we get beta. C, we measure the Then note that the angles are not the angles within the triangle. Instead, they are projected angles in each horizontal plane at points A, B, C, respectively. So all three different
Yeah,
points.
but okay. So
So
now,
not one. So
yeah,
not one triangle.
it can be a spherical triangle on a sphere because
Oh, how do we do a spherical triangle?
well, just ignore elevation for a second. Let's only think about the surface. If you project
Okay.
the whole thing onto the surface,
Yes.
you get a spherical triangle, and
Yes.
that spherical triangle has the same angles you measured.
But we're trying to prove this to Jeremy that this we have spherical axis. You're just assuming a spherical surface and then say, okay, this is what the spherical
No.
axis is going to be.
If it's a planar surface, we're not going to get access in the first place. But if it's, we are only not going to get access if all those plumbs are parallel to each other. If they're all parallel to each other, we don't get access.
Right,
If
but
we do
if
get
they're
access,
not parallel to each other, you still don't have access unless you assume a sphere and draw
no, you
a
don't have to assume a sphere.
non-Euclidean line.
The only reason why I assume the sphere.
Aren't you assuming a non-Euclidean line by assuming a sphere and getting a different angle? That's the only way. Because if you draw a straight line, you get. Go ahead.
Only because you're asking for where the triangle is. Like
Well,
if
yeah,
you're
we're
asking
going to
you,
measure. We're trying to show Jeremy how you get it, and you can't get it unless if you're assuming the spherical triangle and using non-Euclidean geometry.
no,
Then you
you
might get it.
you get the axis without assuming anything. You just measure the azimuths. If it's a flat Earth, if it's a planar Earth, you don't get axis. You get 180. If they tilt away from each other, those three angles are not going to add up to 180.
I'm talking about the things you can actually measure. I've showed you my way how I would do it. Now, why don't you show me how you would do it?
I already said that.
No, you didn't. You didn't, because you tell me you do non-Euclidean geometry. You're just assuming that it's spherical.
No.
Measure an angle between A, B, and AC on a single plane, horizontal plane triangle. I'm going to get 180, regardless of what the verticals are doing. Right?
Yeah, you're only going to get a triangle on the surface. That's the triangle we're going for. So if you're trying to create a triangle between the points in 3D space, then yeah, you're not going to get 180. You're only going to
measure it. How do you measure it?
Because you measure the azimuths. That's the same as the angle on the surface.
Went through this with you guys before.
That's why I think you already got spherical access, and that tells you the story right there. You don't need to do any more triangles. But if you don't have the angle, if you're not able to measure the difference from one vertical to the next, then you just can measure these angles, these three angles. And the three angles will give you the excess of 180, because you're trying to measure the angle difference by the azimuth difference, which is true by all three.
You can't measure the tilt.
Verticals. You can't measure it unless you use a theodolites and you see what the reciprocal zenith angles are. If they're different, then your point is well taken. Then of course we know what the shape of this line is going to be if it's spherical. We can use spherical geometry to calculate it. But if we don't, as Jeremy wants to know, Jeremy wants to say, if I see it line of sight, what am I going to get? And the only way to do it is to do it like this. The only way I know of to do it is what's said here. And I could be wrong, but I think that's.
Are you guys done talking this math language?
It's not math. It's not math language.
Danek's just rambling.
I'm not rambling. It's pretty clear. We have three triangles. We have these diverging plumb lines, and we measure the angles in each of the three altitudes above the surface. And those three angles on three different triangles will add up to more than 180 degrees.
What I hear is that Zanuck is trying to get Bacon to teach him how to do spherical excess.
I'm not teaching.
But,
I know he can. I know you can do it. I know you can do it. This is spherical. This is the definition. This is in a book. It talks about it. It has the measurements too.
Well,
then it must be true. You don't have to go out to the plane and do it. You can just trust the book.
Yeah, your incredulous objections are not going to be accepted here. Sorry.
I mean, because isn't science observable, demonstratable, repeatable? Why do you have to trust other people doing it?
This is like dated in 1950 or something. 1940. This is
Are
just,
you serious?
you think no one's tested? I personally, you're right. I haven't done this actual measurement.
Yo, I didn't see your picture yet, but
Thanks for being
I
honest,
see
and I
that.
appreciate that.
Okay. Yeah, because if you had a device, like I could create a device that had like just a pointer and it had two gears perpendicular to each other, and like you can swivel it on both gears up and down, left and right and stuff. If you had three people at any elevation, you can put them at any elevation, and you had them well, actually it would have to be, let's say that they're sufficiently far. But anyways, you had them point their pointers at each other, and you only looked at the angle that the horizontal gear was measuring. You would get the spherical excess only if it was on a sphere, right? You get above 180 degrees on that, on only those gears.
Not only on the sphere, but certainly not on a plane.
Right, yeah, but not only on a sphere, right? On a curved surface, I mean.
Yeah.
Right.
On a surface with positive Gaussian curvature.
Right. I know what he's saying. I'm just saying how we do this so that Jeremy can understand how we measure it. Now, that's true. You measure one. I think what Bacon was saying, that you have a telescope and you have it so it spins perfectly around, not change. It's perfectly level. So if you spin it 360 degrees, it's going to, wherever it's pointing will be exactly that distance above the surface, even if it's not a sphere, right?
Yeah, that way it works too. Yeah.
And then that way you go to point A, you got a measurement. Then you go to point B, and suddenly it misses it. And that's the spherical excess he's talking about, I think. Is that right, Bacon?
What? Sorry. Yeah, I'm sorry. I'm doing other stuff when someone's not talking directly to me.
That's okay.
But what was the question?
Are you guys still rambling?
What you got, Hank? Or
Larry, why don't you pitch that light bending thing you were talking about? Are you still on that, or
They're
what?
trying to do a spherical excess from a 1950 measurement.
Let's see what Larry's brings to the
I really don't understand this part. It's in something I posted earlier. So at 51 past the hour, it talks about Einstein's equations and coordinates that rotate with respect to their inertial frame at infinity. What does that mean? I have no idea. I'm not being facetious, or this isn't a gotcha. I have no idea what that means.
When did you post it?
51 minutes past the hour.
Oh, okay.
And then if you scroll it before that, I think I posted a link somewhere.
51 minutes.
Oh,
yeah, 46 minutes after the hour too. It's .gov Biblio, so it's something about library. Solving Einstein's equations with dual coordinates frames. That's the source. But I was wondering what it meant by reference frames. Inertial frame at infinity. I didn't know what that meant.
Sounds confusing.
Where'd you put? I don't see it posted. I see Jesse's post.
So at 10:51, that's almost an hour ago. 51 minutes past the hour.
9:31, or 31 after the hour. 32 just posted. Essie, am I in the wrong chat or something? Are we not?
No, it was like 40 minutes ago.
Oh, 40 minutes ago.
I'll post it again, so you don't have to look. There you go.
Dual coordinate frames. Stable numerical evolutions of a black hole space-time using generalized harmonic form of equations and coordinates that rotate with respect to the inertial frame at infinity. Single rotating coordinate frame. Obviously, these are coordinates that that are outward from the axis of rotation.
Of what?
Of a black hole.
But what does it mean? The rotating coordinate frame, or sorry, inertial frame at infinity. I didn't understand that part.
Well, the inertial frame
At
is infinity. It's unlimited in size. It goes out forever. I think.
So is this something that's like real?
Well, this is. I mean, it's not a real thing. This is just a model. Would you say for computing Einstein's field equations? You said.
From Einstein's equations in coordinates.
Where'd you find this from? What do
you? Gave the source right there.
I know I'm reading it, but I'm just wondering why you brought it up.
Because I didn't know what it meant.
Just stumbled upon it. You want to know what it meant?
Yeah, I was wondering if anybody could tell me what it means. Because I don't get it. It doesn't make any sense.
I don't know. I have no idea.
That last part one more time, Larry. I had to step away.
Well above my pay grade.
Yeah, I was, explaining that I didn't know what this meant about the inertial frame at infinity.
I'll be honest; it's hard to fully understand without the entire context. But based on what it looks like, he's just. This is just a method to, solve Einstein's equations by using, two different coordinate systems. And he just says that one of the coordinate systems is rotating with respect to the other one at infinity. Maybe forget that at infinity part. I think he just means one is inertial and one's rotating, in reference to that one, at all times. And the other one is like a legitimate. So I mean, I think that it means like legitimately it's rotating with respect to that inertial frame, that second frame. I mean, for forever. Because it doesn't really say, it doesn't look like it means anything else than that. Like it just looks like I said. I mean, plus this is a conceptual thing. This whole thing is conceptual. It's not like this is supposed to be some real, something real.
So we're talking about black holes and Einstein's equations for gravity, and you're saying this isn't supposed to be reified. Is that what you're saying?
Yeah, no. This is a method. This entire method is what I'm saying. The method that this guy is coming up with. This method is conceptual. It's a way to solve for it. It's kind of like with refraction. They use they combine the two curves, the curve of the Earth and the curve of the light, so that you can treat the light as if it's coming in straight, even though it's not. So you make the Earth bigger. Like this is just a conceptual way to think about it, so that when you're expressing it, it can be expressed more easily. But this all this guy's doing is he sounds like he's coming up with these two different, or this new method for solving the field equations by using two reference frames or two coordinate systems and doing some functions to it. Probably coming up with the same answer.
All right, thanks for that. So you mentioned the light bending around the curve of the Earth, making it appear straight, right?
No. I said that so when they do like 7/6R, like stuff like that, they're using the light as if it were straight and making the Earth as if it were bigger, because it's easier to make computations with a straight line on a curve than it is to make these computations with two curves.
So you're just making it easier for yourself.
Yeah, easier to express, easier to calculate. Yeah. Same answer. I mean, that's this guy's claim. This guy's claiming he has an easier method to do it. I don't know if I'm only reading the abstract.
Right. Yeah. I only saw the abstract too. I just didn't understand it. I think a lot of this stuff is just out there. It's so weird.
I'm the one that gave you the video that showed that a bottom heavy density gradient could cause a curved surface to appear flat.
Right, and I think you were the one that gave me the theory that sunsets wouldn't be reliable. Because if the light is bending at 273 miles in the way that it shows in your video, then the sunset time would vary drastically. If that kind of refraction that you're claiming is happening to 273 miles, like we're talking about the sunlight.
Are you the one that was straw manning me and saying that it always happened because it sometimes happens?
I don't think I ever said it always happens. I said it would sometimes happen, and it would change the sunset and sunrise time on each particular day, but that doesn't happen in reality. What actually happens is the sunset and sunrise time is pretty much predictable, within a little bit of margin of error. But if it were bending like that, then we would have, cities that were to the west where it would be dark, and cities to the east that would still be lit up because extreme refraction events, like you guys are describing with your tank, where hold on, it's above the normal refraction, the standard refraction, and it would actually cause a city to like the northeast, right, to be like lit up, while the city you're in, southwest to that city, it would be dark.
No, because it only happens close to the surface.
So that would mean the lower I get to the water, the sun would come back up?
No, it means the circulation of the light would only happen close to the surface of the water.
So if I got closer to the surface of the water, the sun would come back up?
It depends on the exact conditions. It would have to be the same refractive conditions for a long ways. And the thing is, they don't go for a long ways usually. They're usually just like in an area where there's hotter air that blew in off the land over the water.
Didn't that one guy get 273 miles? Isn't that the Guinness Book of World Records?
Yeah, but if you actually do the math, his line of sight pretty much touches the surface of the earth. It comes right close to the water.
The guy on top of the mountain taking a picture of another mountain?
Yep.
Yeah, his line of sight was close to the surface?
Yeah, well, do the math.
The horizon is in between them.
Right.
Yeah, the horizon isn't between them, but it should be if the Earth was curving. So the Earth is curving according to you guys, but the light is curving around it, allowing you to see it as if it's appearing in a straight line. And if that was happening, then the sun could set in a place where there's standard refraction, but north to that region, let's say that there's above normal refraction and this phenomenon is happening, the sun would set an hour later. Like it wouldn't be predictable.
An hour later?
Maybe a minute.
So
less than a minute.
Not a minute. Okay, the sun goes 15 degrees. So what's 15 divided by?
So 4 minutes.
24,901 divided by 15 degrees. So how would that? Is that right? What? I'm not too good with the maths. If I wanted to find out how far the sunlight, what the time it would take the sun to travel from.
Well, it does a degree in 4 minutes, and a degree 69 miles. So if you did nautical miles, it's easier. You can say.
Okay, you're right. It would be off by minutes miles. if that's true, which it sounds right. So it would be off by like minutes. The sunset would be off by minutes.
Yeah.
So how good are we at predicting sunsets?
Pretty good. What's his name? Jesse said a second ago about long distances, and that is actually different. So that's what they call astronomical refraction, or maybe celestial, one of the two. But they're specifically talking about refraction from objects that are coming in through the entirety of the atmosphere, like through the atmosphere that's on the surface, and then out through the sky on the other side. So I think because of that, even though it's not standard refraction, it's still, you're not going to get any like wild effects, because those wild effects are only the objects that are being seen through a small enough amount of atmosphere that you can get these wild effects.
So if the sun is coming and it hits, let's say, about where the terminator line is, but it doesn't hit there, let's say that it's not hitting the Earth where the terminator line is, but the atmosphere above the terminator line at the exosphere. And the denser air would be closer towards the surface where the terminator line is. So it would bend down and then down again even more as it reached the thermosphere, and then even more as it went through the layers of the atmosphere. How would you even have a sunset? Like, it would be daylight in the sky all the time if the light was bending around the Earth.
Because
like
the circulating refraction only happens near the surface, like within a few feet, maybe 3, maybe 10, but like close to the surface.
I'm talking about sunlight coming from the thermosphere. What are you talking about?
There's no such significant refraction up there.
So you're saying light doesn't bend as it gets closer, deeper. I'm sorry, denser. You know what I mean? It's like, I've been doing this all day.
No, above the water, it's all about the same, roughly 1 degree every 932 miles. Of course, and that's for low angles, like not too. That's like low. That's for low angles, like to other mountaintops and stuff.
So you're saying the light wouldn't bend from the outer part of the atmosphere down towards what you guys call the center of the Earth as it goes through the other parts of the more dense atmosphere? It wouldn't bend down?
It bent down slightly, but not nearly enough to cause this circulating ray syndrome that you're talking about.
Yeah, I wasn't talking about that. I was just talking about the sky would be lit up past the terminator line if this sort of thing was happening.
Well, that's why the sunset can be delayed by a couple minutes. And it is.
You claim that, but how would you know? Does the sun ever skip? Does it ever,
slows down? Yeah.
Definitely.
It slows down. The sunset slows down.
No, if you take like a time lapse of the sun setting or the moon or anything, you can literally see that it slows down as it approaches the horizon. And it shrinks too vertically, but not widthwise.
Well, you can also look at when you look at the daylight times for the world, if you look specifically at the daylight times for the equator or daylight times for everywhere in the world on the equinox, it's always 12:08 and 11:52. So like the extra 8 minutes you can attribute to the refraction.
So it varies 8 minutes either way? Both ways?
No, it's like less than 4. Yeah.
It's always prolonged. Sun visibility is it rises early and it sets later because of it. Because to go the other way, you would need an upside down density gradient over a very long distance, and those are unstable because the heavier air, if it's up higher, immediately sinks and creates turbulence and mixes up until finally it's back to bottom heavy again.
So that video where they shot the laser over the lake, the first time they tried it, the laser was bending up, and I was thinking that if you were looking out trying to see the shore on the other side, and the light was bending up like that, it kind of depends on how we see. Do particles bounce off of objects and hit us in the eyes? Or do we see like the comic books where there's like rays shooting out of our eyes?
So we don't actually know that the laser was bending up because when...
Looked like it.
Well, yes, it looked like it. But hear me out. When the laser light can be bending down, but you can be below it, looking up at it through a density gradient, and because you're seeing it through a stronger density gradient than it's going through, it appears to be bending up, even though it's actually bending down. And I actually replicated this in a fish tank if you want to see it.
Yeah, but we don't live in a fish tank, bro. There's no glass in between our eyes. when we're looking out the lake. There's no glass to point our eyes up to make this phenomenon happen.
Well, I was using a saltwater density gradient to emulate a hot-cold density gradient.
Well, we're not looking through saltwater.
That's a very weak argument because.
Well, you use it. Okay, then do it without the saltwater.
And then you wouldn't have a density gradient.
Why not? You got atmosphere. There's a density gradient there.
Sure
See,
is.
you guys use these. You guys use these extreme conditions like saltwater and glass to show us what you're talking about and show proof of concept. That's great and everything, but show us the proof of concept without the glass and the saltwater. Show it with just the atmosphere.
The atmosphere's big. The gradient is huge. So we use something that can fit in a lab or in someone's room.
I did show with atmosphere that a bottom heavy density gradient makes things look higher, and that it does make light curve downward. I did show that much. So
yeah, if you point the laser up at the glass to make it refract down and bend around the curve perfectly, right?
No, I did this out at the beach too.
Show me that video.
Okay, hold on. I didn't use a laser, but I used natural light because I didn't want to get in trouble for shining a laser around.
I'm sure once you told the cop that you believed in the globe and you were trying to prove the flat earth is wrong, they wouldn't have beat you so severely.
Probably would have locked him up.
No, cops like Globers.
Do you prefer the video or the pictograph that just has the key pictures, screenshots with annotated text?
Whatever you got. Send it. I'll take a look. I still got to look at what I got sent earlier today because I probably should look at it before I go to bed. But I think I'm done arguing. I'm quite tired. You guys can go back to talking about triangles or whatever.
I thought he was about to show you something.
Yeah,
he's going to send it to me.
Oh.
Yeah, he can send it to me.
Fair enough.
The thing is, with the fraction you have, refraction, you have to have that.
You're cutting out again, Jeremy. We couldn't hear you.
He's sneaking around, dude. He's trying to talk to us in secret. He just ran away.
On mic, maybe.
Okay, mic check.
We hear you good now.
In order for the shit to work the way you even think it's working, the Earth already has to be curved. So you have to prove Earth is curved in some other way other than this, because for the refraction to work the way you think it does, it already has to be curving. So this anything involving refraction can't be your proof of Earth curve.
I don't think it ever is, first of all, but couldn't you just...
Oh, okay.
Yeah, we're not the ones that show that. The only reason we bring it up is because you guys show observations that are describing things that are too far or whatever.
Everything you have is involving refraction.
The only times we talk about refraction is when we're explaining refraction or explaining why you can see too far or whatever else.
Oh, okay.
We don't use it for proof of the globe.
Okay, cool. So let's see the globe measurement. How'd you get the radius then?
We could start from Eratosthenes. We could
with no refraction, right? We can't use refraction for this.
Yeah, we didn't use refraction for that. We used Eratosthenes' method and came up with a number for the radius.
Eratosthenes had to do with
sticks and shadows.
Which shadows are made by light.
Right. Yeah.
And the light, there's no refraction involved with this.
There was no refraction needed to think about or discuss or talk about or know about or anything. No.
So there's no refraction.
Refraction is very much reduced when you're looking more straight up because you're not looking crosswise to the density gradient.
Listen, Eratosthenes is a mess. We went over this a couple months ago. That shit's not going to work for you. There is refraction involved with Eratosthenes. Okay.
Well, if you involve refraction when you're doing Aristosophanes' method, you're actually doing it wrong.
Okay, are you using a shadow?
Yeah.
Okay, and the shadows are caused by light.
That's true. Yep.
Okay, and if the light's bending at a different angle, it's going to cause a different length shadow, right?
Yeah.
Okay, so refraction.
Okay, check this out, dude. Light also.
Did you hear what just happened? Did everyone pay attention to what just happened?
45 degree.
Light also has
Angle of
different
incidence.
wavelengths.
Stop lying.
Angle of incidence to the density gradient.
Stop
You know
lying,
this.
Xanax.
There's no refraction.
You're just
There's gonna be
flat out
dithering, no
lying right
refraction.
now. You know there's refraction at 45 degrees. Stop lying to everyone.
There's no refraction that you need to worry about. Like I said, if you worry about the refraction,
Not measurable.
That's your claim that there's none you need to worry. Me and Xanax know that there is refraction at 45 degrees.
We don't see distortions.
Immeasurable.
At that angle. We see distortions close to the horizon.
Yeah, and that's because any distortions caused by refraction at that angle is not going to change the result of what you're doing, which is measuring the radius of the Earth. So any refraction that may exist there, however small it is not going to make a difference. It's only
we
if
all
it
agree there's
only
refraction. Now we're
change
just
the length of
arguing
the
about
shadow.
how much. Okay, we all agree there's refraction. Now we're just arguing about how much refraction there is.
Yeah, sure.
Oh, okay. So you're going to need something that doesn't include refraction. Like I said, the shit has to work the way you say it works. It already has to be curving for this to work.
Yeah, but
you
I
need something without refraction to prove optically that Earth is a sphere.
Yeah, but I never said there wasn't refraction there. What I said was this test doesn't include refraction. Because if you include refraction when doing this test, you're doing it wrong. Because the refraction involved there is not going to be relevant. So there's no need to bring it. There's no need to use it or bring it up or anything.
That's your claim. Now we're just arguing about how much refraction there actually is.
That's not fun.
We're right back to a refraction argument.
Jeremy, you're the one claiming that it's significant, so I would think you'd need to show how it's significant.
Well, I think there's refraction there. Okay? There's refraction there.
And you're not allowed to imitate people here, dude.
If you take a look at the sky, you see a lot of consistency away from the horizon. Like angular distance between stars is constant, shape of the sun is constant, shape of the moon is constant. Everything looks like pretty consistent. We don't see any distortion, like at all, away from the horizon. We only see like weird shit close to the horizon, and even then, we're talking about like less than a degree.
Dang, that's a good point, man. That's a good point.
That's your claim that it's off of less than half a degree or whatever. Have you ever measured it?
Well, you don't have to prove a negative, dude. You're putting the burden of proof on us, right? That's the reversal.
He just made a claim it's only off by a degree. Hold on a second. You just made a claim that it's only off by a degree. Do you have any proof of that?
No, he claims that the major distortion of the significant distortion of refraction all happens below a degree from the horizon, down low.
No. That wasn't what I said.
It wasn't.
Yes. So one way you can
demonstrate everyone that. Stop trying to white knight him. Can you back your claim up that it's only off by a degree or not?
Sure. So
okay.
Yeah.
So let's have the measurement.
Right. We can compare, for example, the horizontal versus the vertical angular size of the sun, because the horizontal isn't changing across the day, but the vertical changes when it gets close to the horizon, and you can get that measurement. Like you can get that as an estimate for how much of distortions you get close to the horizon.
And that proves that the actual distance, the actual angle of things, the actual position of things is only off by 1 degree.
So it looks like it because it's consistent. It's consistent.
Okay, where's your measurement of the thing's actual position and it being off by a degree?
Well, I'm trusting the tables from the almanac, but I can do the measurement. Well, one sec. I can't do the measurement myself.
You can't? Has anyone ever done it?
Probably. I didn't.
I'm sorry. No, you're going to need to show me that this thing's actual position, and then it optically being only off by a degree. So you're going to need something non-optical
to judge it against. Obviously, we're not going to use more
I'm not
optics to
talking about
prove.
actual positions.
You
I'm
can't
saying
use move op. That's what you
yeah,
were claiming when
no,
you
no, it
claimed it was
was
only off by a degree. You're claiming it's
not
only off by a degree by its
off of
actual
the
position.
actual. No, I didn't ever mention actual position. Not off
So
of
off
actual
of a
position.
degree by what?
Can I explain what I said? Thank you.
Yeah, I'm trying to help
No,
you along. Off of a
no,
degree by what? Its apparent position.
I can clarify by myself what I meant. I don't need your help for that. So what I
I'm
what I
trying to
saying
find
was,
out which position it was off of a
dude.
degree by.
Yeah, I'm trying to answer that question. Yeah, when I said that there's a lot of the sky is pretty consistent, is that those the angular size of things, the angular separation of things, are pretty constant the whole day. They don't seem to change. And when I said it's off by 1 degree, is compared to that. So when you have an angle measurement between, let's say, two pairs of stars, if they're away from the horizon, that's not going to change anything. If one of them gets close to the horizon, that might change to about a degree. So I'm not saying off of their actual position. I'm saying off of this consistent position that we can see all the time, except when they're at the horizon. That's what I'm talking about.
Okay, so you don't know if it's off, at what amount it's off of its actual position. So your statement is, yeah. So what's that worth?
I think it's like if you're going from the consistency of how things look in the sky during the whole day, I think that's a pretty strong point.
Of an average apparent, not actual position.
Not average.
Yeah,
I wasn't talking about
that's
average.
an average. Well, it's not its actual position. So what
I'm not
position are you
talking about
talking about? If it's not its average position or its apparent position, are you talking about its actual position, or what position are you talking about?
I'd say from 20 degrees up, I think it would be real close to its actual position.
Do you have okay, cool. Do you have a measurement of that?
You could measure it from 20 degrees off one horizon through the day to 20 degrees off the other and see if it varies through the day.
Yeah, just observe its movement. Notice it's let's call it 15 degrees per hour, even though it's slightly.
Osho's going to try to save you guys right now. Go ahead, go.
No, that's right.
Even though it's not 15 degrees, we're going to call it 15 degrees per hour. Okay, just for simplicity. Just look how it's moving, what speed it moves through the entire day, specifically between 10 and 2 p.m. Okay, and then observe it moving through the later part of the day, and note when it starts changing speed. And if it was consistent up until that point, then you can you can basically base the speed that it's the refractive effects of its position moving based on how consistent its movement was.
Exactly. So you have the sky consistent everywhere, every direction you're looking at, like the angular distance between stars, the angular size of the sun, the angular size of the moon, the shape of the sun, the shape of the moon. All that is pretty damn consistent everywhere, all the time, except when close to the horizon. If you compare how they look when they get close to the horizon compared to how they look when they're higher, that's how you get how much the horizon is distorting that consistent image of the sky that we have. Doesn't tell you about actual position. It tells you about how it distorts something that is consistent in the rest of the sky.
Okay, awesome. Do you guys have an actual measurement of the radius or the spherical nature of Earth where refraction is not involved? Because all you have is these apparent bullshit positions and you don't know the actual position.
Dude, stop ridiculing our position, man.
Your position sucks.
No, I have evidence for you. Very easy evidence. So we don't have to use any refraction.
Easy peasy.
There's no refraction. There's no refraction when you look through a 2-mile tube of a vacuum. And you look through the 2-mile tube of the vacuum, you measure that vacuum that's kept to 20 thousandths of an inch straightness over 22 miles. You measure that those plumb lines vary 30 thousandths of an inch, and that is showing the curvature of the Earth because you have varying plumb lines, and varying plumb lines only can happen on a curved surface. So there you go. No refraction because it's in a vacuum, and varying plumb lines. You're done. It's over with.
It's not in a vacuum. There's gas in that.
It is a vacuum.
There's gas.
10 to the minus 7.
Do you know how many molecules that is per cubic millimeter?
Besides that, we also
you know how many molecules that is per cubic millimeter?
One molecule per mile. One molecule
that's
per
not
mile.
what. That's not what it
Yeah,
is.
that's what it is.
You just made that shit up.
That's what it is.
You just
Listen,
made that up.
so we have
That's
10 to
not what
minus
it is.
10
You
to
made
minus
that up.
10 minus 5 or 10 minus 7.
You're just making things up. I'm done with you.
Forget about the air in there. We have measured it. We have forced
You
the
just
line.
told me.
Hold on. We have forced the line. We're not even talking about air. We're not even talking about the vacuum. We have forced the line by making
Air
sure
in the
that
vacuum.
items. Doesn't matter what's in the vacuum. We're just going to use the outside of it. Forget about the inside. You're just being opposite.
Okay, we're using the outside of the vacuum. This makes sense.
Outside of the vacuum
Okay,
tube has been
we're outside.
machined. Hold on, has been machined perfectly. We forced the line. Make sure every one of the tops and bottoms is the exact same length as best we can, and over all the additive errors that go up along this distance is 20 thousandths of an inch variation over the entire 2 miles. We still measure varying plumb lines, so you can't get around this one. It's done. Force the line, divergent plumb lines, curved Earth.
Okay.
Period.
Just
No
show me
refraction.
something where refraction wasn't used. First you had us inside the vacuum, then you had us outside the
Not
vacuum.
refraction. Well, because you're confused what the vacuum is and how it would react to any kind of
I'm
light
not
bending.
confused. No, you just made shit up about the vacuum when you said 1 molecule per mile. That was a complete fabricated number in your mind. I don't know where you pulled that out of your ass.
What does it mean when you have 10 to the minus 17 torr? What does that mean?
It means you have a number of molecules per cubic centimeter.
No, it doesn't.
Yeah, that's a specific, that
No, it
10
doesn't.
to the
It doesn't
next,
mean that at all.
that number you just said, that means that there is a specific amount of gas molecules per cubic centimeter.
No.
Okay, what does it mean then, genius?
Force. Thank you for finally getting something right. You get the answer by the force exerted on the walls of the container.
Which it would be by what? By how much gas is in there, right?
By the molecules' change of direction when it hits the surface.
Yeah, by the amount, yeah, sure, and it's going to be a specific amount of molecules in there doing that, right?
Could be one molecule doing that.
Oh, really?
Mm-hmm.
But it's not one molecule because the torr you said was not one molecule.
Correct.
It's a lot
but
of fucking molecules.
You can't have that pressure if you have more than a few molecules per centimeter.
Dude, you have the thing. Do you know how many molecules are in? Are we at LIGO right here, or Slack?
I'm on Slack.
Okay. Do you know how many molecules there are per cubic centimeter in the tube at Slack? It's in the millions. It's in the millions.
If there was millions, then there'd be more than they wouldn't get that pressure then.
Ruhaf did the math. Ruhaf did the math on it. There's millions per cubic centimeter.
Mm-hmm.
Uh-huh.
And what does that mean?
That means we're not in a vacuum. We're in a pressurized system of gas.
The vacuum is compared to the air.
Yeah,
It's
the vacuum.
It's 17 torr versus 760 torr.
So is there refraction in there?
Light always will refract over air molecules or any molecules.
So there is refraction, yes.
Hmm? Which way does
So
it
do
go?
we have anything without refraction?
Which way does it go? Which way
Do
does
you
it go?
if we're not, it doesn't matter. Now we're in a refraction argument. Do you have anything without refraction? Yo, hold on.
That's why we remove.
Hold on.
Hold on. That's why we remove. Hold on. No, let me finish. That's why we remove the refraction, use the top of the container. Now, by the way, we can still shoot the laser from one end to the other and verify that it is perfectly straight and there's no refraction occurring. We verify it by the target we hit with the laser or with the accelerated electron.
We're now in a
there's
refraction.
No refraction. We measure it to not have refraction in that too.
We're now in a refraction argument. Do you have anything without refraction?
That doesn't have refraction. We
You just told me there was refraction.
No, inside. I've already gone past that, Jeremy. Don't piss me off.
Yes, inside. You know how many gas molecules are
not inside. We're not inside.
You know how many gas molecules? We're outside.
No gas molecules outside. We're not using any light
outside.
outside.
Gas molecules outside?
We built the structure. With enough diameter so that we can measure if we are forcing the line, as your buddy Mullen wanted to do. We've already done that. And it's kept it straight within 20 thousandths of it. Stop talking. 20 thousandths of an inch. So now we know that the varying plumb lines are not due to refraction. It's due to the Earth having divergent
what varying plumb lines? Listen to me. Where is the measurement where there was no refraction involved?
That is a measurement right there. I just told you about it.
Which one? Outside the vacuum.
Outside the container, on the top of the container.
Okay, how?
You got to tell me, we forced the line. We made 20-foot sections. Each one of these 20-foot sections are exactly the same length,
20-foot
top and
sections
bottom.
of what?
We stack them up. We stack them together, and they have an accuracy straightness
Stacked what
of
together?
20 thousandths of an inch. Why do you feel compelled to talk over
Because
me when
there's
I'm
like
explaining
30
it to you?
questions you're not answering. What?
No.
What did you
You
stack?
keep on
What
asking the
line?
same question over and over again. We
Was it
forced the
wood,
line by
steel?
stop talking. 20 thousandths of an inch accuracy of a straightness of this object that is
What was the
completed
object?
by using, we forced the line. Stop talking and listen. 20 thousandths of an inch straightness created by forcing the line of 20-foot sections of 6 inch, or I think it's a foot in diameter of
sections of what?
copper tubing. Copper tubing.
Copper.
We line them
They
up.
did this with copper.
We did this copper, yes.
They forced the line with copper tubes.
Correct.
How'd they line them up?
They machined them so they were the same height and width as every other tube they attached to each other in diameter and length.
They just connected tubes together.
We forced the line, just like.
How did they make sure it was straight?
It's like your faggot buddy knucklehead Brian Mullen did.
How did they make sure the pipes were straight?
Because they machined them to be perfectly straight and perfectly flat. And
a
perfectly
20-foot
same
section.
size.
A 20-foot section. They can maybe.
Then they validated
a 20-foot section. Hold on a second, Xanax. Hold on.
Make sure the length. They measured it because they can measure things with measuring devices over each combining two sections.
What measuring devices? Here we go. What were the measuring devices?
Rulers.
Where?
Rulers?
Rulers. Yeah, they use
So
rulers.
they had a ruler.
You're being a knucklehead.
So they had. Hold on. We got a ruler in these two pipes. Now what?
I would say that they machined the ends. At
Dude,
90
this didn't
degrees,
happen like Xanax saying it did. Xanax is. I don't know where he even got this from. The ruler, really, Xanax? A ruler? Anything without refraction, please. No GPS, no refraction, GPS bullshit. Kosho's always trying to pull. Okay, no reciprocals, zenith angles. It has refraction. Everything I've seen has refraction. And even Xanax's little bullshit laser beam outside the vacuum. What the fuck? That's the evidence of the straight line is outside the vacuum? Any kind of globe evidence without refraction involved. That Earth is actually a sphere or the radius or something. We're going to need a radius value for this one with no refraction. Because if you just anything with refraction, now we're just in a refraction argument that you can't prove what happens over long distance in the atmosphere. And even if you could, your Earth has to be bending anyways for it to work the way you say it's working. So you have to prove that it's actually happening before you use this method. This isn't hard to understand. It's circular reasoning if you're trying to use anything with refraction to prove Earth's radius. Because you have to have Earth's radius for your refraction to work like it does.
You're beginning to sound even dumber than Nathan Eckley. I told you. Force the line, finally machined tubes, lined up, perfectly straight within 20 thousandths of an inch.
How'd they get them straight? How'd they get them straight?
I'm tired of repeating myself. And I think...
For the ruler?
Even Left Lane even mentioned it. We machine them perfectly straight. We can make things that are perfectly straight. Near perfectly straight, actually.
Okay, 20-foot pieces, yes. But how did you make sure the 20-foot pieces were aligned together straight?
But when you made them together, they are assured to be aligned by measuring that they're assured to be aligned straight.
Okay, how did you measure them? I agree the 20-foot sections can be straight, but now you have to connect two of them together. How did you make sure they were straight in relation to each other?
You have a finely machined surface and you bolt them together.
Do you know what the error bar would have to be for this?
Right now,
Atoms.
20,000
Atoms.
additive over 2 miles.
Dude, this would have to be within atoms.
Dude,
to be
you
straight.
are incredulous because you
If
don't
you're off
understand it.
by a
Right.
half
No,
a
you don't.
photon,
You don't understand it. You don't understand how
if
machinists
you're off
work. You
by
don't
a
understand how
half a
measuring's done.
proton,
You don't understand how
listen,
measuring's done.
if you're off by 1/10,000th of a proton at the beginning of that, you'll be way off at the end.
Oh,
Way
really?
off.
How often would you be? How many sections would there be? How many 20 feet sections are there in 2 miles? Do you know?
In 2 miles? A
I have
lot
no
of
idea.
sections.
Because you can't do math.
What do you mean I have no idea?
What? How many
Of course
sections?
I have
Tell
an
me.
idea.
Quick. Tell me.
I don't know, over 2 miles, maybe 1,000. 500.
How many? What?
I don't know, 500 sections, 1,000
Why?
maybe. I don't know.
How many?
Was there 5,000 feet in a mile about? 10,000. So we got 10,000 divided by 20. I don't know. What's that? 500?
Yeah, 500 of them. Sure.
Okay.
Each one of them measured.
How do you know you didn't?
Straight.
How do you know you didn't do a disco ball around Earth? All you'd have to do is be off by a little tiny bit. You'd have to be off by a little tiny bit.
That's right. Believe it or not.
Yeah. So how do you know you didn't do a disco ball?
Because it has to be a gross error every single unit to be off by that error. So all you need to do is make sure 528 of them are going to be straight within 20,000ths of an inch.
So you got copper pipes that are these machined, and that's what they did within one. How much? What was their error bar?
20,000ths of an inch.
That's what they machine these pipes to.
So they're additive over 20 miles. We'd have no more than 20,000ths of an inch.
These
error.
copper pipes were machined to be within 1/20,000th of an inch.
20,000ths of an inch over 2 miles.
How do they know that?
That means each copper pipe would have an accuracy maximum if all of them had the same error stacked up. That'd be.
They know that's what it was at the end.
3, 4, 1.
When they did this, how do they know that?
Thousands, 10,000s, 300,000, 37
Hear me?
37
Can you
million
hear
of an
me?
inch.
Can you hear me, Zanuck? How do they know that that's what it was at the end? Zanuck, can you hear me?
I hear you fine.
How do they know that that's what it was at the end?
Because they can do math. They measure
They
on the
did
way
math.
up
So they
to what they have at the end.
just did the math and said we did it.
And they check with a laser.
So they didn't measure with the refraction laser.
No.
Yeah. Refraction laser. There's refraction in that laser beam.
What is the refraction through a vacuum? A near vacuum. What do you think it is?
Is there gas molecules in there?
You know what the refraction formula is? What the equation is for
gas?
refraction?
Is there gas molecules in there?
No idea. You have no idea.
Is there gas molecules in the vacuum?
Yes. And how much can it?
Is there light passing through?
How can it possibly? How much can it possibly refract in the worst case scenario? How much could it refract? That's the question you got to ask.
So there is refraction. Now we're just arguing about how much.
We know how much there is in there because we have the measure of the.
Okay, so there is refraction in the vacuum, and now we're just arguing about how much.
How much can it move over that period of time? So you're arguing like Nathan Oakley. So I'm kind of done. I don't want.
What do you mean you're done? At least we now agree that there is refraction. So we're just arguing about how much.
We can't measure things because of refraction. No, that's not how it works.
Yeah, well, your refraction only works because it's a globe, and it has to go through this curved gradient. You don't even know the thing was straight in the first place, but that there's not some other effect that's making the laser bend. There could be some other effect making the laser bend. You don't even know. You've never fucking measured it. You got a lot of faith in that slack laser beam. They never checked to see if it was straight, though. There's a thing where they can make a laser appear to bend but it doesn't actually bend. So it's basically like refraction, but it's not actually happening. It's when peaks interact with peaks and troughs interact with troughs or something. The wave of the light, you ever hear that? That's another thing. It looks like it's bending, but it's not. How would you measure that one? I don't know how much faith you want to be putting in these laser beams, man. On a side note, if we just do one more laser test, we'll probably have this whole shit over with. Like one more laser test, we'll be able to shut it down. So, what else? I think I was a little rough on Bacon. Did he leave because of me? I gotta say, Zanuck came the closest to the no refraction one with his laser beam. Kosho had the worst one with Eratosthenes. That has all kinds of major flaws in it, anyways. That has so many presuppositions. You have to know the distances and shit.
You watching the chat, Jeremy? This guy Protos had, I don't know, he seems to think he's some sort of freaking genius. And he's up looking at the stars. But when I bring him down to the water, Wouldn't you come on VC there, Protothad? I'm tired of typing. Oh boy, we even got Earth is life out. Oh boy. That water triggers the hell out of them. Give it up, guys. You can't argue water. Come in VC, Protothad. Come in VC. I'm tired of typing. We can discuss water. And you can make some popcorn. You're going to need it. If you ask for water curve, does showing a Himawari picture count? What do you say, left lane?
Do what, Odysee?
If somebody asks you for proof, if you say you have proof of water curve and you show a picture of Himawari, is that considered proof?
Himawari definitely shows curvature.
Yeah, I don't disagree with that. The images that we get from the supposed Himawari shows curvature, but is that proof? Is that sufficient proof of curving water?
Yeah.
Like, would you bet your life on that picture? Let me put it to you that way.
No, I would probably stick to personal observations of things disappearing with distance.
There you go. Yeah, that would be a better proof, no? Or try to make your case in that sense, right? You wouldn't go to the sky.
Well,
I wouldn't anyway.
Yeah, I would. I mean, just for motion and shape, I think I would go to the sky.
Yeah, that's the difference between me, I guess, and you. I wouldn't go to the sky for anything unless I wanted to get a suntan. Yeah, there's a lot of sky talk now with the Sexton boys and the angles, and proof of the surface of where you're standing by looking at the stars. That's astonishing to me. And now we have both sides trying to make that argument. It's crazy. One side thinks it's a ball, the other side thinks it's a sphere. And what are they using? The same thing. The same thing. Crazy.
Yeah, no, that's definitely weird because they're the antithesis. They're the antithesis of each other, basically. You know, the flat or the globe.
Yeah, bro. They're both looking at the same thing and saying, "Look, you idiot, it's flat. No, you idiot, it's round." And they're looking at the same thing. I find that truly amazing, man. Like, really, honestly, from the bottom of my heart, I find that amazing. And it's like, it's amazing. Like, not to pick on B-Ball, right? But you know the picture he just posted? He has a picture showing water blocking 16 stories of a building. And he shows a picture next to it how the building should look like. So now, logic, right? You have water blocking 16 stories of a building. So you tell them, okay, if you paddle your boat, right, or you drive whatever, you row your freaking boat to that spot where that block off is, what do you think would happen there? What do you think would see there? What would you see? And the answer is, of course, the answer they give is the water is level there. It's the same as the water here. Then how could that be blocking it? Then you ask him, okay, that water that's blocking there, right? If somebody's in the hotel down at the bottom where that floor is missing and they look straight ahead, what are they going to see? Are they going to see a 160-foot wall of water? And they laugh. No, they won't. What would they see? Well, they'll see level water. Then what's blocking? What's blocking the view? I mean, it's sheer ludicrous, but they buy it, they believe it, and they argue it.
Where do you see a 160-foot wall of water?
Well, B-Ball for Life shows that. You never seen that picture that he shows in Hawaii? His famous picture? Yeah, let me find it. He posted it up. Let me see. Can you see live chat? Live stream text 1.
Okay, what am I looking at?
You're
like
looking
the distance,
at
the height, and what else?
Distance is about 16 miles, if I remember correctly. I'm sure he's listening, so he'll correct me. And there's 16 stories of that building missing.
Correct me if I'm wrong, but that looks like a wave, like somebody can surf that wave. Is that right?
Yeah, that's what it looks like to me. Yeah.
So a wave closer up, right? Let's say, I don't know, 30 feet, will block a farther object farther away. Let's say 16 stories. Makes sense?
Yeah.
I'm just thinking out loud.
Yeah. You're using your brain. Yeah, exactly. Could be a little wave. It's definitely not a wall of 160 feet of water. That's one thing that is certain. Absolutely.
Also,
So,
isn't there a point where the distant objects will begin to blend into the horizon, so they cannot be the light doesn't come back?
yeah, it's a visual thing. I guess, yeah. But any sane person.
And they vanish from the bottom up, right? Not from the top down.
Sorry, say again?
The distant objects will eventually vanish from the bottom up, not from the top down.
So now we're supposed to believe that a person, because it can't be any other way, right? Can't be any other way. If that's physical water if there's a person at the lobby there, you know, the guy that takes your luggage. Now, if he looks up, he has to see 160-foot water there in front of him. And of course, we know that's nonsense, right? That can't happen, right? At least I think it's nonsense. Or you have to think there's an actual hump. There's an actual curve. This is how they say it. Oh, it's a curve of water. And of course it blocks. And you tell them, well, how's that thing? Well, gravity. Gravity. Uh-huh. Anyways, it's comical. I thought I would bring that guy Proto Thad in, but obviously he definitely doesn't want to support his argument. Because he knows the only thing that he can say is Himawari. Look, Himawari. There's the curve. Himawari. Yeah.
Was it what's it who debunked the Himawari? They were claiming that they had live feed, but actually don't have live feed. Delayed by 10 minutes.
I'm not sure. Well, we know that's not live. Yeah. I mean, I've heard of that before.
Yeah, I'm pretty sure that Witch looked into it and debunked Himawari. They have 10 minutes of delay on all those pictures, and that's how long it takes for the computer to draw the globe around the clouds. They take the data from weather balloons and they draw it on a sphere.
That makes sense. Yeah, to render it. Yeah, makes sense.
Yeah.
That's why they don't show us stars, because they don't have enough powerful computers enough yet. You'll see one day they're going to start showing stars. You're going to see. And that's going to be when they can reproduce them accurately. That might be in 10 years from now, but you'll see one day they'll start showing stars. They're going to say, look, there's the stars.
I'm actually worried they're going to take these people supposedly to Mars, right? Sign them up, put them on put them in a line, these people that are going to basically sacrifice themselves for the first Mars mission. So they take this big ass computer. They've been compiling all the social media posts, all the letters, and emails, phone calls, messages, text messages, and they have them in their computer. So they're gonna get an AI, the best AI that they have, to copy the person. So they're gonna act like they're actually on the moon somewhere, making up these stories about them being on the moon, and the computer is basically controlling them, sending you pictures. Oh, here I am. Here we are. Controlling their text, their voice. Meanwhile, they've been turned into Soylent Green.
Yeah.
Never to come back. That's what I'm really worried about.
Yeah, it's so easy to fool people. Have you seen that British TV show that fooled a bunch of participants that they were competing who's going to go up in the space shuttle and orbit Earth? I'm not sure if it was a space shuttle, but they were gonna orbit Earth in a craft, and they competed, and seven of them won, or 9 of them, but amongst them there were actors that knew it was a scam. So they did the
They were
whole
told
thing.
that I'm not actually going to space.
Yeah. 2 of them actually knew. Yeah. So they made this elaborate thing, man. In England, they rearranged an old military base, and they made it look like it was in Russia. So they went to Russia. They bought Russian chips, chocolates, cigarettes, the works, everything. They made like a little town in there, and so they convinced him. They flew him out of England, and they flew him around in circles, and they made them believe that they landed in Russia. Like this, what you got to see this. I'm not making this up. It's a TV thing. So, anyways, eventually they took off and everything, and they bought the whole thing. They bought everything. Now, you might be wondering, how did they convince him of 0G, right? Because they were in a studio all this time. You know what they told him? And they bought it? They told them that they have an anti-gravity machine. Or not an anti-gravity, a gravity-making machine. And they bought that as well, man. Yeah. And then you see at the end of the show, they were all in their... they thought they were in their thing, in their spacecraft. And then they opened the door in front of the audience. And you should have seen their faces, bro. Should have seen their faces.
The hardest thing is for the ego to admit that they've been fooled.
Yeah, that freaked me out when I saw that. I go, wow, man. They actually fooled them. You see, there was a couple of times when some people were skeptic of something, and then the actors came in because they had 2 people that knew it was a scam. And just with a few reassuring words, yeah, they were back on. Yep.
Just with a few reassuring words, they're back on the globe. And that's what happens when NASA puts their shit out.
Yeah, and this wasn't even a big production. It was a film. It was a film, a news thing or something from England. Hardly a $60 million budget a day operation. But what freaked me out is they went to Russia, they bought all Russian stuff, and they actually made them believe they were in Russia. Because of course they would have to take off from Russia to for them to be able to lift off.
You know, I've heard that North Korea was fake, and the when people come visit, they have like a facade city where there's like fake oranges in the orange stand, and everything is fake. Have you heard that?
Yeah, I've even seen a video on that. Yeah, they
it's kind of scary, bro.
Yeah. The story is whenever they bring somebody there to show, like they'll make restaurants and there'll be nobody there with a waiter, and like they'll serve you food, but you'll be the only one there, and it's all a sham. Yeah, it's all a sham. That's what they say. Now, who knows?
There could be like a small group of people, like I don't know, 5 or 10,000, just enough to support like a little city, and the rest could be all facade.
Yes,
I'm only guessing.
Yeah, some people say that North Korea is a sham on its own, but really, who knows? But I seen a thing that what you're saying, and the guy went in there and he went to a restaurant and he goes, "Look, I'm the only one here because this has to be this has to be a scam." And he everywhere he was going, he was supervised, right? He had a handler. Well, I see Proto-Thad is still there, so I guess he doesn't have enough cojones to support his theory.
No cojones, huh?
Or it could be late and, he doesn't want to talk loud. I'll give him the benefit of the doubt.
Who are we talking about?
Proto-Thad, the newest navigator on the scene, professional navigator.
Oh, then he knows how far to navigate to drop down and not get wet, huh?
Yeah, I'm sure you'd like to have a convo with him, bro.
Yeah, so he can fly forward like Jesse's thing, the same amount as Jesse's, like the building, how far away it is from his little scope. Just fly your drone that far and then drop it down 240 feet, but only start out 10 foot above or 1 foot or 2 foot above or 5 foot above the water. Yeah, start out about 5 or 6 foot above the water, fly as far as you said the buildings are away, Jesse Gordon or prototype, and then drop your drone down 240 feet without getting wet. We'll be good to go.
Yeah, he told me there was a curve just before he showed it to me from the Himawari. So just follow that. Then where the curve is, just drop. That's it.
Yeah,
and we'll be watching you drop down below the water. I like that idea. Yeah.
Without getting wet. So 6 foot above the water, go out about 2 miles. You can drop down 1 foot or 2 foot without getting wet below where your height.
We'll give him 3 miles. We'll be generous. We'll give him 3 miles.
Okay, so you start out at 6 foot and you got to drop 8 foot down.
That's it. Simple task. Yeah,
and don't get wet. Matter of fact, drop 7 foot. So just drop 1 more foot than you started from and don't get wet. Just 1 foot past the curve of the earth and we're good to go. I'll be a Glover tomorrow.
That's it. Done deal.
Did you know a rope sitting on a curve pulled up is going to be longer than it is laying across the curve? So if it's laying across the curve and it's like 100, right? When you pull it up, it's going to be 150 or 120. It's going to be way longer. It'll be longer straight than it will on the curve. Isn't that weird? Not the distance covered, the area that it is.
You see, your thing that you're saying could work here. You know, B-Ball's picture? He can fly his drone out 14 miles, right? 14 miles.
Yes.
And then guess what? Not 8 feet. He can drop 160 feet, bro, just for you.
Shit, we'll just do 100.
We'll take 100. Yep.
We'll take 100. You know what? I'm generous. Just drop 60 feet, man. Just 60 feet and don't get just 60. So that's all. Start at 6 foot above the water, go out, and then drop 60 feet. We're fucking gold.
All that's
and
left
do
is
it
to
over.
laugh at them. That's it. That's all
Do
that's
it over
left is to laugh.
Which one's the biggest ocean nobody wants to fly over? The long one?
Well, the Pacific Ocean, I guess that's
Yeah.
the biggest
Yeah,
one.
we'll do it over the Pacific. Yeah, that way we know we got enough water out in front of us.
Yeah.
Any Glovers?
B-Ball has the ideal thing for you, bro, right here.
I know, and I want to bet
B-Ball
money.
is your guy.
Yeah, and he should bet 1,000,000 to 1 or 100 to 1. Any Glober should bet me 1,000,000 or 100 to 1. I'll put up $1,000 or 10,000 or whatever I can scrounge up, and then they'll give me 100 to 1 odds, right? Because I'm retarded, and there's no way in hell we're on anything but a ball, right? There's no way they can lose. So if I bet 50,000, they could match me 100 or 1,000,000 to 1. They're never going to lose, right? Shit, we can take it all the way to the betting club, the better's house, in Los Angeles or LA or California.
They're too smart. They wouldn't take that bet, bro. They're too smart for that. They won't take any
You mean
flat earth bets.
Vegas wouldn't take my bet at 100 or 200 to 1 odds?
No chance.
That's crazy. What if we all came up with an amount of money and we put it in, and the amount paid back, you get the amount you put in times the odds? I mean, you know, it's math. I mean, shit. And it wouldn't be me holding money. It'd be the bet against, you know, the people would have everybody's ticket. You see what I'm saying? Everybody just went in on the amount. The bigger the amount, the bigger the payback. It's the way flat earthers can be rich for fucking free, basically. You know? Because there's no way we can lose. So
it's too funny. Water, they have no chance when it comes to water. Don't even try. Don't even try.
Dance underwater and not get wet. Just bet me 50 to 1. No, I want my 100 to 1. Fuck that, because we got some millionaires here. They're able to give away 100 grand pretty quick, pretty easy. It's no fucking big deal. They can make $10,000 bets on dog shit all day. No problem, right? They don't give a fuck. So my little measly flat earth $1,000 against 100,000 that they can't dance underwater and not get wet. Not really that, but just, you know, fly out, drop 60 foot, drop your object 60 foot and don't get wet. It's so simple. Fly your drone out, your helicopter, whatever.
Yeah, that's a legitimate thing. If they live on a spherical, mythical thing, that's easy peasy to do that.
Yeah.
As a matter of fact, it would have to do that.
Yes, Jesse Gordon. He's got 240 feet, you know, with his little building, right? And he's showing everybody, and he won't shut up about it and keeps coming in here. Tell him to fly the drone out and drop that motherfucker 60 feet, but only start at 6 foot above the water. And then he's going to have an excuse, isn't he? I bet you he has an excuse. I bet you all the Globers all of a sudden have an excuse that their curve doesn't exist now.
Now, I know what their excuse is going to be, but I wouldn't say it because I wouldn't want to give them any ideas. But I know what that excuse would be.
What?
Nah, I don't want to give it away. I don't want to give them ammo.
I know what all their excuses. They're going to have more than one.
Well, the main one, the go-to one.
Oh, gravity, it's happened to me. Not in front.
No, not that.
No. Oh man. I thought that was the go-to for everything.
Something to do with equal. Something to do with equal. All right, I'll tell you because I can combat it. I mean, they're gonna say equal elevation.
Yeah, equal elevation, equal altitude. Yeah.
Yeah.
But there's no such thing on a ball.
Nope.
What the fuck? How can you, if everything's under your feet, there's no equal.
See, we can play both baller and flat earther at the same time.
Right. But like, yeah, the sheer idea that a helicopter can hover above you and fly past a cliff, and it doesn't affect it, means that the Earth wouldn't affect it either. I mean, there's nowhere I've seen any dirt affect any helicopter or airplane in any weird way. Never. The only thing that's ever affected it is the object being in the way of the wind or not, right? Allowing there to be enough resistance or not. Like if you're in a mountain or down in a dip and the wind's being blocked, then you'll have a problem. Other than that, you'll that's
like
it. That's all.
Like a plane, you know, gusts of winds and shit like that. But a helicopter more so, yeah.
Yep. But now if you're just flying out a couple fucking miles over the ocean and you're staying 5 foot above the ocean and you get to drop down 240 foot in your helicopter, let's fucking do this shit, baby.
Yep. You either have a drop or you don't. Simple. You either have a hump or you don't. The water is either blocking you or it isn't. There's no two ways about it.
Well, and they can't say helicopters ain't flying down around it because National Geographic does it with a helicopter. What the fuck is their excuse now?
That's right. We saw a picture of that. That's right.
What would be their excuse? Come on, Jesse Gordon. Come on, Jesse Gordon. We don't need all that garbage you got going on. Let's just drop it low. We'll use your math, and you just wrap some towels around the helicopter's things, the little bars. Wrap some towels or some tampons or something on there, and then when it hits the water, they're gonna get absorbed and they're gonna swell up. A color changer stick. If you touch the water, it changes color. Yep, that's how we'll know. Yep. You know how in your cell phone you got that little white tab, it turns pink if you get it wet? Yes. That's what we're going to use. We'll have that little material on your drone hanging down. You can hang it down 1 foot below your drone on a string, just a white cloth material. You fly your drone out and you drop it 60 feet. We just need 60 feet. I mean, we know you can drop 60 feet. You can drop 240, clearly, right? 60 foot, and that thing should come back white still, not pink. Yeah.
Hey, we have Matthew here, mathematician. Maybe he can figure out the drop rate for you, or if it's feasible. Have you heard his idea, Matthew?
No.
Sounds crazy at first, but it's not.
Let's hear it.
Let him have it, bro.
Well, to start, where your observer is, where you got your little optical thing, where you start, your view, fly your drone straight out. And when they claim, the building's this far away and there's 240 feet of missing building, you just match it by dropping the same amount with your drone. So you fly your drone out, you watch it in your optics, you can see it, then fly it out, and then drop it 60 feet, not 240. Fly it out the exact distance, then drop it 60 feet without getting wet, and I'll become a baller. Over water.
It's going to be hard to fly your drone in a straight line rather than curving with the earth beneath it.
So it's going to be hard to drop 60 feet. So if you curve down with your drone, you're clearly going to curve down 60 feet, right? You shouldn't have. Hold on a minute. You should not have a problem curving down 60 feet and not getting wet when you're flying around the globe and not, right?
Right.
You're only going to start 6 foot above the water. Now we're going to fly out. And if what you say is correct, we should be able to drop down 60 feet and the drone won't get wet at all because it's going to follow the curve. It wouldn't possibly be able to get wet. And it's going to drop our 60 feet. We're all going to be happy and it's not going to be wet, right?
Wait, how far out are you going to drive it?
Excuse again.
How far out are you going to fly?
It's going to go forward and follow the curve and drop 60 feet.
I'm asking how far forward will it go?
Far as you need it to.
So
far as the globe says it needs to go forward and then be able to drop 60 feet without getting wet. It's going to go it's going to start out 6 foot above the water. It's going to fly forward. And it's going to drop 60 feet. We don't care if it drops and goes down. That's what we want, right? We're not worried about it following the curve. We're good. We just don't want it to get wet. Okay? Is that good? We good?
Yeah. Yeah.
Yeah. So where can we do this, and how much do you want to bet on it?
$0.
You don't want to bet on your globe?
No, I don't want to bet on that way.
He wouldn't bet on his own globe. We got 240 feet. We got 240. Jesse Gordon says we got 240 foot of missing building, and I just want to fly 6 foot above the water, as far as this building supposedly is, and drop 60, not 240, just 60. That shouldn't be a problem for you, right, math guys? Now it's a problem.
Yeah. What happens if your drone goes out of view?
What happens if your drone doesn't come back dry?
No, I'm saying that we would expect.
Well, I'm saying some ifs too. What do ifs matter? What do ifs matter? What if a leprechaun jumps up and down tomorrow? Is that gonna what? Does that got anything to do with what you're talking about? No, the drone's gonna go out, and if your building is missing, and we're staring at your building right now on the globe, right? Through Jesse's optics, through Jesse's cartoon, it's missing 240 feet. So clearly, you shouldn't have a problem with me sending out the drone 6 foot above the water, as far as this building is, and then watching the fucking drone drop 60 feet, right? And not get wet. I mean, this would be so simple, right?
Yeah, the problem is when
There's no problem. You got a problem dropping 60 foot and not 240. I don't understand. I'm looking at a building that's 240 foot missing. That's what's the claim is. So now you have a problem with something dropping 60 foot, but the building is dropped 240. How would you have a problem? Where's the problem at with your globe? Your globe has a problem?
When you fly
the drone has a problem, or your building? The drone hasn't done anything yet. Hasn't done it yet. We're going to watch it do it. It's 240 feet. I'm standing here and I'm looking, and supposedly 240 foot of the building is missing. And I only need to drop the drone 60 feet, and you're saying there's a problem already. I don't understand how your math works. So you're saying 60 foot's more than 240 feet? Something's not right with your math.
The problem is
with what? With the globe not curving down?
The problem is when you try to fly your drone straight out, it's not going to follow a perfectly straight line. It will instead curve with the Earth, and so its altitude will be the same as you fly all the way towards the building.
What I tell you, number one excuse.
What he's asking is correct, that if you could fly a drone in a perfectly straight line towards the building, then you could drop 60 feet.
Isn't the water blocking? Isn't the water blocking?
Now he needs to demonstrate where he can't fly a drone straight, or where a professional drone flyer can't fly a drone straight. Demonstrate that. Get a curved line and a straight line on the wall and demonstrate they can't fly straight versus curved. Have you lost your mind?
No, I haven't.
Where can a drone fly straight at? Where's that at? Show me where.
If you fly a drone across water at the same altitude, that if it's flying at the same altitude, then we Globers would say that the line that it traces is not perfectly straight.
So when I got a curved line on the wall and a straight line, and I fly my drone straight, then I fly it curved, then what's your problem now? I flew it both. Now what's going on?
So you're right. If you fly your drone in a perfectly straight line, then you're correct.
Okay, let's see it happen then.
Yeah, I don't know much about drone flights, but if you flew the drone straight towards that building, its altitude would increase from 6 feet all the way up to halfway up that building, or however wherever that building is. So the altitude would increase.
So you're saying if I start my drone and I'm looking at the 13th floor, and I start my drone and I'm looking at the 13th floor window, and my drone starts at that floor, but it's only 6 foot off the water, you're saying my drone's going to fly forward and not be at that 13th floor anymore? Show me this. Show me how my drone's going to deviate from a straight line, a straight B line, straight to the 13th floor window ever. Off flying. I've never seen in my life anything not fly straight that's flying straight. I don't know what you're talking about.
I'm confused what you're saying. You start at 6 feet and then you're aimed. You start at 6 feet and then you're aimed.
Where have you demonstrated this? Stop saying goopy shit. Where have you demonstrated it?
Oh, I haven't. I don't own a drone.
You don't know? So
No,
what
I
are you
don't
talking
own a
about? You're
drone.
talking about it if you haven't seen it. You haven't seen them both live next to each other? A drone fly the arc of the earth and one fly straight? You haven't seen that? You haven't done it yourself?
No, I haven't.
Then what are you speaking about?
I'm speaking about what I would expect in this.
How would you expect it if you've never seen it happen?
Based on a model, a mathematical model.
Something you haven't done. Well, show me it. We'll do it with physical stuff. You can't see math. You can't see numbers do stuff. Numbers don't fly.
Right.
Numbers don't follow lines and trace them. So my drone, when I aim it at something, it's all of a sudden just going to start arcing away from the thing that I aimed it at to go land on? No, never going to happen unless you can demonstrate that, claim maker.
Yeah, so you're saying you're aiming it at a 13th floor of a building, and you're at an altitude of 6 feet. Is that where you're doing?
No, you said when I aim it at the 13th floor, it's going to arc away somehow when I'm flying it straight to it. That's what you said. I didn't say anything. I'm wondering how this magic works.
I'm asking what the setup is.
I'm asking when can we demonstrate this? Or are we just going to keep on imagining nothing and going back and forth about math? When you got it from math, I'm going from actual drones flying, objectal things, and you're going from math. Somebody's losing.
Yeah, if I'm standing at an altitude of 6 feet and I aim the drone at a building that is at the 13th floor of that building, far away, and I can make it go in a perfectly straight line, then it would go up to the 13th floor.
So you're saying theoretically, not in reality, but theoretically, Matthew?
Right. I don't own a drone. I'm just saying what I would expect to happen.
Assuming a globe model, you're saying? Assuming a curving Earth surface and curving water?
Uh-huh.
Do you assume any other things, or just that amount of curvature?
Oh, well, I mean, your assumptions will determine how you answer that question. So I was saying, with my assumptions, what would happen? Obviously, if the Earth is flat, you'd have different assumptions and different things would happen.
Matthew, you see the picture that I just posted?
Yes, I see that.
Okay. This is B-Ball's picture from Hawaii, right? He's at 11-foot elevation, 14 miles away.
Okay, above 11 feet above the water. Okay. And that horizontal black line is exactly.
That's the 15th story.
But I'm asking, what is that? That's the horizontal, like straight out.
Yeah, when you're looking where he's at right now at 11-foot elevation, when you're looking out, this is what you see. You see the water blocking, what is it, 13 stories? How many stories would you say
something
there?
in
I
that
can't
range.
see.
Yeah.
Yeah. So he's saying now that the water at that distance, at that elevation, is blocking 13 stories due to the Earth curve.
That's what it looks like. What would you say is happening?
No, yeah, but just follow through. I want you to
Okay,
understand
okay.
what he was trying to tell you, right?
Okay.
I know it sounds crazy, but just listen, right? This is physics. This is your model.
Yeah, no, I like this picture. This is an interesting picture.
You like the picture, great. So you agree that there's from the edge of that water, right? There's like an 130-foot drop there of curve. It would
That's
have
what
to
it
be
looks. Yeah, that's what it
blocking
looks
the.
like.
Sorry?
Yes, that's what it looks like.
Well, it's not just what it looks like. There's water there, right?
Right.
So it's not just what it looks like. In order for you to block that 130 feet, right, 13 stories, there have to be something in your way there, right?
Right.
In this case, it's water, right?
That's what it looks like. Yes.
Okay. So what he's trying to tell you now is, if you take a drone at 11 feet where you are, and you fly it straight to that edge, right?
Right. So you fly it like at that horizon line.
At that horizon there, right? Now,
Yeah.
what do you suppose would happen if you reach that? You think that you'd be able to like drop down to the first floor of the hotel?
Yeah. So let's say that you aim it straight at that yellow hand pointing at the top of the building. If you aim the drone directly there and you make it go in a perfectly straight line, then I would say that it would end up on the top of that 15-story building.
Okay. So if you were to make it go down now, right? If you were to, let's say, like an elevator, if you were to say down drone from that 15 point, you'd be able to go down, right?
Right, because it'd be at an altitude of 150 feet at that
point. So that's what he's trying to tell you. So then you should be able to go right at the edge of where that water is, right? And then just descend down to the first floor. Right?
The edge of the water, or are you going all the way to the building? What was he saying?
What do you mean all the way to the building? Why would you have to go all the way to the building?
Yeah, I guess you wouldn't have to. You could go past, as long as you go past the water.
Right. So you go past the water and then you'd be able to drop down, right?
Right.
How far down do you think you'd be able to drop past the water?
Oh, it depends on how far past the water you go. You go let's say you go the full 14 miles out there, you probably go down 130 feet.
You could probably go down 103 feet. Well, that's what he's trying to tell you. Do you think you'd be able to do that in real life?
It would be difficult to get the drone to follow that perfectly straight path.
No, but let's say you had the best military drone money can buy.
Then yes, you could do that.
You still there?
Yes. I said yes, you could.
Oh, you said yes. Okay. Wow. Okay. That's quite. Are you sure about that? You think you can do that in real life? Fly the drone out to 14 miles at 11 foot and then drop it 130 feet?
The elevation would change as you do that, and it would be hard to get the drone to go in a perfectly straight line, and that's a key problem, is getting the drone to go in a perfectly straight line.
That's not a problem. You have the best drone money can buy.
Yeah,
it's not a problem.
Most drones are designed to fly in a straight line laterally, and then keep the same elevation.
Yeah, you don't think a drone could keep the same elevation? Let's say you told the drone fly out 14 miles, and then drop 130 feet. You think a drone can do that?
I'm saying I'm distinguishing between keeping the same elevation and flying in a perfectly straight line. I think those are different. I understand that you think they're the same.
Well, I thought we just established that now. I thought that we established that you can take your drone 11 feet off the ground, fly it to 14 miles, and then drop it down to the lobby. I thought we established that.
Yes, I said that you can do that as long as the drone is flying in a perfectly straight line.
Yeah, and didn't we establish that it can fly in a straight line?
I don't think drones are designed to fly in a perfectly straight line.
You got to be kidding me now, Matthew.
So I think drones are designed to fly laterally straight and at the same elevation. So there's two different things we're talking about. One is flying in a perfectly straight line, and one is flying perfectly straight at the same elevation. And I think those are different things.
So you don't think that you can tell a drone, for example, I'm on the first floor, and I tell the drone, you're going to take a direct straight line to the 6th floor. You don't think a drone can do that?
I think it could. It would be hard, and they're usually not designed to do that, but I think it could.
I think we're I don't know. I thought we were getting somewhere, but now I think we're tracking back.
Oh, well, we tracked back as soon as you said that the drone stays at the same elevation.
Well,
yeah, they actually don't.
Sorry?
I own a drone. I know how it works.
Okay, so you can make a drone fly in a straight line?
Of course you can.
Okay, thank you. So if you had a really good drone, can you tell it fly 14 miles and then drop 130 feet?
Yeah, sure.
Yeah, if you had a really good drone, then you could.
Okay, so we're back to yes now.
Yes, that's what I've always said. If you fly in a perfectly straight line, you can go 14 miles out towards that building and then drop 100 feet.
Yeah, but can't I tell the drone, okay, stay at 11, stay here at this out, forget the height, right? Let's just pick a height. Arbitrary.
11 feet. Yeah, 11 feet's good.
11 feet. But
yeah, Matthew, you'd have to say that drone, if you set it level to fly straight, that it would run into the water.
No,
the drone would just run into a mountain of water.
Well, it depends on where you aim it. I would say aim for the top of that 15-story building.
We're talking a straight, horizontally level line from where you started at. Plumb line, 90 degrees to your plumb, boom.
In a perfectly straight
line.
line.
So if you did that on your globe model, it would shoot off into space. So yeah, it does depend on what angle. At one angle, it would run into the wall of water, like in the hump type thing. In the drop type scenario, it would shoot off into space.
Yeah, so I would say if you start at 11 feet and you make it go 90 degrees from a plumb line, and you somehow program it to go in a perfectly straight line from that 90 degrees and just go towards that building in the picture, that it would get it once it got over towards the building, it would be 150 feet high at the top of that 15-story building.
Okay, then you can make it go down then, right? You can drop it.
That's right.
But you're saying you can only drop it if you reach the building? Is that what I'm hearing?
No, I mean, you could drop it before then.
But before you said you can't, bro. I'm having a hard time tracking with you.
Yeah, I'm sorry. So I'm talking about two different things. I would say if you made it go in a perfectly straight line, then it could drop down. On the other hand, if you made it go at the same altitude, then it couldn't.
What do you mean by it? By default, it will keep the altitude. You know that, right?
Right. And so I would say if it's keeping the altitude, then that's not a perfectly straight line.
Of course it is.
That's where we differ.
In his mind, it's a curve.
Right. So
yeah, I know.
Let's just say that you set the drone to go exactly east and exactly keep the same elevation of 11 feet. And you say, hey, go out 15 miles and do, stay perfectly going east and perfectly 11 feet high. My claim is that I think that it would trace out a slight curve, not a perfectly straight line, if it does that.
Yeah, I know what you mean, but that's just not the truth.
And that's the crux of the difference here.
You would be able to see that.
You know why I love this argument? Because I've used it before, but with a surfboard. Let's try a surfboard, Matthew.
Okay.
What do you think would happen if you were to put a surfboard right at the edge there, where it's blocking the 130 feet? What do you think if you were to paddle there with a surfboard? What do you think would happen?
When you get to that point right there, then you would be, what do you mean? It would just be there.
Sorry, what would be there? Sorry for laughing. I've done this so many times.
I didn't say it. I mean, it's sort of a funny way to put it. I would say that it would just appear flat there. It would look flat.
So no drop? No drop there?
Oh yeah, no, there'd be the same drop as we think there is everywhere, 8 inches per mile squared.
Yeah, but didn't we establish that there's a 130-foot wall of water there, blocking your view for 13 stories?
No, that's farther beyond. If you keep going farther beyond that.
How can you get up and around the water if the earth makes you not be able to do that?
How can you get
How can you go up and around it if the earth makes you not be able to do a straight line? If you go straight, it just makes you just drop down everything, no matter what. So how can you just drop down and automatically if you got to like rise up around the curve of water?
The direction of down changes as you move. That's how.
Down changes?
Right.
I thought down was the center of the globe always.
Yeah. And so if you from here to that other place, it's a different direction.
How can it change if it's the center of the globe?
If you're one place, then the direction is one direction. But then if you go out 15 miles towards those buildings, then it's a slightly different direction.
So down is a different direction. It's not the center of a globe anymore. It's not the focal point of the center of a globe.
Yeah, down is the center of the globe, and from two different places on the globe, those two directions are not parallel.
How do you demonstrate that? With two flying objects?
That would be hard to demonstrate. I mean, surveyors
hard to demonstrate. Aren't you doing it with buildings and people showing it do it with buildings disappearing and all kind of like, so you can't demonstrate it optically with two flying objects?
No, I'm talking about demonstrating whether the direction of down is parallel or not.
Yeah, no, you don't need to demonstrate it by imagining goofy stuff. All you got to do is fly horizontally up and land horizontally on the side of a building or something, or some dirt or some water, the water hill. That's all you got to do.
Yeah, I think that'd be hard to do.
On a globe, it's supposed to be happening everywhere.
Right.
Every inch of every dot that can be lined up with a dot that's the center dot, that's where it should be happening on a globe, buddy. Everywhere. You should see it exponentially everywhere, all around you, in every direction, every orientation, everywhere, from your feet down on a ball. Correct? But you don't see it anywhere on this ball, though, do you? This imaginary ball you're supposed to live on.
Right.
It's really hard to see a ball on a ball. Isn't that weird? You don't find that weird?
No, I don't.
That a ball doesn't present itself as a ball anywhere. You don't find that weird?
Not really, because it's really big.
Can you show me where a ball doesn't present itself as a ball anywhere else?
Yeah, when it's big. It's big, too big to tell.
When it's big.
When the
what does that mean?
When the relative sizes are so huge, like the size of
How can you demonstrate that? You're just saying like the leprechaun is too big. How do you demonstrate that claim?
Oh, how do I demonstrate how big it is?
Yeah, how do you show us a straight stick become curved because it's so big or little?
Oh, I mean, we know the size of the globe due to other.
No, not what you know. How can you have a problem with this word demonstrate? I'm asking you to demonstrate your claim that nothing can drop, nothing can do this, that you got two flying objects, and one of them's going to be straight and one of them's going to have to curve away. Like, show me which one does this. I mean, where do you have the comparison of one not doing it and doing it? That you keep thinking all this weird stuff's going to happen.
Oh yeah,
we have
no,
reality.
I don't have a demonstration.
No, we have reality. Reality, what we see in reality, that's what we have. Now, do you have a ball and then a flat plane in the lab where we can judge then see which one matches reality, or are you just going to keep on making stuff up? Like, where can we demonstrate?
Yeah, I'm just making this up based on a preconceived notion that the Earth is a globe.
So wouldn't a preconceived sphere in your hand help you out? And not preconceiving a real sphere, wouldn't that help you out better than preconceiving? Instead of imagining, wouldn't it be better to have a sphere in your hand and show us how the helicopters and stuff work?
It would be better
we'll do
to
that
get
real
these
quick.
drones and try these
Can
things.
you do it? No, not a drawing. A ball in your hand, a ball in the room, a big ball, 20-foot ball, 2-foot ball, 10-foot ball, 5-foot ball, and a little flying object. Show us how it works.
I can imagine it. I don't need an actual ball.
You can imagine it. What are you imagining? Leprechauns or pink elephants? What are you imagining?
The geometric.
I can't see your imagination. That doesn't help my science. I don't think that helps any kids in the classroom either, because nobody can see your imagination. You or no other glober.
Yeah, we'd have to.
That's what makes it sad. That's what makes it not physics. So if we could stop imagining globes and actually see how a globe works, you know what I mean? Why are you allergic?
Oh, I think imagination is an important way to understand things. Who keeps muting him? I can handle myself.
But physics aren't important to actually show the attributes of what's really going on with a sphere and stop making claims and imagining.
I didn't say
Why
that.
are you running from a real sphere? So get a sphere and show us. I'm saying you are. You're running from a real sphere every way you can, especially with the little drone helicopter.
So what are you asking for? Like a demonstration and evidence for a globe?
Yeah, how things work on a globe, how they appear bottom up, how they disappear from the top down, how things actually look on a globe. Yeah, I want to see a ball. And then if we see what we see on that little ball with little buildings and the way you portray them, you got your numbers, you got Google everything, you got a little globe, but you can like print out a little ball, a big one, a 10-foot one. Then you could print out 80 million different globes, all actually 1/1000th of a percent perfected. Exactly every dirt and piece of sand, just like the real globe is, printed out onto a little ball, a big ball, bigger ball, bigger ball. That's what we do. That's what models are. And show us how they work.
So I actually think that people have done that. So yeah.
They flew in helicopters around the ball to show us how they don't match reality? No, I haven't seen that. I've never seen one glober ever out of the 8 to 10 years I've been a flat earther ever touch a ball and do anything with a ball that makes any sense. Ever, not once.
So you're saying you failed to understand the globe argument these 10 years?
No, I failed to see you grab a ball and show us what a ball does. That's what you're failing to do too. Now you're talking about whatever I failed to understand, but you're not showing me. How can I understand your imagination when you're not showing it? God dang it. It gets rough, doesn't it?
Yeah,
out here in these mean streets of
like
physics.
A failure of education.
Sounds like a failure of a ball in your hand. So why did education fail you and where you can't grab a ball and show us how it works? How bad did education fail you?
No, I'm saying that I can't explain it well enough for you.
Education must have failed you, huh? It failed you pretty bad, didn't it? Where you can't even explain your ball you're believing in, you're preaching to, you pray, you got a religion. Put your last penny and nickel into it.
Education.
Yeah, it's pretty sad. You can't demonstrate a ball, and that's all your education is based on. Your whole education is you live on a ball. And every science and every physics and everything is a ball. But you can't demonstrate it? That's a poor, piss poor education, if you ask me. Don't you think? You don't think so? You gotta imagine your education. You gotta imagine your physics. You have to imagine your reality. You have to imagine everything about a ball. You can't demonstrate fuck all. And you think that's a good education. So basically you have a cartoon education of Walt Disney.
Yeah, I put
And
another
you think that's
cartoon.
good.
I put another
Yeah.
cartoon at 28 past the hour, and that's part of the reason why I think the Earth is not flat.
So show us how it matches a ball somewhere.
Oh, I'm
Get a
just saying
ball and
that
show
it
us anything and
doesn't match
show me
flat.
in my reality, what I look out into. Hold on a minute before you keep talking over me before it seems like I'm talking over you. Just a second. So in my reality, when I look out, go get a ball and show me anything I see in reality, match that ball.
Sure, sunsets.
I don't see your ball. I said go get a ball and show me anything I see in reality, match a ball. I haven't seen you do that yet. You're just talking so far, right?
Right.
So 8 years. So how many more years is it going to take one Glober to grab a ball and show us how this works?
It's never going to happen because I don't think you'll ever understand it.
You don't know you'll never be able to grab a ball? This is the problem. Ballers don't know what a ball looks like. They won't even grab a ball to show themselves what a ball looks like. But they want you to imagine stuff on a flat plane.
I think it's easier to
On
imagine
a flat
how things
plane,
are.
how are you demonstrate this flat plane is not a ball? How are you demonstrating that? You haven't?
I did it 28 past the hour.
With the ball. Show us how
No.
the helicopter works on it. Yeah.
Oh, I see. Like if you take a basketball and you like a golf ball, and then you can put the golf ball behind
Well,
it.
a basketball would be your Earth, and a golf ball would be your moon. What's going to represent your sun? Show me how an eclipse works. What's your favorite physics lab model where an actual human grabs a fucking ball, right? A globe, and then they get a sun ball and a Earth and a moon ball, Earth ball, sun ball, moon ball, and the physics in a lab, a class, outside, actual physics of how the eclipses work. Have you demonstrated it?
Yeah, it works perfectly in the
How
3D
far away
model.
did you get? How far away was your sun? What'd you use to compare to 93 million?
Models, in computer models, not in real life.
The only thing I've been asking you about is real life stuff. We want 3 balls in real life.
Oh, that's
one that represents the sun, one that represents the moon, one that represents the earth. We need you to do 3 ball eclipses with 3 balls. How else would you know how a ball works if you guys haven't physically touched balls and made this stuff happen?
Through computer
where are you getting your
animations and
schematics from?
imagination.
No.
That's good enough for me.
No. Imagination.
Yeah, I mean, I have a mind where I can visualize 3-dimensional objects. And
You can't print it out. We don't have printers.
It would be impractical because of the sizes.
Do we have printers?
Yes.
Can we print stuff out to model?
Yes.
Okay, so where's your little modeled Earth?
Some people have made things like that.
Google has your numbers, the longitude and latitudes. You should have at least 1 billion different sizes of Earths and different trinkets and stuff. Earrings, nose rings, necklaces, little balls, basketball Earths, everything. Exactly 1,000,000%. Every longitude matching, every little river, stream, ocean, granular of sand, every piece of land, every city, country, state should be accordingly. If you do it this way and turn it this way, everything should match.
Yeah, so I posted an example of a model of Earth.
What can you do with it? Can you hold it in your hand?
Yeah.
Grab it in your hand and show me how many helicopters you can fly around it. Show me how the elevators and stuff like that work on it.
I don't think I could. I think you wouldn't understand.
I don't think you would understand. I don't think you've ever seen it done. I don't think you could possibly understand anything but an imagination that doesn't work. Right?
So imagination is a useful tool for visualizing.
For who?
Things that you can't
Leprechauns?
make. Not for many people.
For unicorns?
For people who understand 3-dimensional ideas.
I imagine you owe me 3-dimensional money. So you owe me three-dimensional $1 million, and I imagine it. Does that make it good enough for you now, or is that
Imagining
not good
things
enough
does
now?
not make it real.
So now you don't owe me money. So imagining doesn't make it real now. So why are
Right.
you doing that? So what are you imagining for? It has no bearings on reality.
Because it can help you think about
It doesn't make it
ideas.
real. It doesn't
Right.
have no, it can't. No, it doesn't do anything. It doesn't help you do shit. Not for science and not for physics.
My imagination helps me understand.
It's good for a religion. You got a good religion there, buddy. Go pray to gravity.
I don't know why you don't like the idea of using your imagination for things.
For measuring stuff and showing how balls work? No, I think a ball works for that, buddy.
In general,
You
for doing
okay?
things you wouldn't want to do
Are
in
you
real
all
life.
right? I think a ball works for showing how a ball is going to work. I don't. I don't need to imagine how a basketball is a basketball, do I? They actually exist, buddy.
They do, but you can also imagine them.
So demonstrate one. See how easy it is to demonstrate a basketball? People would think I was stupid if I said they didn't exist and they weren't real, right? But they can't say that about your imaginary Earth, huh? Because it's not real. You can't produce one. So, can you produce a ball that matches your Earth claim?
No, not according to your specifications.
So your Earth's not a ball then?
No, that doesn't follow.
Show me what ball isn't 360. Where do you got a different ball at? What kind of ball do you got that's not a 360-degree ball?
Yeah, all
Show
balls
me
are
your magic ball. Which one do you got? The only sphere I've ever seen is 360.
Yeah, me too.
Right. Okay. So if the Earth's a sphere, then what are we waiting on? You got billions. Every little ball you touch is a sphere, correct? How would that be different than the Earth then?
It would be similar because they're both spherical.
Show me where spheres are different than spheres in physics. I'll wait.
One is a mathematical concept and one is an actual thing in real life. So, all real balls in physical space are slightly different than the idealized sphere.
I think you have to demonstrate what you're talking about. I think you have to demonstrate your claim one of these days, buddy. Does somebody pay you a check to just imagine and lie? Or what? You ain't never got to show anybody anything?
I'm not going to confirm or deny whether I get paid.
Well, you don't get paid for doing anything physical. That's for sure. Non-physical globe. Step right up and buy your non-physical globe. They're so mathematical and non-physical. Test the belief.
I don't hurt you, baby.
Test the imagination.
You see how when we're talking about the drone, which shout out to you, D-Mock, very good. I like that. Now I coupled that with B-Ball's famous picture, right? And he was going for the drop. He was going for the drop, right? But as soon as I mentioned the water, you see what happened? Pulled the Scooby-Doo
Yeah, but you
there.
know what? I told him I don't care. It's supposed to go down. We want it to drop.
Yeah.
That's what we want it to do. When they're it's gonna follow the earth. Good. Good. Make sure it doesn't get wet though, motherfuckers.
Hey, he dropped at 130 feet, bro. 130 feet. But now, as soon as I put the surfboard there on the water, what happened? It just got leveled. The drop disappeared. He did a Scooby-Doo right there. Right, Matthew?
That's not how I would explain it.
I'm messing with you, but you did change your mind though there, because you went. Wait a minute, how could that be?
I wouldn't say that I changed my mind. No.
How would you explain it?
I clarified the things we were talking about. Clarified something going in a perfectly straight line versus something going at a constant elevation. So I've been very consistent based on which of those two scenarios we're talking about.
Well, not really, because you said we were at 11 foot, and we set the drone to fly in a straight line. You agreed up until what did we say? 14 miles, not 14 miles, right up to the edge of the water. And then you said we can drop 130 feet.
No, I said we'd have to keep going a ways after that before you could drop 100 feet.
Well, first you said up to the building, drop down.
Yeah.
Right?
Right.
Then I asked you, why only up to the building? Isn't there a drop there? And you said, yeah, as soon as you pass the water there, then you can start dropping.
8 inches per mile squared, not much.
What do you mean not much? There's 130 foot. Didn't we establish that there was 130 foot missing? And we
No,
it goes from 0 to 130 foot, correct?
That's right.
Well, no, from the observer it goes 130 foot is blocked, but from if you're going halfway it'd be somewhat less than that.
So you mean it's not an actual water there? That's causing you're changing the story now?
No, I'm happy to assume that that's actual water there, and it,
Okay, so there would have to be either a lump of earth to obstruct your view, or some water, or I don't know, Coke cans or barrels or bricks. There would have to be something there obstructing your view, no?
Yeah, it looks like the water's obstructing the view. That's right.
Okay, so it's the water. Okay. So then, how do you explain the drop? There has to be a drop there, like we agreed before.
Right, and that drop is 8 inches per mile squared. That's what we've always said.
No, we said 130 foot.
Yes.
Yes. Okay. So the drone, you said, would drop from that distance, from the edge, 130 feet. You did say we can play the tape back. I mean, I'm not making it up unless I misheard you.
No, that's right.
Okay. So if the drone could go down 130 feet, right where the water is there, how about if we were to put a surfboard right there at that edge of the water? What would happen?
Nothing. It would just float in the water.
Then the drop is gone all of a sudden?
It's still there. It's just it's not. I mean, it takes. It's 8 inches per mile squared, so it doesn't drop much.
Hold on. It went from 130 feet to not much?
It's 130 feet over the distance of the whole 14 miles, yes. But if you put the surfboard anywhere along the way, it's still just that gradual 8 inches per mile squared.
So the surfboard would do what? Just remain neutral in the water level?
Right. That's right.
So what happened to your 8 inches per mile square drop?
It's still there.
Where?
And if you go to where the surfboard is out in the middle there, from that perspective, everywhere around you is dropping 8 inches per mile squared. So it'd be like you're at the top of the water there.
So the drop changed now. Now because I put you, we went from the drone, which was able to drop 130 feet from that point. We went to the water, and then all of a sudden the water leveled off.
From the buildings.
The water. Sorry?
Not from that point, but from the buildings. If you go all the way out to where the buildings are.
I don't know, Matthew. It's hard to keep up with you. You keep changing. You're going from this, from
I've
the
been
building
very
to
consistent the whole time.
Nah.
No, you
I don't
absolutely
think.
haven't, man.
It's really pretty simple. It's just three-dimensional geometry. It's not hard.
What do you mean by three-dimensional? Do you
Looking at a
think
part of a globe.
so? If it wasn't a globe, it wouldn't be three-dimensional?
No, we live in 3 dimensions, so pretty much everything's three-dimensional.
Yeah, what does that have to do with a globe, though?
Because the surface of the globe is curving, and we're like arguing about all these little things about where a drone is and whether it's going straight and all that type of stuff. It's just three-dimensional geometry.
Yeah, it has nothing to do with three-dimensional geometry, and you can't prove that it is curving.
Well, not by squinting at the horizon, no.
You can't at all. That's the whole point.
Would you say that the opposite of flat is curving?
The opposite of flat is curving?
Right.
No.
Why would you say that?
Oh, because I posted at 28 past the hour some evidence that the surface of Earth is not flat.
By dropping a drone down or a hot air balloon past the water where you look back and the water stops. Can you look back at the water wall? Can you horizontally fly and just look back at the water wall?
No.
No?
No.
So you can fly horizontal and drop 240 feet, but you can't look back at the 240 foot tall water wall.
No,
That's weird.
if you're flying horizontal, you're at the same elevation.
If you drop down 240 feet, now you should be able to look back and see a 240 foot tall water wall. Same size as the building you drop down 240 feet below. So you should look at a building and look back and see the water wall too. Right?
No, that's not how it works.
So the water wall doesn't match the building. The water wall you're standing on, looking through your optic and looking at the building and seeing the drop, doesn't exist now when you look the other way?
I guess I'm having trouble understanding how the words that you are saying are put together into coherence.
Maybe that's why you need to go get a ball and put a couple buildings on it and show us how some drones go around it and show us how they don't tilt. Show us how they match your imagination. Show us a ball that matches your imagination. That's what we're waiting on. Is that so hard for you to go get a ball that matches your imaginary ball in your head and show us stuff on it? A physical one, a tangible one? Well, that way you can't run. You wouldn't be able to run or make up any lies or bullshit. We'd be able to see it right there, right? Correct?
Right.
Okay, so that's probably what you Globers should do. Put your money in physics, not imaginary numbers that aren't a shape. I'd love to see what shape 521259 is. I haven't saw it yet. No Glober could tell me.
51259, what's that?
It's a shape, isn't it? Math, right? Reality. It's a flavor. It's a color. It's a height. It's a weight. Shit, it's a speed. 52159. You don't know? Math. It's reality.
That's an integer. That's a number.
It's reality, isn't it? It's math.
Math describes reality. It's not reality itself.
How does math describe anything when we're just trying to imagine it right now and we can't? We can't even describe your imagination. Clearly, math is your imagination you can't bring to the table. You need to bring it physically to the table in a sphere. If you say it's geometry, clearly it's no different than any sphere. So go get a ball and show us how it's working.
I think math is used to describe reality. It's not reality
For who?
itself.
A computer? For who?
Physicists, engineers, all kinds of people.
Go tell them 215295202 and repeat these numbers to them and see what they come back and say. What kind of poetry they come back with? What kind of shapes and sizes and birds and stuff. What are you talking about? Since when do numbers become anything but an imaginary piece of nothing?
Yeah, the number you said is a number, an integer divisible by 2, 5, 10, and 20. I mean, there's lots of things you could say about that number.
What size is it? How does it feel? What does it look like?
Numbers don't have feel. They don't look like anything.
So why would you use them to describe something if they don't look like anything?
It's helpful for designing the world.
If they don't look like anything, what are you designing with them?
Airplanes, battleships, iPhones.
And airplanes look like nothing.
We use mathematics to design airplanes.
But you can't design your ball with them when you got the mathematics for your ball. But you can't design a little one. But you can design an airplane from math. But you can't design a little globe from math. Somebody doesn't sound right here, bud.
I agree with that statement.
Yeah. So where's your globe at? If you got a little airplane from fucking math magics, clearly you have your globe that's been demonstrated 3,000 years now. Shoulders of giants, Google, airplanes flying all over with their little mammograms. Clearly you got the printed out 3D globe already, right? Clearly.
Yeah, I posted it 31 past the hour.
So now go grab one at the store. Show us how stuff works on it. Show us how stuff flies around it, how buildings appear on it. Move it around. Show us how stuff works. Why are you so afraid? Why are you afraid of your own sphere?
I've never said I was afraid.
Well, you're demonstrating. That's what you're doing. You're being afraid right now. You're the scariest glober I know, and you won't touch a globe. I bet you will never touch a globe and show me how a globe works with a real physical globe. None of you globers have been able to do it so far.
I haven't.
You won't be the last. Not one of you have ever done it. Don't you think that's sad?
No, I don't.
So you don't think it's sad a little kid can't grab a globe and show us how a globe works in a class?
A little kid
but then they have a classroom that they describe to them how globes work with little balls. But a little kid can't come home and describe to her family how that works. You don't find that sad. And the little kid's going to be told she's wrong and that's not how it works. Right? Because you can't demonstrate nothing, right? So what are you demonstrating in classrooms if you can't demonstrate it to a grown-up? Grown-up?
I guess I'm having trouble understanding coherent ideas from your words.
To kids, you are telling them they live on a ball. You give them a book with math and all this shit about a ball, right. An earth, a sphere. So demonstrate it. Why can't they go home with a little sphere in their hand of different sizes if they want from the Sphere hardware store or the local toy store and show their parents how globes work? You don't find that sad that they can fly little airplanes and show you little Elmo dolls, 100-foot tall, 2-foot tall. You can make big old floaty balloons at Macy's parade time, and you can have a little Elmo or a big Elmo flying over the city, but you can't make a little globe. Somebody's sad. Sounds sad for the globers to me.
I'm not sad about it.
Yeah, you should be. You can make everything but a globe. Little buildings, little houses, little cars, big houses, big jets, little jets, big everything, little everything, but not a globe. Not what you have the perfect schematics to. Weird. I just find that sad. Mom and Dad, for science class, I wanted to make a little Earth, and they told me I couldn't. All I gotta make is a volcano.
Oh, don't be sad. Many school children do make globes and can explain it.
But you can't follow their footsteps? So little kids can grab a ball and show us how stuff works on it, but you won't. Fuck, I find that sad for an adult. You call yourself an adult teacher. So which teacher showed the kids that they could do it? I want to talk to that teacher.
Well, Demok, just go to the store, buy a globe that says "not for educational purposes" on it, and then use it for educational purposes, and you'll be all set.
That's what I'm saying. It's like so weird.
You know, it's practical. You know, when they spin it and then you put a finger on it, and then they travel to that area wherever their finger landed. That's very practical.
I just think it's weird they can't show a drop with a drone that supposedly you're staring at. You're staring at 240 foot of something missing right in front of you, and you can't fly an object while you watch it fly straight to that building, that floor, right? So if you were in that building looking at the drone, you'd see it fly straight to you. It wouldn't start deviating anywhere, go around no curve or nothing crazy. When does this happen?
Yeah. No, that's a good idea with doing it with the drone like that. It'd be interesting to see how straight a drone could really fly, because on a globe Earth type idea, yeah, if you started, 30 feet up in the air or whatever, and then you have it actually take a straight line, like if you do a plumb line from wherever you're at and you set it to go 90 degrees, directly horizontal from that plumb line, and then you have it go out, like the example they were saying earlier with the, like B-Ball's picture, the 16 miles with the building. So it's supposed to be like 130 feet, raised in elevation from the position that the drone leaves from. So if the drone could take a straight line, once you get out there, when you drop the drone, if it was a globe, it would drop way more than 130 feet. It would have to drop a lot more, because that plumb line should be shooting off, off the ball.
Right,
so
right.
That would actually be interesting, and I think we all know what will happen ultimately. I mean, it's just going to be, if it was a straight line, it's going to just be a horizontal level the whole way. It's just the
drone's going to get wet.
They would have to show that. They would have to show it actually being higher, which has never been done.
No, I agree. That would be an interesting thing. I don't know much about drones.
Well, I don't know much about the Earth making stuff dip down. You know what I mean? So yeah, it'd be a learning experience.
You could also have it fly like right next to it, like have a laser as well. And depends on how good the equipment on the drone could be to fly in a straight line, but you could also compare that to a laser. You could even do advanced things like set different sensors along the way to pick up data as well. Yeah, because you'd have to show that drone would be way higher than 130 feet, that it actually lifted off the ground.
Yeah. Or be able to drop it 1 foot more than it is. So if you start 10 foot above the water, if you can drop down 11 foot and not get your drone wet at any fucking distance past a mile or two. You see what I'm saying? Just keep it flying. And you only start at 10 foot. If you can drop down 11 foot and not get wet, you're good to go. We're on a globe. I'll take it. Because I know for a fact if you go 10 foot above it and you stay right there and fly and you drop down to 10, that's touching water right there. You go 11, your drone's done. It's sunk. It stops. The camera on it's gonna be like, bloop, bloop, bloop.
Yeah,
Have
no,
a
I
camera
would
on
agree
it
with
too.
you.
It's the same aspect as you can't shoot a rocket, a bullet. You can't fly anything not 1 foot past the Earth's curve, dirt or water, and show no curve, no water or dirt underneath you. How about that one? Have you thought about that one? No object can ever be shot from this Earth with a camera on the bottom of it, no matter where you're at. I don't care if you have a million dudes lined up in the air on a straight, no matter what. If you shoot it horizontally, it's never going to leave this Earth 1 foot to where there's no dirt and water underneath it. No matter how much it goes out, drops, whatever you want to go, it doesn't matter. Ever. Not 1 foot. That's my challenge. Not a rocket, not a missile, not anything. Because if that was the case, and you're a submarine, just think about a little bitty submarine, Matthew, with 24,000 miles of water surrounding the big circle. You're in 7 miles of water. You're telling me you wouldn't be able to shoot your missile out horizontally away out of the wall of water ball? Like, come on now, dude. We should be able to shoot stuff horizontally out of the water ball and not hit the dirt that's cupping the water. The dirt should not be surrounding the water. The water should be surrounding itself. So like if I go out in the mud puddle and dropped a little toy submarine in the mud puddle, I know that the mud puddle dirt is up higher than the water. So no matter what, that little submarine will never be able to shoot anything out of that water horizontally. It'll just hit the dirt every time. It'll never leave the water. But on a globe, it has to automatically. Just going down a couple feet and shooting your water or shooting your missile, it should go forward and then leave the water. On a globe. But it can never happen on a flat plane. Ever. How microscopic is a little baby sub with its little toy bullet coming out right off the surface of the water, 7 miles of water, but you're at the surface. You just shoot it horizontally. You should be able to leave the ball, man. 1 foot of no dirt.
Gio, are you there?
Oh yeah, I'm here. I heard someone. I wasn't right at my mic, but someone just say Gio. But yeah, it's a good idea with the drone. We should definitely do that. And I think combine it. I've always wanted to do one with drones with plumb lines. Basically have drones which would make massive plumb lines. Have like tethers that would come down from the drone and then get it to be perfectly vertical. And then at that high a distance, you could do various things between the drones. Because on a globe, they should be angling out, like the diverging plumb lines thing. Whereas, of course, over a planar surface, they're all just square, level and square all the way along. Also, combined with that, shooting lasers at high altitudes as well. Then you have different refractive effects, or even very little. So many things we can do.
That's a good idea, actually. You combine that, the drone, with water and geometry, you got a winner.
Yeah, maybe even include a water level with it as well. High altitude water levels across long distances. I feel like water level towers that had marks and that you could change the level of the waters in all the tubes, then do them at different altitudes and measure the distances between them.
Yeah, you can do that. Yeah, but I was thinking more of what we were talking with B-Ball's thing, like with the water. Have it go out. You're going to destroy the drone anyways, but something like that, something that involves geometry and water. We're actually just talking about that one with like what we did with Matthew, because you're going to destroy the drone. I mean, there's no way to do that, right? You are you tracking a little bit now, Matthew? Even when we're thinking of trying to do it, we can't do it because we're going to smash the drone. We know it can't be done.
Right.
And why do you think that is, Matthew?
Because the drone will go at the same altitude the whole time, and when you lower it, it's going to go straight in the water.
Could it be because the water isn't curving?
It's either because the water isn't curving and the drone isn't, or the water is curving and the drone is. They both do the same thing.
What do you think is more likely?
That both the water and the drone are curving as they go.
Both the water and the drone are curving. I knew you were going to say that.
That's what that picture shows.
Yeah, I'm afraid there's no way to get through to you guys. I mean, you're just going to think water curves? That's it.
Yeah, I mean, obviously we think water curves based on our preconceived notion that the Earth is a globe, and so therefore we look at pictures and there's the water curving on the globe. In order for it to stick to the globe, it has to curve.
Preconceived notion.
Yeah.
Right, like doing drone things or looking at the horizon that building's 14 miles away. None of that is going to show us one way or the other, I don't think.
I mean, the definition of notion is a general understanding, vague or imperfect conception or idea of something.
Right.
So the globe is a vague and imperfect conception?
No, it's just an idea.
Another definition of notion is an opinion, view, or belief. There's another definition, a fanciful or foolish idea, a whim.
Yeah, I would say my belief in the globe is a notion in the sense that it is an idea or a belief.
You think if you were brought up with everybody telling you that the Earth was actually planar and all the same observations, and if somebody came to try to tell you it was curved, I'm going to speculate that it would be as difficult to change your mind as you are now, perhaps, or even more so. What I'm saying is that if you weren't told it's a globe and somebody came to try to convince you that water was curving, I feel like you wouldn't be able to be convinced of it when you're an adult, but because it was at a child age and because there's this whole kind of paradigm that is built around it, you perhaps would think that notion is actually reality more than you would otherwise.
Yeah, that's an interesting what if scenario. I don't know the answer to that. I hope the answer would be that I would see the reasonableness of the idea of the globe and switch from my indoctrination of flat Earth as I grew up and understand the true nature of the Earth. I think I would do that, but can't be sure.
But it isn't what reality is observed to be. Like, it's not what the Earth is actually observed to be directly. So it would be, you would have to be convinced of it from
right. You have to be convinced. It's using logic and reason and taking the observations into account and like fitting it into the globe theory. You'd have to be convinced that that's reasonable.
Because you said flat Earth indoctrination. I wasn't really referring to anyone purposefully trying to even tell someone. It would just be the base reality as well.
Oh, you mean if nobody had said anything?
Yeah, that's kind of maybe more. I mean, now it's kind of morphing because I didn't give those details, but I was more like, yeah, it wasn't really about that somebody brought up forcing that it was stationary and planar necessarily, because you said indoctrination. So I wasn't saying that it was some indoctrination thing. I was just saying if no one was ever told it's a globe, like there was a lot of resistance around this globe thing when they started rolling it out. I would say so much resistance that they had to employ essentially world wars to even get this level of domination, because they had to get control over the school system to even indoctrinate this stuff into the children. So before that, they didn't have control over the schools. So everybody was just still in the base default reality and all of the spiritual and religious systems that were all connected to that. Not really the word religious as much. I would say the actual like spirituality, but that word religious can be used in various contexts. But like it was already the base reality of humanity since the dawn of time. So people started coming in and saying this globe thing. It was a huge resistance. So, I mean, I actually think there was a huge reset in the 1800s and 2 world wars and everything we see in our modern time, especially after World War II, for them to even get the NASA and the United Nations and all this stuff even built to where it even would be in schools. So I'm just saying for all the decades and beyond time before that. Yeah.
What happened during the Great Reset? I've heard that idea before, but never had it explained in detail.
Well, that's going into a bit of a different category, but yeah, that it is. I mean, there's definitely different ideas that people have in terms of a whole spectrum of different types of resets. I don't know whether you want to go into that topic, or because that is a whole in and of itself.
I had heard it before, but so in other words, the just the basic idea is that we don't know history very well past a certain number of years, like 150, 200 years, or something like that.
Yeah, I mean, I would say just like in a quick little 30-second thing. I mean, I think there's a spectrum of different ideas that people think about and think may have happened. I mean, one of the more kind of dramatic levels of it would be that in the 1800s that there was actually a huge reset event that, you know, like the all these architecture and this antiquitech architecture that, you know, still exists today in some areas. And so there's one like idea that actually there was a whole different world, like that involved, it had potentially free energy and very advanced on multiple ways. And there's a lot of different ideas and potentials of what that would have been. And then that there was some huge like genocide of sorts that essentially where they took people out of their, you know, native living areas and torched a lot of these cities, burned them all to the ground. Like a lot of this, like Chicago, all the major cities in the United States were all either had earthquakes or fires in the late 1800s, early 1900s, like Chicago, Paris, New York, St. Louis, San Francisco. Anyway, so yeah, there's a lot of very interesting. And then there's all these orphan trains and these asylums. Basically, a lot of these old architecture, like buildings, were turned into asylums, and then they were also they were like orphanages and asylums. So they had like orphanages for all the new children that they were repopulating the cities with in this idea, and then they had the asylum was connected right to that. So if any of the children in their extreme indoctrination and reprogramming that they were doing in this idea, any of the children that didn't go along with the program or were not, up to par for whatever they were trying to convince them of and all the rest of it, trying to repopulate, went to the asylum. And, who knows what tests and experiments and what things may have gone on there. And it's like these asylums and these orphanages are in these incredibly beautiful buildings, like this, this incredibly like advanced architecture. So it just doesn't really line up. Like, why would these like indoctrination centers basically and these kind of asylums and, which were in all of these huge buildings that do not look like they were originally built to be that. So that's one possibility. I mean, that's kind of, like I said, it's a more dramatic version, like a real major reset where like the adults were all taken away, either killed or eliminated in some way. And then they basically used these orphanages and these orphan trains to kind of repopulate the cities. And then even under that idea that they've still been continuing to destroy a lot of that architecture through the world wars. And perhaps that the world wars were even designed partially to destroy a lot of the old architecture to hide that whole hidden past.
Yeah, those are interesting questions that need to be answered, I suppose.
And like linked with that, like really no one has very like memories beyond like 150, 200 years, like you said. I mean, we all have like a great grandfather, or maybe a great, but beyond that, like really very minimal actual real life memories or connections that people have to their actual families. A lot of people don't have birth certificates from from those times. And
yeah, it's interesting.
But I mean, going with that, yeah, I mean, there's a lot to all of that whole the potential of that. But if that's the case or something like that, it would also be the idea that if there was like a re-indoctrination, some kind of repopulation, asylum, something like that going on, it's kind of interesting because it's like we're all in this like trauma, it seems, with the shape of the earth. Like I don't mean you or me. I'm not talking about anyone individual. I'm just saying like in general, like people call flat earther people retarded and stupid and dumb, and then flat earther people call the globe earth, globe earthers, those things. And it's like, it's just interesting to think about, like, was there like almost like MK Ultra, but way earlier, like not the MK Ultra of today or whatever, but that type of thing. Like, was there some kind of like traumatic event that was based around like really hardcore indoctrinating people into these children into being in a particular mindset in order to repopulate those into the world? And then was there like actual programming in a sense, like, done on them to like replant this new history that we now think is real, in terms of a lot of the history. So, I mean, that's like I said, I was using the word dramatic because some might see that as a pretty extreme level of a reset. But there's also other ideas that, go back earlier in time that there was things like that. But I'm talking, that one I'm talking about, where it's like a re-indoctrination, repopulation of people into these new cities. And perhaps like the entire paradigm that we're sold today with the globe earth, the medical thing that's going on, the energy, the education system, the military, that all this stuff was like, it's like programmed and implanted as recently as the 1800s as a whole new paradigm, to get people to believe in, to erase the old history. And so in that sense, like, are we all living in that kind of mode right now?
Yeah, those are interesting things to think about. I guess I would generally go with the mainstream narrative on all of those things. But you're right. None of us have living memory past, the age of the oldest person.
Yeah. And look how quickly they got people to believe in a globe. So I mean, they can change people's, entire. I mean, even if you believe the story, I mean, even with the globe, it's like, okay, they say the ancient Greeks, but even they don't admit that, like, it's not like everyone on Earth believed it was a globe back then. It was like a small cult of people. And then there wasn't, I mean, at least in the history we're told. And then you have the Copernicus situation, but that was really within like 500 years, less than, well, around 500, let's say. But even then, even if we want to pretend like it's a Copernican revolution of the globe, I mean, even if we even call it that, but it's not like everybody in 1602 thought the Earth was a globe at all. In terms of the mainstream, even in the mainstream explanation of it now, it wasn't even the case that everybody did. And then it's like, when did people really even start believing it? Because before NASA and the landing on the moon and the picture of the globe Earth, what would people have to go off? Like, oh, well, we're just told that it's got this curvature, and there's this Isaac Newton guy that has a theory of gravity, of mass attracting mass. They wouldn't really have anything to go off. There would be no reason for them to like believe it and embody it, as like, yes, I live on a spinning globe, and there's no way they would have. So it took this like school system to do that, and the NASA and the whole situation we're in now. So, I mean, how long have people even really believed it? And then if it's, quite recent, then why are people so recently into this kind of globe idea?
Yeah, so you're saying that the normal people back, the 1600s didn't believe the globe, but the scientists did, right?
I mean, that's what we're told, yeah, is that there's a select few within, I don't know if they admit any statistics on that, actually, but yeah, I mean, if you were walking down the street in 1652 and you just went up to a person, hey, what is the Earth? Like a random person. They're not going to say, oh, it's a globe with a radius of 3959. There's outer space and gravity. And I mean, there's no way they would have believed that.
I think a big part of it is like the visualization of it. Like having a visualization of it. So like when you talk about the world.
Yeah, having it served up exactly as like a thing. Yeah.
Exactly, because like that's like a very satisfactory thing. Like branding and just it clicks in your mind. And so like Flat Earth to this day doesn't have a replacement for that. And people just can't get over that.
I think it's weird how they can imagine everything else. We got all the stuff, movies, comic books, all this other stuff, but Flat Earth, oh no, we couldn't imagine that.
Well, it's because they haven't been given something to imagine. The vast majority of people, I think, are kind of lacking in the field of independent thought. You know what I mean? Like they were given what to think. So it's like, until you give them something else to think, they can't think. That makes sense.
Yeah, and it's even branded as like the blue marble and the pale blue dot and all these like Carl Sagan, all these different terms. And
yeah, I think the average person doesn't even know. I just think they don't even know about all that, like that, like nerdy, goofy, like technical stuff that we talk about. Like most people just seen animations of where we live, and it's a globe. It's like and honestly, I'll be like, it's a very satisfactory thing. It's like when my Apple TV's on, it shows like the CGI globe, and it's like cool to think about the world as a whole outside of it. There's like something nostalgic about it, and there's like it ties back to even like our childhood when we first learned about like the idea of where we live. So to like take that away without a replacement, like people can't really understand it. That's kind of how when I first heard it, I like didn't understand it. You know what I mean? Like I think that's half the spell. The people in here that defend the globe, in my opinion, are like anomalous. They're not like
I was thinking it was hard to think of, like, because we think of endless space, like never-ending space and stars and everything, like the vastness of what that's supposed to be. Then I was like, well, hold on a minute. Why can't Earth be vast and never-ending? And I was like, let me wrap my head around that for a second. Like, why not?
I'll say I never clicked with space stuff, but like I never even really thought about the Earth either. But it's just a thing. It's like when you see the whole world or something about it. It's like if someone's making this motivational speech about the Matrix or how we live on this planet that's completely controlled by a select group of people, blah blah blah, and then the voice is overlaid on a visualization. It shows you a globe as it talks about the entire world. Then you see the whole globe. it's this like satisfactory portion of your brain that people feel like needs to be replaced, in my opinion. Like if you type in the Earth, what pops up? If you type in Earth images, you know, you actually get a bunch of images, like a bunch of cartoons, albeit,
But they
Yeah,
don't
it's like
have
they've
one.
carved out, because all of us as humans, like all we can do, we see the sky, we see the ground, we see as much as we can in our lives, and whatever the mystery of the Earth, the geometry, all of those components, they've like removed all that and then almost like carved a hole into people's mind, or like carved a little area where they've then implanted, you are here, like this is the globe, this is it. And so I know what you're saying is that when you give someone now, because of that indoctrination, because of that imagery and the way that the human mind works with imagery, to tell them that that's not the case, it's like they're just jumping off a cliff and they don't know when the ground is.
yeah,
in some cases.
you see that right there. Like, say you're watching some video and it's talking about we have people all over the world, and then it shows you this. Like, what do you know? It's just something about it. It's like it's hard to put into words, but like even there's this weird little part of me that when I see the globe, there's something nostalgic about it. Now I've significantly changed where my response is like I'm like it's like almost like I'm repulsed now when I see a globe, you know, or like Kai and I.
Well,
Like,
the idea of one spinning like that. Okay, like in school, you could go to buy this little $5 little thing, like at the shop time when you're a little kid. They give you money, you can go thing if you have some money. So I found some change or whatever, and I had this little floating pin. And I always had the idea, what if we could put a little globe there and have it spinning instead of the ink pen that I had just floating? Like you put it in like this little thing and it like levitated from the base and from the top, and it would just like hover there. The ink pen, it was like a little trick ink pen case. And I've always wanted a globe or something like that in there, instead.
yeah, like
when I was a kid.
I mean, it is like a part of history too at this point.
Like the little globe, like the actual globes they have in the classroom and stuff, never resonated with me. Space cartoons never resonated with me, like to such an extent that I used to like challenge them, like as a kid. But at the same time, I'm just saying, it's hard to explain, but there's some like nostalgic aspect of it. And dude, what I've discovered is humans, although I don't like that word really, but they're much more emotionally driven than we may want to admit. You know, like we operate in this like subconscious, intuitive realm that merges with like our emotional filters of our conscious mind. And we're driven by emotion. And there's a spectrum of this, you know, like men and women are different and there are different spectrums and stuff. But yeah, I think that we're fighting like this emotional spell. We're not really fighting an intellectual battle. So we're trying to basically go talk to forgive me, no one get offended, but like we're trying to talk to an IG model about relativity. It's like she's like, what? Like she doesn't speak that language. Like we're talking to the 7-year-old version of someone about like all these intricacies of their belief, and they're like, whoa, 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 calm down. Like they look, you know how Gio, you know how we talked to Zanuck and we're like, have you ever been to like a bonfire and there's that one guy that's just like killing the vibe, he's going around everyone like, you're wrong, you know?
Yeah.
They look at us like that. Like when we come talking about all of this like nerdy, intricate details about the earth, they're like, whoa, 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 it's not that deep. You know what I'm saying? They're like, why are you killing the vibe? It's like, it just has to be a globe because I emotionally prefer that at this point. That's what I experienced on tour. The hardest part for me was breaking through like this wall of emotion that people have. So it's weird. It's kind of, and it makes sense though because like you were a child and you were told a story about what you live on. And that's a very magnificent idea. It's a big idea. You know what
Yeah,
I'm
it's definitely it's very close to home, and it's for people, and it reminds me of the way people get into like sports teams and patriotism. Like, you know, like whatever town they grew up in, like just the whole patriotism thing in general, which that's a whole nother crazy psyop, like to get people all like worshiping the country. Even to the point, like when we were in school, we all had to like sing the Pledge of Allegiance every day. Like every single day we had to like chant this Pledge of Allegiance to the country. So like you get that patriotism, that level of patriotism, which then bleeds off into like being attached to the school system, like that, you know, that you're going to get all the good grades and the degree. And then like in your city or in your town, you have all this like fandom of like your football team, your local football team, and all of that stuff, which is usually linked to the high school. So yeah, to me, it reminds me of like in that same lineage. And then you're like Planet Earth or whatever, and you've got it like in the background of your phone. It's in every movie. It's like this intense like cult like worship of like cosmological patriotism that has just been so deeply implanted. And it's like such a, at this point, just like a default state for people, even though it's really just built on a house of cards, and they don't even really believe in it. They're just going with it in most cases out of that kind of cosmological patriotism that was really forced upon them. And they like had to go along with it to even like seem like they were making it in the world, that you got to go along with it to go along to get along in this current day.
I guess like a fundamental difference, and I don't know what it is, but we as like flat earthers, we were able to entertain that like what we were told about the earth was wrong. Although probably very skeptical. Like for me, I was like, wow, I'm just going to disprove this. But like I could entertain it. Like my brain never had like this inability to entertain it. Whereas there are people that come on here all the time, but they literally cannot entertain it. I mean, I'm talking about they would swear up and down that they have, because they've been here for 7 years. So they've definitely entertained it, but they haven't. A good example is I brought up a new argument last couple of days. It's like they said that the Earth was gradually slowing down over time, and although there's a change in the speed, we wouldn't feel it because it's so small, it's negligible. And they've now said that the Earth is spinning faster, and they say it's mysterious, and they haven't figured out why. Like the top level of academia and in the globe paradigm doesn't know why, but they know it must be this way because the stars and the sun are moving faster. The days are shorter. So that means actually it must be the Earth moving faster, right? So when I tell the Globers that, and I'm like, you have to have some type of mechanism to introduce additional energy. You need like more energy added to make the Earth move faster, or that would violate the law of conservation of energy and momentum. Technically, you can also have a change in the distribution of mass and keep the same amount of the energy, and it would move the different mass faster, right? But dude, it doesn't even like, they don't sit there for 1 second and think, oh man, is like, well, maybe the Earth's not a globe that spins. Like it's like not even like on the table. That's why if you're talking to them and they end up getting to like this concession point and they're like kind of playing like an apologist position to, well, maybe this or this or this. They're like, okay, like Mickelson Morley is a good example, right? You ask them, well, what's the other alternative? The obvious one, it's always obvious, right? In that situation, it's that the Earth's not moving or whatever. They can't even articulate the primary alternative of the debate. I'm all that to say, I don't think that they can actually entertain it. Like what's the famous saying? I don't like the word educated, but it's the mark of an educated mind to be able to entertain an idea without believing it. Right? Like they can't do that.
Yeah, because that's what would be like, to not have it fall into a cognitive dissonance situation. You do have to like fully entertain it, something different, just in general. Yeah. Otherwise, if you don't really fully consider it with all honesty and all reality in that sense, then the likelihood for some would be to just stay in the other one, because venture, like, to consider it would be to then have to face that cognitive dissonance if they have any. and perhaps in a lot of cases just don't even want to just even take that on. So it's like they haven't even begun the journey.
That's right. So like for me, I began the journey as soon as I heard about it, because I was already at a stage in my life where I'm like, and I heard about it delivered with a lot of the other info that requires you to kind of have like a paradigm shift, like B.O.B.'s Elements mixtapes. I knew, I didn't learn about any conspiracies other than like cloning, I think, from him, but I'm just saying, like, I already knew about the Federal Reserve at like age 14, and I knew about the moon landing in 9/11, like 13, 14, and I fell down a rabbit hole at 14 years old where, like, from that point forward, I always knew it was possible that what everyone believed could just be completely wrong. So I don't know that they did that. So like when I heard about flat Earth, I was like, oh yeah, like that's crazy. I think that sounds dumb, but let's see what this is talking about. You know what I'm saying? Like and then when I started to see that there were no real pictures, I'm like, I was just very open to the possibility that we were lied to about where we live. And I think that's a fundamental difference here. That's why I think that, like, I've really shifted over to flat Earth's not for everyone. You know what I'm saying? Like, it's just not. I mean, there are plenty of people it is for, but there are people that it's just simply not for them. Certainly, or as of now, I don't think that they have the mindset to look at flat Earth.
Well, there definitely seems to be a spectrum between people who, once hearing about it, will just be like full-on resistance. Like that's all it is for them, is just resistance in their own mind, the way they project themselves to others. But they're like fixated on it or addicted to it in the same way. And then you get into all the psychology of that. Or it seems like on the other side of the spectrum, people are completely willing to consider other ideas, or at least be willing to like put the other one that they had on pause to really take on or consider something different. It's like just complete resistance on one side, or an openness to actually look at the information as fair and balanced as possible to see if there's really something to it. And then you get into like the one's ability to actually discern the truth out of it.
So the easiest way to tell if this is the case is straw man fallacies. If everything that you say to someone, if the baller responds with a straw man version like consistently, and then once corrected the next day, they'll straw man how the sun has to work on a flat Earth and blah blah blah. There's really no debate. They have cognitive dissonance. They haven't been able to entertain it. I think the easiest way to really figure it out is just ask them to still man your position, and they can't do that. You know what I mean? I think that you should be able to still man both sides of a position before you're even in like a situation to make a determination. You know what I mean? Like I can still man the globe so good, dude. Like it's kind of insane. And the ballers always say that they don't buy it. And then I'm like, okay, ask me any question. Or like I get tired of hearing them bumble around, so then I'm like, look, here's your position. You know what I mean? Like I know the globe's position with like an annoying amount of subjects. Like to a very precise, I can articulate it very well. I could even be convincing, I could convince people it's a legit answer. And I don't think they can do that, bro. The other way around. And when I say they, it's obviously a generalized conversation, but just think about it. Zanuck cannot do that. Zanuck and Kosho maybe is one of the better ones. He can't do it really either. Zanuck cannot still man our position.
Yeah, that's interesting, because that is like a indication that they are actually looking at both sides. Because one thing I noticed with the straw man thing, where people will like they'll make these blanket straw mans. Like, oh, you guys, or you flat earthers, whatever term they want to use, like you guys all say this. And it's like, they may or may not have heard someone say something like that at some point, but it always seems like the way that they describe it in my mind, I'm like, I kind of doubt anyone's really saying it that way, you know, or even meaning what they're trying to say by it. And then they use that as if it's just like a set in stone, like, well, you say this and therefore everything else you say is wrong. It's like a blanket straw man, which would make sense if that's connected to cognitive dissonance, because instead of actually considering the other sides, they're just instantly sticking on something and then trying to kind of like ridicule or call that thing out without actually coming to the table with an actual intellectual breakdown of whatever it is they're actually pointing at.
Yeah, like think about it. So one of the big ones with the Globers, they say like Southern Star Trails, right? Now, many of the people in here, they've heard like many alternative explanations for the star trails, right? Like you can literally just look at like a dome over circles on a piece of paper, dude. You can also look at the idea of like a azimuthal grid of vision, and it would literally cause that effect and stuff. So there are some people that think it's like a magnetic field and blah blah blah. So there are explanations. Like the dome shows it. The dome over the circle show it, bro. And so does the azimuthal grid of vision. Anyway, if you ask them, right, like the veteran ballers, if you ask them, well, what's like the flat earthers' answer for that? They will say, I don't know, they don't have one. You see what I'm saying? Like their brain doesn't register the information. It doesn't register our position.
Yeah. That reminds me of one person. I'm not going to call them out just to be respectful in that sense, but they always come in and ask about the Southern Star rotations. It's just what you just said. I've explained multiple different ways that could be occurring over a stationary planar Earth. And I've also shared my multiple viable potentials. And every time they come in, they just say the same thing. Every time. There's two poles. It has to be a globe. Flat earthers have no explanation. Zero. So, you're hot miking Turtle Plane.
Yeah, bro, it's crazy. It's played out. It's like really lame and boring and just stupid. Like, yeah, I just talked to someone again today. They said the same thing that like literally hundreds of people have said to me, and that is that they woke up to flat Earth from my debates, but it was mostly the globe side's behavior. The way they argue, the way they misrepresent, the way they always change the subject or move the goalposts, and how dishonest they are, and how rude and arrogant and derogatory, and how they appeal to emotion and gaslight, and blah, 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 blah. Like, dude, they all say that. It's not that. It's just like, they're like, wow, if you have to, if this is the only way you can defend the globe, there may be something to this, right? And it's like, I just talked to someone today about it. It's like every time, bro. Every time someone reaches out to me, they're like, they bring that up. It's very interesting, right? So it's like, I think this is the same way. If you've been in this conversation for 5 years, bro, and you can't still man like flat Earth, if Zanuck can't still man my position for just about every flat Earth topic, because I talked to him like an inordinate amount of times, then that goes to show you something, right? I mean, I guess technically speaking, they could know the real position, and they're tactically dishonest about it. And it may be a mixture, but I think it's deeper than that. I think that they can't, it's like their brain isn't in a position to receive and register, much less like retain the true plain Earth position. So it's like, should we really be like mad at them, or like, are they like our enemies or something? Like, no. You know what I mean? Like they don't know. Like my baby's 2 weeks old. Like I can't be mad at her for like screaming when she's hungry. She doesn't register what it means to communicate. You know what I mean? Like what for me to be mad at her would be ridiculous. So I think if we look at it like that, it'll begin to start making a lot more sense. It makes a lot more sense to me where I still work on this. It's definitely something I struggle with. Like I get upset with them, and I automatically default to them being dishonest because it's just so abundantly clear to me. I'm like, you know what I just said. You know what our position is. We've talked about it 30 times. How are you going to come back here the next day, like Groundhog Day, like you have amnesia and you don't know? But I'm starting to realize that they may not actually know. Like the next day, they may not know because it just never registered with them in the moment. I guess definitely the case for Zanuck. Zanuck is prepared to speak the second you get done. He's not listening to what you're saying. He already knows what he's going to say. That's why he so consistently talks past you. I think a lot of them are like this. I think it's just crazy. I think it's like a crazy psychological thing. I don't think it's just the Earth either. I think that people that took the jab are like that. There's a lot of subjects that people are like this with.
Yeah. Well, it reminds me of that in the Bible, forgive them for they know not what they do. I think it's Luke 23:34. So yeah, it's, in some cases, no, I do hear what you're saying. Yeah, with that as well. Yeah, Zanuck does. He seems to, it's like he's listening for trigger words, and then he's just thinking of what he wants to say with those words and how he wants to project it, and it's often not like an actual receiving of what actually, like an actual back and forth. Yeah, I mean, that's why I usually don't get super engaged with him myself, because I just, it's like sort of like there isn't an actual, in a lot of cases, like a back and forth happening to where there's something very real about sharing ideas. Like if you throw a ball, it's almost like playing catch with someone. Like you throw the ball to them, they take the ball, all right, and then they throw it back. Like you have to actually like engage. It's like the difference between when someone's really listening or they're not listening. Like that can actually be felt. Like there's an actual dynamic to that. And so, yeah, like if someone just isn't listening to you and then they're just repeating something or just trying to project something, it's almost like just listening to a loudspeaker rather than actually feeling like there's an actual engagement happening.
Yeah, it's like they interpret it like white noise. You're like way better at that than me. Like, although I know there will be no fruitful conclusion with the conversation with Zanuck, it's like, and dude, I'm not like they do it on purpose, bro. Like they've engineered scripts specifically tailored to provoke me. You know what I'm saying? Like they so grossly misrepresent what I say, and combined with like these like false accusations of word salad, and I regurgitate other people, and I don't understand the things I read, I just say them and all this stuff, right? Where it's like my pride, right? I end up being like, I have to correct them. I must correct them, It's like it's something I really struggle with, to be honest with you. Like it's like a problem, but I'm trying to work on it, man, and I think that like a part of it is kind of what I'm talking about, where I've always kind of assumed malice and do not attribute malice to that which can adequately be explained with incompetence. And I think in this specific scenario, incompetence could be changed with the word cognitive dissonance. And I think that, yeah, I mean, it's just been a very, very refreshing view of it for me in a way where it's like, like just like you said, like they know not what they do kind of thing. I don't know though, bro. Let's be real. It does seem like they have to know what they do a lot, right? When I say they, we're just talking about like the anti-flat earthers, right? They know, bro. Like if they were like tied down with a gun to their head and they were told to still man our position and they were asked 10 questions, I mean, you don't think they could do it? Because like I don't know. Like I think they could do it, but I'm starting to think maybe they wouldn't, man. Maybe they couldn't. Yeah.
I think most of them are colorblind to the topic.
Yeah, that's like a lot. That's what we're basically saying. They just like don't register it.
I also think that like I also think that like now that you have a daughter and you're going to be a really, really tired new parent, that it'll actually give these assholes a chance to catch up with what the fuck you're saying when you speak, because you're going to be too slow for them. You're going to be talking so much slower. They're just going to you'll have to sink in. You know what I mean?
Yeah, maybe. I get mixed reviews about that. Some people say that they like when I talk fast, and some people, even
No.
like flat earthers, say they don't.
Like I get it. I hear everything you're saying, but like to people who are just totally mentally detached, it just breezes right by them, you know.
My message is not for them though, right? Like,
I wouldn't say that. You know, I think there's some people won't get the message, but like to just blanket say that it's not for them, that's kind of like a judgment thing, right? Isn't that for God to do and not us to do?
well, I mean, if you're asking me my opinions about God, you know, like I default to scripture. So like the scripture would say, you have to know when to dust your feet off.
Yeah,
So
definitely know your time has value. Like it may not be you who does who spreads that message. It may be like it may just be like somebody who just figured it out today, you know. It may not be you.
yeah, or like their cousin or their
Yeah, their
colleague.
mom or dad, whatever.
Yeah, like it was like my time is about to be much more like portioned out, right? Like it's because like of course I have my daughter, and I also am like Jaren and I just started a business and starting a couple other things. So I like Airplane. Where are you at, man? You at Epcot or
But
something?
it's
Different countries.
is that here?
Yeah, that was Turtle Plane again. He just sent in a text that he was good to not hot mic, and then he hot mic'd again.
The fuck?
Oh yeah. Anyways, I'm just saying like I would rather reach new people. Like I think that I'm gonna launch a channel where it's like Kai talking a lot and not about the Earth. I think I'm gonna start to. I've done this out in here. I think, but I'm gonna start having like meetings where we just all organize and we launch different types of channels. I'm gonna start like a true Earth audits business. So it's like First Amendment audits, but it'll be true Earthers. I just think that there's I'm in 2 documentaries this year. I want to do 2 documentaries this year myself. I just think that I think that's my energy is way better used that way.
Yeah, I wouldn't spend any more time talking to these guys unless there's something you really need to. Like, you know what Dan does? Dan will just like throw out some information, and then he'll use all the ballers to basically do the baller research for him. So he gets all the like best links and the most latest answers. So like he just totally delegates to these assholes, and then they bring him all the information.
Well, that is what. Yeah, that's also how I look at it. Like they're my employees, basically. Like I definitely have greatly benefited from them in that way. It's much easier, right? Than like trying to go to the mainstream. The mainstream's like 3 years behind, if not more, to this stuff. And you go ask Kosho, Bacon, Zanuck, like you're gonna come back with like their school reports, like their apologist school report. So yeah, it's beneficial in that sense for sure. I tell Jaren that all the time. Jaren's like, "Do you know what the Glovers just say about this?" He showed me the video of the Orion just disappearing. I'm like, well, give me a couple days, I'll tell you exactly what they can come up with.
Yeah.
The best they can
That's a
come up with.
pretty fire clip, though. I mean, it definitely shows that there's 2 different layers. One's disappeared, and then it comes back. If I'm thinking about the same clip, anyway.
Yeah, I mean they did. They definitely started coming up with stuff, man. I think Gio was in here one time. They'll definitely come up with stuff, but yeah, it's whatever. I mean, they're useful for that, but at the same time, I don't know. Like the average person that's like not really looked into flyers, whatever. Like they're not hearing that, bro. Like they're watching the Big Think video with Michelle Thaler and Neil deGrasse Tyson and stuff. They're watching like maybe a Professor Dave video. They're not really hearing like Zanuck, Kosho, and Bacon like tag team in and out of conversations, save each other when they misspeak, and like frantically Googling any little narrative to save their position, then pulling in JAs and then appealing to his credentials. And, yeah. It's like you would. This is not where you want a new flat earther to come. Like you would not want a new flat earther to be around those people, dude, because they're just gonna brainwash them with like they're gonna.
Well, the problem with these rooms, like, and you highlighted it a little bit, but like the biggest problem is that you guys just everyone talks about the fringes of the made up science, which nobody is familiar with anyway in like real life. So, like flat Earth and conspiracy in general, it's a lesson in history. It's connecting the dots. It's showing how they started with these numbers and then they came out with these numbers later, and that the people who presented the ideas weren't even behind their own idea, that they were propped up later by people with money and power, and they were constructing a story using all these individual it's literally a lesson in history that you have to build up to, and it starts with the foundation of how they started making the reality spherical in general, and then changing that around and always shuffling around as if it was a question. Like, has anyone ever just asked the question, like, what's the shape of the earth? No, it's the question that they gave you, and it's the confusion that they gave you, and that's the history lesson. And it's just